Hello, Gaurav. Gaurav, we can't able to hear you.
Rajesh, can you hear me now?
A little bit louder, Gaurav. Voice is low.
Okay, let's see if you're able to hear me now.
Perfect.
Okay, great.
Hi, Gaurav. How are you?
I'm doing good. How's things for you?
Yeah, doing good, Gaurav. It's my immense pleasure talking with you, and I'm really proud. I'm talking with the great person today in the very first event of my session. It's a Gaurav. So really, I'm very very proud for that. So before we get into the our sessions, let me give some short brief about Gaurav. Okay. So
Sure.
Gaurav Agarwal, he has a complete focused in helping of tendency, and plus he has worked in the cyber security and digital transformation, which leads as a leader. Plus he also expected to be the everyone, and for from layman to the large people of times he needs to be coached from the chief architect. So in a short summary, Agarwal just come up with the architecture to from sorry, it's a consultant to its architecture. So it's a great path and a great travel and a great steps has been come across in his life. So really, we are very proud to be welcome you in the very first session of our day two, Agarwal. So once again, welcome again,
Yeah, thank you, Jyotish.
and the stage is yours, Agarwal. You can carry on.
Thanks, Jyotish, for the introduction. And a good morning for folks, everyone. Thanks for joining the session. And during the next 40 minutes or so, I'm actually going to talk about something what I call as a digital architect, a new persona, which I think is going to define how the future is going to look like for solution architects. So the topic for the session is talking about a new persona, what I'm referring as digital architect, and there is a background to this.
Yeah,
Uh,
Gaurav. Yeah, sorry to interrupt here. We couldn't able to see you. Yeah, perfect. Yeah, please carry on, Gaurav.
okay, sure. So guys, this talk is about a new persona that I see is going to define the future role for solution architects or cloud solution architects going forward. And the hypothesis there is based on the way digital transformation is defining the current business requirement or the way things are moving within the digital transformation world for majority of the customers globally. And with that context, let's look at what does this mean. I would say right now we are seeing a digital revolution, and the COVID actually accelerated that aspect. So while digital transformation, digital revolution was going on, I would say COVID probably accelerated it manyfold. And that's fair. No, I would say Satya Nadella quoted about saying we saw 5 years of digital transformation in 5 months, and then we saw a statement talking about similar stuff uh, for 10 years in 10 months. But similarly, for a similar survey that was conducted recently, what came across as the top 10% of leading digital organizations, they actually saw 5x faster revenue growth than their competitors. And so what's different? What those organizations was doing, what was their readiness that they were able to grow even in this tough time of COVID? I would say they were a little bit ahead in terms of their digital fluency, digital readiness, how they reacted to the opportunity that the COVID challenge threw at them. But more than that, the standardization those companies had with respect to adoption of cloud or the way they were thinking about leveraging cloud as an innovation catalyst. Those are the aspects which this companies was doing. But other thing which I want to highlight here is those were the companies who understood cloud economics. They rotated their solution architect persona into the true sense of cloud solution architect way earlier. But in last 12 to 18 months or so, they probably started transitioning those personas into a new persona, digital architect or digital solution architect. So what this new persona is about? So what does a digital architect would do differently as compared to the known personas of solution architect, cloud solution architect? And I'm sure there are people who would try and correlate it back to that, how this new role of digital architect would work with some of the other roles of maybe enterprise architect or some of the other roles which exist there. I would say, imagine digital transformation is happening at a fairly fast speed, but that requires very specific expertise, set of practices that align business focus with technology solution. So it's no more about saying, hey, I'm a technology expert. I can bring you the best possible distributed architecture or a possible solution for a given business problem. It's more about thinking, do you understand the digital journey aspect of it? And if I go back, it's like probably if I go back to 2008, 2009 timeframe, there's a time frame when I started defining a persona called cloud solution architect. And that point of time, it was all about solution architect as the role in the industry. And as public cloud started rolling out, that point of time, I started creating this new persona, cloud solution architect. And then in, soon I started defining the persona of partner cloud solution architect. And very similar to that, it's like based on my market survey, my market study, I think going forward, the role of cloud solution architect would have to transition. So I would say think about the window from a timeline perspective, 2009 to 2022, probably another 12 months or so, cloud solution architect role is still the most sought after role. But it has to transition. It has to transition into a version or a perspective which is more aligned towards digital architect. And that's what I'm going to spend the next 30 minutes or so in defining what is different in this new persona that I think would become the de facto role for customers or businesses that want to be successful in this digital transformation world. And the way I think about it is based on my past experiences. I think digital solution architect or digital architect would be the future. They would be leading the practice and introducing the overall technical vision for the digital transformation of large businesses. And on the right side, what I'm showing you here is that initially the architect role had different perspective to it. Over a period of time, roles like infrastructure architect, application architect became more like a subject matter expertise. They had their own role, but then businesses needed somebody who could stitch the conversation, get the infrastructure architect talking to application architect or application architect talking to a database architect. And that role became known more as solution architect. Enterprise architecture existed, and that I'm sure is going to continue, but there is going to be a huge amount of redefinition of what an enterprise architect role would look like. But with the advancement of public cloud, especially when Microsoft entered this area, started democratizing public cloud, uh, the role of solution architect transitioned to cloud solution architect. And going forward, it would be about digital architect. So let's look into what does a typical responsibility for a digital architect would look like. So I would say a digital architect would be the one who would be leading the digital initiatives and the teams, both from a business perspective, but also from a technology perspective. They would be the one who would be driving the change. They would be the one who would be creating the new business opportunity along with the business owners. To start with, based on the maturity of the business, it could start as simple as saying accelerating digitization, and accelerating digitization to a level where it is just not about saying, hey, can I do a e-discovery or can I do a forms recognition, but taking it to a different level with digitizing every aspect of that business. But more than that, translating the digital transformation roadmap to the digital application solution plan. There is a slight difference that businesses need to understand there, that majority of mature businesses understand they need to go through this digital transformation. Majority of them also have a digital transformation roadmap, but somebody needs to transition that roadmap into an application or a solution plan. And the role of digital architect along with enterprise architect would be the one who will be best positioned to do that. Now, while you have a solution plan, that's fantastic thing because you have a strategy, you have a execution plan for that strategy. But that digital transformation would be successful only if you are able to envision the new user experiences, or you are able to define the new products and services. And when I'm saying new products and services, that also includes the aspect of new commercial or business model. And the traditional role of cloud solution architect has a few capabilities, fundamental foundations for it, but you need somebody who understands more of financial engineering than what some of the existing roles understand. Somebody who understands the new generation, how does generation X to generation Z would use those applications, what those interfaces would look like. Or how do you start envisioning user experiences, which cuts across the physical forms to the virtual form, hybrid forms, or for that matter, I would say a format of AR, VR, or mixed reality. So looking at that kind of experience, converting the solution plan into the user journey or a customer journey. And that's where a digital architect role would have to pick up that skill. The previous roles would have to transition. Now, the same role would have to start owning the end-to-end journey. That's what I'm reflecting as leverage technology to accelerate digital transformation. But in this journey, there is going to be an aspect of technology change management. That's what I'm talking about as transform process and technology. It's just not about defining the new experiences, new products. You would have to transform your existing processes. And that's where I would say the pandemic made the things go much faster, because what pandemic allowed us that now architect can question all the assumption that existed in any business for last 20 years, last 25 years. Businesses are open to try out new things. You could challenge all your assumption that was a complete no for making those changes. And that would inspire some of the strategic goals. But since most of this new application, new scenarios are going to take some time, they are going to take some effort. And that's where some of the technology advancement in the domain of hyper automation. So a digital architect would have to own the aspect of hyper automation for the coexistence duration of it. Now let's look at typically in this domain of architect personas, architect role. Most of the time people talk about a perspective of saying there are 4 architecture domain, right from business architecture, data architecture, application, and technology architecture. So how does, let's talk about how does the existing role of solution architect and enterprise architect, and where does digital architect role would fit in. I would say digital architect role is a perfect fit somewhere in the continuum of solution architect and enterprise architect. Typically, a digital architect would be somebody who have a fairly good understanding and experience with business architecture, but fairly high experience on application technology and data architecture of it. So it's not that I'm saying a digital architect is a unicorn, but somebody who understands how your data is going to get captured in the application and how your application is using the technology for trying to solve a business problem. But within this, how does then this role fit into from an enterprise architect perspective? I would say enterprise architect is a persona which understands business processes way more, but probably doesn't go that deeper onto technology architect. And that's why I'm saying digital architect persona would fit in between a solution architect and an enterprise architect persona. The other thing, the architects ask me, a lot of customers ask me is, that's fine, we understand how digital architect would fit in or close the gap between solution architect and the enterprise architect persona, but how about the scope? Who is going to do what in my enterprise or in my business? So from that perspective, let's look at how does typically from a scope perspective, a solution architect or the other roles look like. I would say at a very high level, solution architect has been owning the solution design. They have been applying the technology for providing the solution, just not from a what is my technology architecture, deployment architecture, but also looking at the operational aspect of the solution. How does that solution would fit into the enterprise standards? And then as public cloud came in, that persona had to learn few more things. That's where in 2009, cloud solution architect became such a prevalent profile. So solution architect of the past had to understand how do you apply cloud economics? How would you define your journey to cloud with respect to migration, respect to transformation? But just not that, how would you define your journey in the cloud? So there are two aspects there that a good cloud solution architect had to do. And within that journey in cloud, most of the time it meant you have to understand the cloud native principles. How do you use cloud native capabilities to provide the scale, the business agility that cloud could offer? And they had to understand the scale and resiliency completely at a different level. And during the same time, enterprise architect persona was getting a little bit redefined with respect to saying somebody who is defining the enterprise strategy, looking at the enterprise-wide integration, standardizing the processes or the technology continuum catalog there. And somebody who was responsible for cross-group collaboration. Going forward, that's where I said digital architect is a new persona. That's a persona who's going to design and model the digital journey. So that's a new skill. So existing solution architects, cloud solution architect would have to start building this new capability of designing and modeling the digital journey. They would have to streamline the solution supply chain, or maybe in a simple term, how do you define your release management or the entire DevSecOps process so that it's just not about your solution, but also the entire supply chain of surround solution. And they would also would have to be the bridge between the business and the enterprise architect and solution architect persona. That's the perspective I listed down cross-group collaboration there. So it's not cross-group across the organization, but definitely somebody who is acting as a bridge or a translator between business, the technology subject matter expert, and the enterprise architect who is defining those standards. So let's look at if I have to summarize what does a digital architect look like? Uh, I would say a digital architect is a persona which is a solution architect, but somebody who is developing a skill to think about or a mindset of product and platform. Because to be successful in the digital transformation world, it's just not about providing a solution. You also would have to start thinking about how would you monetize? How would the customer journey would look like? Is there an aspect of creating the solution as a service or as a platform? And that's where the aspect of growth mindset and a value creation as a foundation skill would come in. Now, definitely, a digital architect needs to have the cloud first mindset, very similar to a cloud solution architect. But taking the skills of cloud first mindset along with financial engineering, a little bit aspect of domain driven design, and the domain driven design is important because that's where you would start thinking about creating a well-crafted API-centric architecture for those solutions. And in today's time, I would say a digital architect would have to understand the aspect of sustainability. Sustainability from a perspective of how does cloud help you in making your solution sustainable, but also the aspect of leveraging the new digital solution using public cloud to create new business model which helps in sustainability. So new products which allows customers to save energy, save water, or aspects like that. So think about leveraging sustainability as your business lever itself. All that with a perspective of cybersecurity and compliance upfront, that anyway was an expected skill from a cloud solution architect. So what you're seeing on the slide, a little bit of a color coding, that's what I've been following across a couple of slides so that you know what are the new things that a digital architect is doing. Let's go a little bit deeper onto some of this aspect of capabilities of digital architect role into converting that into what I call as a skill metrics. So if I have to talk about saying how does a skill metrics for these three roles that we have been talking about as a base, uh, that's where I would say a digital architect would need to understand the big picture and the purpose of the business. That's what I'm reflecting as a business domain level there. So they are not the one who understand each and every piece of Lego block within that business process, but they need to know what's the purpose, what's the big picture. They need to know what's my digital innovation and insights, because that would be important to highlight those, bring those aspect through the new solution that digital architect persona would be responsible for. But for digital architect to be successful from a skill perspective, they would have to understand the human-centric design or design for people. And that seems easy, but it's a tough skill to acquire, because you would have to think about how do you cater to your target audience, and the target audience has a completely a different way of interaction. And in this virtual hybrid workplace world, a lot of new scenarios, new user interfaces came up. All that can be empowered by the emerging technology, which I'm sure all the architect personas are trying to build their capability or skills around emerging technology. But for a digital architect persona, I would say two things that I want to highlight, or which I think would be very, very important for them to build, would be aspect of storytelling. A storytelling which would come over and above the human-centric design. How do they create the value, or how do they think about and develop the data and digital fluency? And this digital fluency is a key perspective there, because a digital fluency is going to decide the product or a service that you're bringing to the market. Would it get adopted or not? How would customer would get onboarded to it? So how do you think about enabling your target customer audience, or for that matter, your own internal employees? And for that, the digital architect would have to think about, is there a readiness for digital fluency in their target audience and stakeholder? If yes, fantastic. If not, they would have to think about how would they create or do the enablement or evangelism for digital fluency for their stakeholders and customers. Now, for other thing, which I would say, as I said, this role has to be a bridge between solution architect and enterprise architect. That's where the understanding of the entire supply chain and enterprise architect framework would be very, very important. Uh, do they need to understand all the aspect of maybe enterprise architect frameworks like TOGAF or any other EA framework? They don't need to be expert on it, but they should be able to translate or be the bridge between the two personas. Now, this might seem like too many skills, too many different responsibilities, um, which sometimes I see people saying that that's not possible for one person to do. Uh, And that's what I'm going to transition into, that what are the critical skills, because it's going to be a journey. It's not that a cloud solution architect would become a digital architect the next morning they wake up because now they know there is a new persona. It's going to be a journey, and that's what I'm going to spend my next 15 minutes or so talking about, the learning path for digital architects. Let's look at what those critical skills would look like. I would say three critical skills. You need to understand the customer value. You need to have the digital innovation mindset at the core. And it's not about that you need to build those skills in each of those areas. What you need to do is you need to build a network of competence. You need to know who is the person in your network who could deliver or bring that value to you. And all of the skills would become easier if you're able to do experimentation using agile pod. So if you want to transition from solution architect or cloud solution architect to digital architect, I would say focus on thinking about what is my digital innovation journey going to look like. Develop that mindset. And I will spend some time about what that digital innovation mindset looks like. What does it mean in terms of day-to-day life? And building the network of competence. So let's look at a core aspect of what does digital innovation mindset look like. So I'll give you a few examples with respect to what typically people do today versus what a digital architect should be thinking about when they're taking a digital decision making. So see, today most of the successful CSA solution architect, I'm sure, keep customer at the core. But a transition from a digital decision making is, it's just not about having customer at the core of your solution. It's about keeping the customer journey and experience at the core. So just not about saying, I know who is my customer, who is my stakeholder. That's not sufficient. For your digital decision making, a digital architect needs to convert that into what is going to be the journey and the experience for my customer. Another example, it's like as a solution architect, you're seen as somebody who solves problem and solves problem in a repeatable manner. So on the slide, you see something what I've reflected as do X to all. So if there are 10 problem or 10 things of a particular category, you start applying a particular solution. Now doing X to all has to transition into how do you disrupt so that you don't end up with similar problems, or if they happen, how do you hyper automate? Another example which I take is typically a CSA or a solution architect has been talking about, let's make a solution simple, let's consolidate, let's optimize the application portfolio. I would say that aspect has to change. So it's just not about consolidating, because it's not that just because you consolidated your application portfolio, you achieved something which is a better outcome. The perspective, the transition that has to happen is, if you're consolidating or if whatever decision you take, are you reducing your technology debt? And the decisions that you are taking, if that is helping you in reducing your technology debt, that's going to help you in defining the overall digital transformation. And most of the time, when you start thinking about reducing your technology debt, you will start innovating. The other aspect that you see here, which a digital architect would have to think about, is typically CSAs has been thinking in terms of, let me build something on top of what already exists today. So it's more about creating wrapper, or maybe talking about applying sidecar architecture or pattern to the existing application, or sometimes even just applying and creating APIs for the existing solution so that you could be more agile and create new interfaces. Um, I would say that aspect of build on top would have to transition into what I call as build for future, and do a co-creation with your supply chain or your ecosystem. So going forward, I do see a digital architect would have to think about whatever they are building is just not about saying, let me make it easy, let me reduce technology debt, but also Are you building the solution for the future? And a lot of that would happen with a multi-party decentralized architecture. That's what I'm reflecting as a co-create there. Then the aspect of validated assumption. All of us for ages has been documenting the assumption, and a good architect would have always validated those assumptions early in the process. I would say the mindset change has to happen there. It's just no more about let me validate my assumption. I would say a digital architect would have to reimagine and revisit the assumptions. So you don't have to live within the assumption set that you defined or a company had for last 20 years or so. Do a reimagination of what the new word is going to look like, what my new process would look like, and revisit your assumption. And COVID made the life easier because businesses had to react at the speed of trust. And that's where they reacted, they invalidated a lot of assumptions. So I would say a digital architect would have to make that change. Other thing, most of the time, a cloud solution architect or a solution architect thought about let me make this solution work one time. Let me create the best possible solution upfront. Now that aspect would have to change again from a digital decision making. That it's no more about getting the best possible product upfront. It is going to be about a minimum viable product with a continuous roadmap of releases and a continuous improvement perspective to it. So I would say that's what at the core of what I call as digital innovation mindset. And if you as a solution architect or a cloud solution architect are able to apply this simple shift of digital decision making, you would start your journey to be on this path of what I'm referring as digital architect. Now, quite a few people actually ask me that digital decision making and things like that is fine, but at the core of it, does our digital architect needs to understand or define the digital business? I would say it's not that digital architect is defining the digital business. That's probably a mix of your business owners, your CXOs, along with the enterprise architecture team. But primarily, I would say that's about 5 building blocks. It's about, do you understand the digital business value? What are the new technology and the new operating model that the business needs to do? But these 3 new building blocks would be able to work together if you figured out how does your digital identity or your identity for authentication, authorization, or developing that trust with your customers are going to work. Um, and sometimes that manifests as a conversation as zero trust. I would say digital identity is at the core of zero trust architecture. So when you're looking at a digital business, a 30,000 feet view, I would say you need to have a digital foundation. That's where aspect of digital decoupled architecture, migration of journey to cloud or journey in cloud would fit in. And how do you convert that foundation to be more resilient, more sustainable? And if you could get your digital identity perspective right, you would solve the challenges in this continuum way more faster. And that also brings me to the aspect of saying these are too many things that this new persona would have to do. So what are the corresponding changes which are happening in the ecosystem which would make this transition easier? So the best part is it's just not about saying digital architect is a new persona, but most of the businesses right now, or rather I would say in last 18 months or so, has been going through a change from a perspective of a hierarchical organization to creating a global strategy with a regional leadership, or in a way, a leadership everywhere, where you are making the people accountable. And that shift in the organization strategy, organization change management I would say, is a key lever which would make the transition of previous personas to digital architect easy, because everybody is looking for what can be done differently. So you are not alone when you are making a transition from solution architect or a CSA profile to digital architect persona. Now, as I said, too many skills, too many perspective. I strongly believe all those skills or capabilities can be easily bundled into 7 foundation blocks. And that's what I'm showing you here, what those 7 foundation blocks are. That's an aspect of saying, do you understand what does it take to have a good digital transformation strategy and innovation? And I'll walk you through a couple of quick frameworks which I would recommend for anybody who wants to start with this journey. I would say cloud first mindset is fairly good, well understood. There is a lot of capabilities which are there in the market right now, or even the aspect of cloud adoption framework or well architected framework that you would see from Microsoft or other hyperscaler providers too. Um, then understanding the aspect of emerging technology and trend, that's an important aspect which could also be combined or merged into technology change management, but both of those has to coexist. This persona would have to understand those two things. Within this, the other two are fairly self-explanatory, because you want to be an architect in this architecture domain, so you need to have a good understanding of what are those new architecture patterns that you would require in this new digital world. And all those architecture patterns would probably start converging into what I call as pillars of future composable enterprise. Because going forward, it is not going to be about one single large solution or one single large platform that gives you the future business. Most of the businesses and enterprises would have to start looking at those smaller composable components in every aspect of their business. And the most important aspect that I've been talking about through this entire talk is about human dynamics, the core soft skills. And I would say it's something beyond, which is about keeping that journey aspect at the core of it. Let's make it real. Almost like sometimes even if you're saying there are 7 skill blocks, what are the key fundamental questions that a digital architect should be answering? I would say on this learning path, the easiest thing that you need to start asking is, who are my future customers? So it's just not about understanding who is my current customer. You should be able to identify who are your future customer, because that's important for you to keep and define the journey that your future customers would go through. Then an aspect of looking at, is the business going to delight the customers anywhere and every time? Now, the aspect of anywhere and every time is important. Earlier, I would say that people always spoke about delighting the customer every time. Going forward, I think digital architect would have to think about anywhere, and that anywhere could be the last mile delivery or last mile reach to. Then also the aspect of who are your future competitors and partner, because going forward, it is just not about saying, hey, I already had a good market share or a market capture. Because what has happened in last 18 months is the buying pattern of customers has changed. It's no more about saying this is the best possible product in the market or customer loyalty, but customer buying pattern is shifting to what is available locally. What organization is doing from a corporate social responsibility perspective? Is the product sustainable? And that's where a lot of new partnerships are coming, a lot of new competitors, new business models are coming. So for a digital architect, you would have to understand who are your future competitors and partners. And sometimes it could mean establishing those partnerships upfront within your supply chain. And if you are able to answer those questions, you start documenting some of that, then you would have a visibility to what will the business become over a period of next 2 years, over a period of next 5 years. Now, if you want to be on a journey, I would highly recommend that on this learning path to become a digital architect, think about using a skills framework. And one of the framework that I have been talking about or I've been experimenting successfully is this two quadrant thing where I put everything about reimagining the digital transformation path. And on the x-axis, it's more about what I'm going to renew, what I'm going to extend, or what I'm going to redefine, or what I'm going to transform. Because as a digital architect, it's not that you have a magic wand and you would be able to transform everything. Because at the end of a day, everybody is living with a limited set of resources. So you still would have to do things which is about what you are going to renew, what you are going to extend, what you are going to redefine. But when you are doing this, the other aspect is how are you reimagining or how are you reading your operating model? Or how are you looking at the culture or the how part of this entire journey? And within that, when you are on this plot or the graph, when you're defining renew, redefine, transform, I would say think about, are you going to build something? Are you going to leverage something from the existing portfolio or existing solution? Or are you talking about integrating the existing solution with something which exists or somebody else who has created? I would say across the how part and the what part, most of the organization would end up taking multiple paths, and that's what a digital architect would have to figure out and say what parallel work streams you are going to run. And on the picture that I'm showing or the chart that I'm showing you here, um, the three different paths, whether you started on the path of transformation for some of your future business model, or you started reducing or taking a path of reducing your technology debt, or even the most simpler aspect of renew or redefine through an API strategy. All of that is going to start taking you more closer to the transformation, the end goal that you need to achieve. So that's one single framework that I would suggest, that easy to use, but any solution architect or cloud solution architect can start leveraging this to start developing the digital innovation mindset that I've been talking about. Let's progress a little bit further. Let's make a little bit more understanding about if digital transformation is a big buzzword. Rather, I would say it's probably the most abused buzzword being used right now in the industry or in business domain. Um, One thing that I suggest to most of the people that I work with is have an understanding of what does a digital transformation mean, and that's where I really love what Dr. David Roger brings in terms of 5 domains of digital transformation, something easy to follow. Um, as part of that 5 domains, it's about it, do you understand your customer? Do you understand your competition? What data you have? What innovation you are bringing? And what value you would bring to the table? Then how do you enable the digital transformation? So I'm saying this is the path that you could start following. But within this path, in addition to the 5 domain of digital transformation, I would highly recommend um, for people who want to take the digital architect journey to probably pick up that book or pick up that course, understand these 5 domains. But the other aspect that I would highly recommend is understand what is going to change with AI and machine learning democratization. Because the way you start thinking about the future customer journey, AI and machine learning is going to play a key role in terms of defining what those user experiences are going to look like. And all that is going to give you is an integrated business strategy. You would be able to find your new opportunities, the new digital growth. I want to probably give you a little bit more perspective instead of just saying you can pick up the book and start learning from there. Let's spend maybe another minute or two on the five domains. So when the five domains of digital transformation actually talks about customers. Now within that customer, it could be about the network of customers or what networks you would bring in. And that network could also be part of partnerships, new partnerships that you would establish. Defining what is the path to purchase. And that's where you would have to understand the entire life cycle, whether it starts with a simple search and then what are the decision points that a customer is going to use before they actually buy the product or subscribe your service. Understand the digital behavior of your target customer, and all those are well defined within this five domains model. From a competition perspective, it's about understanding your platform business model. What is your competition? Because which is a fairly well understood business model nowadays, because just not about competition, a lot of competition happens. Then other thing that you would have to watch out as a digital architect is about asymmetric competitors, because it's just not about saying I'm a retailer, who are my top three competitor in retail domain. What is changing in this world is there are parallel businesses which are rotating faster. The best example that I give is the highest car seller in North America is not a car dealer, but it's Costco, which is a retail chain. So that's what I meant by that asymmetric competitor. So you would have to start building that capability, building that skill. And understanding data, which is about how do you use data for as a strategic asset, or what value you could create using the data that the organization has, or the data that organization can acquire from the market, and then using that to create the value, which is about constantly changing or understanding customer centricity. All that from a perspective of saying what disruption you're going to talk about, but don't go for a disruption without understanding or predicting or diagnosing what are the scenarios that you could predict when you're talking about disruption. And when you're looking at a disruption, keep in mind the digital fluency framework that I mentioned, because you would have to ensure whether your target audience is ready for it. If I have to put all this into one single slide with respect to what that learning path could look like, uh, a time that I took to make it easier and simpler, the same seven set of core capabilities on a block of saying what is foundation, what is a specialty skill and leadership. That's how I see a journey of a digital architect. Um, I would say it's in simple terms, it's about transforming the mindset. If somebody has been a successful solution architect or a cloud solution architect, it more than the technology expertise or new skills on technology, it's the behavior and the mindset change that a digital architect would require. And within there, I would say the foundation building blocks are about having that cloud first mindset and good understanding of new architecture patterns and the emerging technology and trend. But as you start refreshing your foundation, then do spend good time with the five domains of digital transformation and understanding of what the digital transformation strategy and innovation looks like. How do you define those digital transformation journey? How do you do a road test or a validation verification of your architecture principles for those journey? And as you start building that skill, the next level would be how are you going to manage the technology change? Or how are you going to define the pillars of those composable enterprise? and at a highest level, though it's been reflected at the top, but that human dynamics is actually happening right at the bottom too, which is going to cut across whether you are building your foundation, building your specialty skills, or the top level leadership. Uh, and if you start following this seven skills category and a simple perspective of a couple of framework that I spoke about, that should help you in transitioning to this new persona. And respect to this, I actually have been talking about this new persona across a series of my thought leadership that I've been sharing. So if I have to point you to some additional content, additional reading, I would say I'm leaving you with a couple of links here, which I'm sure would be available to you. So it's a 12-part series. The four is something which is already available. So the links for the first four part are there, where you'll find more details about. But if there are questions, I'm more than happy to take those. But in short, if I have to summarize, I would say a new persona of digital architect is going to define the future. That's a path that if you are thinking about building your career going forward from a solution architect to or a cloud solution architect, then digital architect is your persona, and there'll be huge amount of demand for this persona. It's going to be a journey, and for this journey, you could actually start with this some of the simple frameworks, simple models that I shared, or just maybe follow this 12-part series there. Um, if there are questions, I'm more than happy to take those now.
So, hi Gaurav.
Handle.
Uh, as of now, we don't have any questions, Gaurav. If our participants have any other doubts, they will be contact you in a separate chat.
Yeah, sure.
And it's my immense pleasure and thanking you, Gaurav. We really appreciate the time you took for our concern in having this mysterious area clarified, and we're really grateful for your speech, also your thoughts and the experience you shared with us for the last 15 minutes. So it was a such wonderful opportunity to see your big personality in on the stage. So thanks for your time, Gaurav.
Yeah, thanks everyone, and I hope you enjoy the talk. And if there are questions, feel free to reach out. Thanks everyone.
Yeah, thank you, Gaurav. So, hi Gokul.
Hi, Jyoti. Yeah, good morning.
Yeah, hi Gokul. Very good morning, Gokul. How are you doing?
Good, fine. How are you?
So, yeah, good. I'm too good, fine.
Uh,
And thanks,
yeah,
Gokul.
sure. Am I
Before
audible?
we get in,
My voice is clear?
yeah,
Fine,
Gokul,
good.
we can able to hear. Yeah.
Thank you.
So before we get into our session, let me give a short introductions about Gokul. He's a speaker, and about the Google, Google have more than 13 years of industrial experience, and currently is working as a scientist AC in ISRO, which is a Satish Dhawan Space Center, Sriharikota, and also functionally designated as a project manager for India's prestigious new launch vehicle called a Small Satellite Launch Vehicle, which is a SSLV. So he also treasured in CHEC Aussie during the year 2016-2019 and organized India's biggest chemical engineering congress, which is a CampCon 2016. Also, he is a honorary secretary in CHEC Aussie during 2019 to 2021 and is the head chemical divisions of AIEI TVLC, organized nearly 18 online webinars during the pandemic to widespread the knowledge for chemical engineering students. So, Gokul, please take the stage and you can start your session.
Yeah, I think our Sheikh Shah has joined, so maybe we can introduce her and we'll be
No,
starting.
please go ahead, Google. Yeah.
No, sir. Just now only they have introduced. I think you can start, sir, as we decided.
Okay.
Hi, Sheikh.
Hi, Juicy. Yeah.
Yeah, how are you, Sheikh?
Yeah, I'm good. I'm good.
It was my pleasure talking with you. And so, before we get to the session, let me also introduce our second speaker, who is a Sikh. So, he has a 20 years of experience in information technology, and presently he is working as a senior technical manager in Cryptos Technology Private Limited. And APJMJ Sheikh Dawood is currently involved in architecting a cloud-based solution and AI solutions for enterprise customers. Also, he is working as a software engineer in Supercomputer Education and Research Center, which is Indian Institute of Science, and had a rich experience in conserving, planning, developing the world-class software packages as part of a geographical distributed international team and engineers. So, Sheikh, please, you can take the stage over here.
Okay. So I'm good morning to everyone. I'm really happy to participate Azure Community Conference in this track. Uh, really happy to talk about Dr. Kalam's inspiration from Dr. Kalam, and we'll be talking about how he thought about inspiration, innovations, and creative ideas. So let me share my screen. Hope you can see my screen. Okay, so this is the topic, inspiration from Dr. APJ Abdul Kalam, Space and Innovation Technology. I'll be talking about the stories inspired me when I worked with Dr. Kalam, or I interacted with him. So this is like 10 years ago, Dr. Kalam actually was presenting a lecture in my organization where I was working earlier. He said, I visualize a world where office work from morning to evening will be done in a 100% paperless and 100% transportless mode over video calls. This was 10 years ago. So think about somebody is, how is think about innovation and creative ideas. He was talking about 10 years earlier and what is coming. He didn't know whether we are going to get into the pandemic or anything like that. So as a leader, he was visualizing this. So he said, in such a world, transport to office will be history, and people will work from the comfort of their family and home. Now we are living through this reality. Now, how do you see future work in the next 20 years? So that's all is all about innovations and creativity. So this is one big idea. Okay, this was happened 10 years back. Dr. Kalam talked about it. Now we are witnessing it. The second innovation idea, what it was very interesting to see when they were actually using this composite heat materials for rocket purpose. He thought this is a lightweight material, how this can be used for for somebody as a human purpose. So this is physically challenged students, they used to carry 4 kg propels new their clippers or weightage is 4 kgs. So this, after implementing this weight is reduced to 10 times lighter. Now this is a idea where he thought about it. This material is used in rocket science, how this can be used for humanistic way. So this is a very good innovative idea. So it is how you think, how uh, dream about your ideas and apply to humanities. Next one is, this is where 2013, and I was in USA. He had come to present his ideas about National Science Forum, where he was talking about global energy technology initiative for harvesting energy from space. So he asked this one question: so what will be the vision for the entire human space and world, greater than how you have a clean energy 24/7? So this is again 7 years back. He was talking about harvesting solar based energy and transmitting back to earth. This is his dream, and so many scientists are keep working on this. So there are different countries are working towards this. So this is a simple idea where in the earth, above the earth, we have enormous solar energies available, where how you make use of that. Now we are in a need of clean energy. How do you harvest that energy, space energy, and transmit as a battery and keep using it? This is today is it was a dream for him. Today is happening, and there are so many scientists are working. This is one of the innovation he thought through that. And he was not only talking about science, he was continuously evolving his ideas for healthcare, how you can do this healthcare thing affordable way to the villages. So that is where his idea about connecting villages to the cities, where Pura was born. He was talking about electronic citizen card of the basic health data, availability of quality health care, affordable cost, use of teleconferencing and telesensing to interact with patients. In the pandemic, we witnessed, and we people are living in the villages. They were having this COVID symptoms. They don't know what to do, and government of India across all the governments arranged the facility where you can call a number and talk about your symptoms, how what you are going through, and people are able to answer your question. He talked about it 20 years back. And surgical procedure demonstration using net-based videos. Today, when somebody is doing an operational procedure in a place where he needs some expertise help, that fellow can sit in anywhere in New York City or London, he can help the doctor who is doing the procedure. So knowledge system provide expertise advice. Today, if you look at it, the entire world is connected with knowledge base, videos and audios and multimedia stuff. Anything you want to learn about healthcare, agriculture, anything, you can go and play that video and learn it. That's not expertise advice, but still you will be able to get some knowledge. Electronic patient records to provide biomedical information. This he talked about 20 years back. This is very, very important. Suppose you go to a hospital or a healthcare system where you done all your health checkup and you will have information. That information now it's stored in an electronic format. Where suppose if you want to consult another doctor, another hospital, easily it can be transmitted over an email or cloud storage. So the entire data, health data is managed in a nice manner. Now embedded software of telemedicine and telesurgery. So this is again you was talking about how you can treat a patient with his data connected with computer. So like sensors today, your mobile phone carries a sensor. It can tell you what is your temperature and all other factors. He was talking about it. Health and nutrition broadcast and electronic media including internet. He was talking in 2002. So advisories, how now we are hearing in COVID-19, what are the advisories you need to follow? So he was talking about it. So how this is innovation, he was talking about in effective healthcare. So Dr. Kalam was a very much fond to knowledge about any skills he wants to learn, anything he wants to know. He was talking about knowledge society. He was advocating all along his presidential year. After that, he has to interact with students. He will say we need to have a knowledge society. So knowledge society is one the basic foundation for the development of any nation. From now onwards or earlier, if you want to go forward electrically, we are connected. We should know what is the knowledge available to how to read it or understand it. Probably 50 years back or 40 years back, somebody need to understand some concept, he has to go to a library and reference a material. Today you have a different scenario. Since we are all connected with the internet, knowledge is available in Wikipedia and other internet sources. This was again 2003, where Carnegie Mellon University and Indian government jointly launched this digital million books project, when he initiated himself that capturing information which is in palm leaves and old books of 200-year-old book or 300-year-old book. Those are things are very much precious. So we need to capture those information and store it. So if you store it, we can do a research on that. We can extract information from the olden knowledge and keep improving on that. So that is what he was talking about, knowledge society. So again, this is a million book project where I was associated in 2002. He actually launched this project with Government of India and Carnegie Mellon University and Indian Institute of Science. This project aim is to digitize million books across the globe along with other institutions, where you actually scan palm leaves, books, everything, and put it in a digital format in a searchable way. If you go to National Digital Library today, you can go and search all this information. You will find enormous information to learn and enhance your knowledge. This is one of the unique idea which everybody talks about today. So these are the things what Dr. Kalam has done as a innovative and creative ideas in technology. So we thought, okay, he was talking about making a satellite, per kg rupees under 5,000 rupees. If we are able to do that, then the entire world will benefit by doing that. So we took that idea. We thought, okay, how can we do this with the students? So there is something called Femeto satellite, which will have small sensor into that. You can actually launch to the sky and observe some information, weather information, and other information. You can observe it and record it, bring it back, and you can do research. So this year, in the beginning of the year, we actually assembled 1,000 plus students across India. They actually assembled 100 Femeto satellites with this different goals. So we launched it successfully. Now we involved government school students where they were not able to afford to do this experiment. They call it as democratizing this as a science. So this was one of the inspiration. We took it from him. We are continuing on that. So I would like to conclude my speech with this. Dr. Kalam always talk about this. A leader must be able to explore uncharted areas. So that's where you'll have new ideas and innovations. A leader must know how to celebrate the success and manage failures. If you take up any new job, new skill, or new idea, you will eventually have some turbulence and failures, you will have to come across and keep continuing. He was talking about a leader must have a courage to take decisions. So there is a place where you need to take a decisions. If you delay decisions, there is no use for any innovations or creativity. A leader should exhibit nobility in management. You will have hundreds of people working on a project. How do you manage that? He talked about it. A leader should be a transparent. He was very much transparent person and what's happening in and around a team and everything. So that's where he taught us about knowledge management, innovation, and technology. So thank you so much for this opportunity. Coach, you can take it forward from here.
Yes, sir. Yeah, sure. Maybe my presentation is visible, sir.
No, not yet.
Yeah, yeah. Now it is visible right now, sir.
Yes, now it is visible. Yeah.
Yeah. Okay. So, good morning to all. I welcome our Sheikh Dawood sir, who is the grandson of Abdul Kalam. So proud sitting along with him. So also the Azure community, I think they're doing a wonderful job last past day. I think from yesterday onwards, there's lots of connecting community in the digitalized world. So also thank the organizing committee who could able to give us a platform, especially to say about the visionaries of our the people's president and the rocket man, none other than our Abdul Kalam sir, the vision. So it's going to be like a small presentation from my side. So definitely, I think we all humans. I think definitely we should know that how the history of Earth has come. So then it will be easy to understand about the technology and the innovation. When we try to see, I think maybe almost we should go back almost 4.56 billion years ago. What we are really right now in 2021, it is very small. So when we go back, I think the formation of Earth was started in the solar system. From there, I think the moon formation has initiated, and all kind of sedimentations, the oceans, and the isotopics of evidence of land also was there. And when we try to go to 2 billion years ago, that was the time I think there was an oxygen was being noticed in the atmosphere, and which has leads to the formation of a nucleus. I think the nucleus is the one important component for all the living organisms in the world. And from there, I think almost zero point 0.5 billion year, I think the first hard-shelled animal was initiated, and right now I think with humans and with other bioecosystems, we are all living together. And when we try to see, that is the like the initiation of the earth and the microorganisms and the humans. But when we try to see where are we, I think there is a today I put as a zero. From here, I think what's going to happen in the next level of the earth. Definitely, I think there are so many things are happening. I think right now we are talking more about the sustainable development and the global warming and so many like climatic changes. I think it is all already predicted, and that is going to happen. It because the way industrialization is happening out, and the a very huge amount of the pollutions, everything is being let out. That's all going to cause a many obstacles in our earth. So when you try to see after this 2.5 years, I think the Mars warm is going to happen, and the oceans boilers will happen, and definitely almost in the year of something around 7.5 billion year, it's almost like the sun will become a red giant, and sun will fade away, and rock will melt. I think the universe can even like disappear from the solar system. So it almost going to take another 8 billion year. I think what's going to happen another 100 years itself, we are not going to see. This is the predictions what is going to happen. So what really happens on the complete solar system when we try to see, I think only like a few planets which could able to emerge this kind of living organisms in the galaxy. So that is one, I think we know our Earth. So we are all living happily, And similarly, I think we have a certain planets like a Mars and some planets which is nearby Saturn, Jupiter. So there also some kind of a life in the universe has been explored. How it can be done? So it is not so easy. I think we sit in the Earth and try to go and explore or invade the other planets. We need some kind of instrument. And again, other planets, there are so many Earth planets also been around the solar system, around the galaxies. I think for so many like the science. Our own galaxy Mars is the only very near planet, and it is having a good amount of like same kind of atmospheric oxygen, same kind of climatic change, and a kind of a similar the predictions happen in the Earth we can able to explore in the Mars. But when you try to see go to the other like where there are so many billions of stars are there, and that's what they're called as a G star, K star, and M star. So I think there are so many like Kepler has found, and a small amount of habitable is being found in other planets. So already I said like I think Earth is going to be end by another 8 billion years, or even the faster the innovations, faster the industrialization is goes up, we may decrease that year also. But what is the next option? Are we going to shift our the peoples or living organisms from the planet Earth to the next planet? How it is happen? That's the we need an vehicle. I think it's not something like we need a rocket, bus or train or aeroplane which we can travel to other planet. We need something very big gigantic vehicle, and that vehicle should be called as a rocket, satellites, or you can even take a crew module, and they can put so many humans being, and they can go to the other planet, and they can explore. But to design a rocket, I think it is not so easy. I think one important one important I should share this picture. I think even it is put up in the NASA, and say that India, I think the first of the person Tipu Sultan was an Indian who has worked with to orbit and use our Earth to traverse to galaxy. So this is the first species of the robots. But what has like India has done it for space and for definitely I think Dr. Vikram Sarabhai, who is the father of our Indian space program, was a pioneer, and he has a very big vision.
So,
That I almost
hi
we
Google.
try to 60 years ago. He has given a visionary thing that my
Google.
scientific knowledge and powerhouse of Eng should build our own and also owning metal craft and
Google.
launching Indians' life to the problem. In 1990, such a statement he has given, and today I think we have done it. You know, like you can see yesterday. That's a first rocket which we have taken from our own soil, and we have put it in the orbit. Okay, to name we have developed a bigger rocket like a Mark 3, and taken our which is something like a very, and it has capacity of loading something around 400 or 500 kg. And in even the satellite, I think we have crossed so many embark, which is we are going to see in the coming the slides. So what he has created today, I think we are enjoying the technology, and today we are sitting inside the house, and we are like we connected with the
Kovalji, your voice is very
one
it's
could be the
breaking.
entire global
Kovalji,
life instead of what kind of we
Koval,
are
your
going to
voice is
face.
breaking.
But the satellite is always communicating from one end to another, and it makes life easier. This is the vision,
Hey,
not like a
hey, Sheikh,
visionary document
are
has
you
been
there?
given by our
Hey,
Vikram
Gokul, sorry for
Sarabhai,
interrupt.
but it is not easy that in a short span of 6 minutes or we can able to do it.
Hey, are you there? Hey Gokul, sorry for the network
Am I
glitches.
audible, sir?
Can you switch off your camera? Can you switch off your camera?
Yeah, yeah. Am I audible?
Yeah, yeah.
Yeah, definitely. Now am I
Can you hear
audible?
me?
Okay. Yeah, yeah, I can hear you.
Yeah, yeah. I can hear. I can hear me. Just share your screen.
Okay. Thank you. Sure. Is the screen is visible? Unbu?
Wait. It's loading. It's loading. I think bandwidth issue. I think so. Still loading. Google not a shared. Can you reshare again, if it is possible? Google, you there? Sheikh, are you there?
Yes, Anbu. I'm trying to reach him.
Yeah. So I think there is some network connectivity issue.
Just give me a second.
Yeah, yeah, sure.
Yes, sir. Am I audible, sir?
Yeah, I can, but some glitches still.
Sir. Okay, sir. Am I audible, sir? No?
Hey, thanks for welcome back. Hello.
Yes, sir. Yes, yeah. Am I audible now? Okay.
Yes, yes, I can. Yeah, yeah, I can able to hear you.
Now screen is visible.
No, it's still loading. Give me a moment.
Yes, my screen is visible, Anbu.
Sorry. Hey Gokul, sorry for the. So actually, you, your screen is not visible. Hey guys, please hold on few moment. And there is some network issues. Thank you. Hey Gokul, can I hear me?
Yeah, I can hear you now. Yeah.
Yeah, super. I can. Can you share your
I'll just
screen,
share
or
it now.
are you going to do the talk?
No, no, no. I'll share it. It does now function. There's some. Now it is okay. It is coming out.
Um, yes, yes.
Fine. Okay. Thank you.
Yeah,
Thank
thank
you.
you. Go. Go ahead.
I think some internet. Yeah. Okay then. Yeah. So sorry for the interruption, guys. So yeah. So the ISRO has not, I think, developed in overnight. I think there are more pillars have been there. One, Mr. Vikram Sarabhai. I think he's the person, I think, who has created the ISRO. And second, when we try to go with our the Satish Dhawan, I think he's the emperor who have developed all the infrastructure of our ISRO. And none other than our APJ Abdul Kalam sir. I think he's the first project director to create the SLV rocket. From the SLV rocket, I think definitely we have gone to the Mark 3. It is an unimaginable the growth and height what we have given to the entire world. If you would have not developed such a rocket, I think in the 1980s, I think now the indigenous rocket or indigenous satellite which is taken from the Indian soil would have not happened. And we have like Madhavan Nair. I think he's the person who has done the mission on Chandrayaan, and we have Radhakrishnan under his leadership. I think we entered the Mongolian mission. No other people in the world would have entered the first attempt. I think India has done that. Currently, we have a chairman Shivan, who's like very dynamic, and we have gone to Chandrayaan 2, and we have landed. But fortunately, I think we could not able to face the technical glitch. But still, I think we said to Moon, we are going to come back and see you again by landing our own Chandrayaan 3. And again, the Gaganyaan mission is also going to come. So these are the various emperor who could able to develop the ISRO in a very important perspective. What is the space engineering and technology has done from the past something around 1970s to 2020? When we try to see, I think the space has involved in all kinds of departments or all kinds of revolutionary movement. I think the SLV was started from the SLV. I think we have stepped into PSLV, GSLV, and Mark 3. And same parallel, I think ISRO also taken an important regime, especially in the defense also. We started with Prithvi, Agni, and right now I think Agni 5 is going on, which we have tested, I think, 2 days before. So 5,000 kilometers we can able to travel and we can hit the water. So in all the areas when we try to see in the ISRO and defense, I think the potential development in India is huge. That's what the science, engineering, and technology has created a big pathway. And not only I think it is by the space or defense. The another important is that I think the IT, information technology, has like given a huge revolution. Now currently India is seeing up. Definitely, I think maybe you would have seen with some small floppy, but try to see. I think today we have entered into a kind of a bigger supercomputer, which nobody in the earth would have been had. Such a kind of development we are doing it, and also other development like green revolutions, white revolutions, wind energy, and right now we have been gone into precision farming. So these are all been connected with our own satellites and rocket, where we could able to the communicate or connect the technology with one to one. So the journey of ISRO, I think it is not started like very easy. I think 1960s, I think India got our independence, and almost a 2 decade we were like developing the infrastructure of our country. But still, is there like a need to enter into the spacefaring nation? Yes, we have to be. That is what today we have become an indigenous. So you can see, I think the small rocket has been taken in the cycle, and it has been developed. It is none other than our APJ Abdul Kalam sir, along with the Arvamudan. So they took like a people in 1960s without any kind of a technology advancement or without any kind of a support from the other nation. They are doing it by their own indigenous, by sitting in the library. They're reading out, and they brought the technology out. And that has become in 1979 a big like a revolutionary rocket of SLV. So SLV is the one, I think, which has created a huge impact around the world, and which said that yes, India has a capacity to launch their own launch vehicle, and they go to the orbit without any kind of a support from other nations. That was happened in around 1979. And these are the various evolutions in the launch vehicle right now ISRO has developed. So always people used to say some job you do, they will always criticize like as they you're going to launch a rocket. So rocket is not easy, it is a complexity. It has something around more than a lakh compound, which is all movable items. So any movable items, anything like a dynamic items, Any small kind of error, I think that will create a big disaster. So we have to try to see that the rocket which is created by our own India, I think every missions we try to see how complexity, how an improvement, how like the technology innovations can be kept inside, and we are doing that. So maybe 1980 our journey has started with SLV, and we had ASLV in 1992, but the two rockets were withdrawn from the service. Currently, I think PSLV is one of the workers of our rocket in our world. It's almost a 50 long vehicle what we have carried out. It has all been success. That is what the 200 years the British, I think, who have ruled India, they are bringing their own satellite. They're asking, can you put our satellite PSLV? Can you launch our own satellite into the orbit? That is the enhancement. That is the improvement or innovations we've brought inside. And next is GSLV. And currently, I think we are also getting inside Mark 3. I think that is one of the biggest, like a space shuttle. When we try to see from NASA, it's an Indian space shuttle. So it can lift up something around 5 tons of satellite to the geostationary orbit. So whatever the communications, what we are handling it right now, it is not so easy that we have to put every time 2 tons or 1 tons or 1 ton using PSLV. Now GSLV Mark 3 can have a capacity to put 5 tons of satellite into the geostationary. And the next, I think, because of COVID, I think this SSLV is under development. Definitely this year or the first quarter of the 2022, the SSLV is going to come to the world, and this is going to play an important role in carrying out all the nano satellites, which is having a huge market across the globe. I tell about rocket. So what really the rocket does, and what is the like informations we have got it till now. The rocket always takes up satellite, which will be kept on the top, the nose of the rocket, and the satellite plays very important role. India has enhanced the more three important area is one, the remote sensing, the communications, navigation. Right now, if you try to see, I think a more amount of the navigation, we use Google as one of the platform. Whereas when you try to see the remote sensing and communication, we have become so indigenized, and we have become like a master in the remote sensing. The remote sensing, if you try to see, these are all various area where remote sensing is useful, and we are could able to develop such a scenario. And the communication, you see, like the televisions. I think in 1990s, I think we had only one news like a television channel, like a Doordarshan's or National or something. But right now, I think we have enhanced more than 1,000 channels, and that channels have become like the more like the brightness or contrast or quality, such a kind of like a pixels we have been developed using our satellite. And it's not only like a communicating one information to other using a television. We also do a telemedicines, we also do a tele-educations, and we create some kind of emergency communications other part of a country. So that is satellites will be playing a very important role. The another important difference, you can see our map. I think the three parts is covered with an ocean, whereas one area is covered with completely with the mountain. So we cannot able to deploy each and every area of the border to keep one soldier to monitor for our the border protection. We have kept the satellite. I think this satellite is completely monitoring our country, and it will give an information whether any kind of an enemy is entering in our the borderline. It immediately gives up a fractions of second, and immediately our army or navy will be alerted, and they'll be like a communicating to them. Such a kind of a system has been developed. And the meteorological, definitely, I think 10 years before, the life of every human would have been lost because of the cyclone or disaster warning. But right now, the satellites are predicting the frictions of like a second, and it says that where the cyclone is going to hit, at what location, what place, what time. That is the amount of the huge contribution is given up, and that is what today I think even the cyclone comes in like every month or every 2 month or every 3 month once, we could able to evacuate the people and we are clearing the life. That is the contribution of the satellite. And this is also like it contributed in other part of area like an agricultural, forest, and water and ocean. You see, ocean is one bigger, like our the land capacity in the earth is very small, but the ocean is very huge. And the fisher people, I think fishermen who go to the ocean, they want to catch a fish. It is not so easy that they can able to go to one place and they can catch a fish at the catchment area. They need to wait for at least 10 days or 1 month in the ocean to get a good amount of fishes and come back to the land area. What does the satellite does? The satellite take an image and it gives the correct of like the plot like to the fisherman, which latitude, which longitude you want to go and be there and get a fish catchment area. It is giving a correct directions, and the fisherman people are going there. They're getting the fish within a overnight to 2 days. They're coming back to the land. So that kind of a support is also given by the satellite and other areas what we have really like used in the Earth observations application. So remote sensing, the India is the number one, and definitely I think whatever the satellite applications we are daily using up, and for our day to day life as well as for the development of our nation. And you can see the enhancement of the satellite. I think somewhere like in early days we had a satellite resolution something around 223 meter, and we brought it to 5.8 meter. Right now I think it is in 1 meter. I think we have also enhanced something around zero point 0.5 meter. You see, zero point 0.5 meter, a satellite is sitting somewhere around 700 kilometer, and it can take a picture of resolution around zero point 0.5 to 1 meter. You see the unimaginable the satellite is doing its function. It can even map up wherever we are sitting in our house, and it can able to give us a terrain. It can give us a proper mapping. It is useful for our complete development of our nation. Suppose the new state which is formed like 5 years before or 6 years before the Telangana, they want to develop a state. It's not like they go to every street and the corner of the places and they can able to say. The satellite will map which part is the water zone area and which part is the like the farming zone area, which part where our hospitals and schools can come up. Everything can be mapped, and that has been used for our daily life. But okay, these are all the applications what we done. I said that the initial slide, the Earth is one the important regime which is formed around 4 billion years ago. I think another 4 billion years, like 4 to 5 billion years, the future. We don't know what the Earth is going to face a huge amount of the disaster created by the nature or by the artificially by the humans. So it is like we need to explore other planet also. So that is what India has taken interplanetary mission. The first mission of Chandrayaan-1, which is very nearest natural the planet, the natural satellite for our Earth is a moon, and we want to explore what is really happening in the moon. What kind of minerals are there? Is there like a moon can able to create an habitat? So in 2008, I think the Chandrayaan mission was carried out, and the Chandrayaan mission was taken up to the orbit of moon with various maneuver. And nobody in the Earth would have thought that the water molecules is there in the moon. Yes, we have found, and this is the picture of the moon, which is taken by the Chandrayaan-1. And the complete like we said we want to establish there is a molecules of water is there in the moon or not. We found out and we have given to the complete world, and the world also like agreed, yes, there is a water molecule is been there till at 2008. Before, so many missions have been done by the NASA or ESA, they could not able to find out. That is the first historically ISRO could able to do that. And these are the various the crater and the pictures of the moon which is taken by the Chandrayaan-1. So definitely I think this has given us lots of like a research interest, and it has also created the craters. The approximate the years of the moon is might be around some 2.8 billions old. So these are all the evidence what we could able to say to the moon. The moon is could able to have a small kind of a terrace system. It is having some kind of a impact crater, and the diameter and everything could able to impact it at the one point of the moon. So that has given a huge lift for the other researchers to study more about the moon and create more interest about it. And next, the mission is a Mangalyaan. The Mars, I think, the one important habitat where from the Earth we want to take it up. But definitely, I think no other people in the world would have attempted first mission as a successful mission in the Mars. India has done that. Even I think China could able to realize it 2 3 years before, but we have done it in 2014. So which means like India has such kind of an innovations, and the complexity of the technology can be like handled, and we can able to reach to the level of Mars in the first attempt, and we have reached. And our important the mission of Mars is we want to see that whether methane gases are available. The one important for any kind of an habitat to develop, the methane gases and other kind of gases when it emerges, definitely the kind of living organisms can be like a developed. So we have gone to the Mars and we have reached the Mars at something around 5,75,000 kilometers. We have reached with 450 crores of money. You calculate 5,75,000 kilometers divided by 450 crores, it is per kilometer something around 6 rupees. Even in our own country, I think the per kilometer charge for an auto wala will take minimum 10 rupees. We have taken a rocket, we have taken a satellite to the Mars with lesser than 7 rupees. That is the potential we have contributed to the nation. And this is another important, I think, always we try to say the Sachin Tendulkar or Mahendra Singh Dhoni or Kohli will hit a century, but even I think Rocket also has done that. And the PSLV C-37 are carried out something around 107 satellites, and that has become a very historical event. I think before our 107 satellites, I think the Russia who have done it with 38 satellites, and we have overbeaten it. But I think after that, I think recently Elon Musk has crossed more than 250 satellites. But it creates an like the impact. I think whatever the technology, whatever the level we want to go, I think we have reached to that level. That is not the innovations behind the rocket technology and satellite of Indian space program has created, has contributed huge for our national development. So this is about Chandrayaan 2. So definitely, I think Chandrayaan 2 is one of the an, historical mission. But fine, we have taken both like a orbiter, lander, as well as I think we have taken a rover. But fortunately, I think when we have taken our launch from July 15th and we have gone to the moon and we have inserted and till now the orbiter, I think whatever we have aimed the orbiter to function, it is functioning in a very enormous way. But when we try to see the rover and lander, I think because of a small technical crunch, I think around 2.4 kilometer, our lander could not able to land properly, and it has been spread out. But this Chandrayaan 2 mission has created a huge impact around the country. I think people would have been watched the overnight the cricket match or some movie or something, but everybody was waiting for the Chandrayaan to land on the moon. That has become a very big scientific experiment around the world, around the nations, and it has impacted huge. And definitely, we always say that I think the moon is almost like it's going to be there, but our missions always can be taken up. That is what we said to moon. We will be come back and we will land our own Vikram on the moon with more precisely, and will make our orbiter to run on the moon. So very soon, I think Chandrayaan 3 is going to be taken up by ISRO, and definitely we are going to create another historical. And the important, I think, right now, I think you are seeing is Mr. like Rakesh Sharma and the Ravish Malhotra, who is an Indian astronaut. So the government of India has initiated the Gaganyaan mission. So we are going to take a human, I think the Indian soiled human to the orbit and going to bring it back. So these astronaut has gone with the Russian the rocket, and they be back and they become like a first Indian who could able to go to the orbit and come back. So definitely, India is going to take its own the missionary of Gaganyaan in another two couple of years. And India at 75, we are proudly say that we have entered into all the elite areas. For example, the initial 1980s, nobody would have thought we would have created a rocket. Yes, we have created, and people would have not. One rocket can achieve 50 continuous success. Yes, we have done it. And whether we can go to Mars, we can go to moon. Yes, we have done it. And now the important mission is Gaganyaan. Once we have reached to the level of Gaganyaan, definitely I think India has entered into the complete elite status of the space program. It is not only like 4 decades. If you try to see 1980s to 2020, within a 40 years, the development on the space program is huge, and that is one big complexity on the space program is being like astonished, and we are going to travel on that. But what is going to happen in the next level? It's not only like a space program. We need to develop in all the areas. That is what the vision of Kalam was brought into the picture, and what really is going to impact our space program. The next 100 years, when we try to see the aerospace, there's so many important programs are going to happen. At one, I think, a moon and Mars mission across the globe. It is going to take a very big regime a structure, and we are even going to have a reusable launch vehicle. Example, we go to the moon. I think we can go there and put some kind of setup at moon and bring back our vehicle to our Earth. Again, we can reuse the same vehicle for as a like a space tourism. Right now, Elon Musk is doing. And the other important, I think, one is a solar panel where we are going to use a satellite as a like a kind of complete harvest the energy from the sun and going to send it to the Earth as a substation, which can able to convert complete the energy say requirement for the entire world. So even the important, I think, space colony is going to happen and space tourism. I think already, I think few of the people from UK or US started Jeffrey Bezos and Elon Musk. Definitely, I think the total world is going to see, including ISRO, the space tourism is going to happen at around 2050 to 2000, which means I think the ISRO is going to take a next level of interplanetary mission, and which is going to create a huge amount of impact for the next level exploring the other planet. But we have gone to the one level of the increasing technology and proving our world that yes, within a 40-50 years, I think we have gone to the other planet, and another 50 years we are going to take it as a tourism, and we are going to set a colony, and we are going to move one a human to other. But if you almost like try to see other area, I think these are the very big impact which you are seeing in the daily life in the complete world. Maybe a global warming, climatic change, and mass extensions of species. It is nothing like okay, we want a technology, we want a innovations and everything we need, but we it is our duty to protect our mother earth also. The technology what we develop, it should not like create some kind of an extent for the any kind of a biodiversity. Every humans, every species what is been in the earth, they have their own role. So each role, every like even a rat, even an ant, even a mosquito has a role, but it is our duty to protect them also. That is what, when we are not able to protect, the global warming is increasing and temperature increases, and so many glaciers are melting out, and the entire world is seeing a big climatic change. The examples, I think, one important ozone depletion. You see, 1978, how the Earth looks like. By 2066, they are predicting Earth will be like a kind of a rocky structure, because the ozone layer, whatever the depletions has happened in Antarctica ocean, it is going to create a disaster changes, and it is going to create a disaster climatic actions on the Earth, and that will create our own Earth into the level of a rocky structure. Are we like happy to see such a kind of Earth, or are we like happy to see an Earth with a more bluish and green, like a greenish color? Definitely we need to look into that. And it is again, there is another important, I think, there's so much of wildfire has been started. We see somewhere like in 2020, the Brazilian, the biggest Amazonia forest has been fired. Somewhere year before, 2 years before, we have seen Australia, we have seen US. Everywhere, I think, the wildfire has been increasing, and is increasing sixfold in the last 30 years, which means when the fire started, I think, it is all like a kind of wildlife, the extension also started. When their extension which started, it is everybody duty to bring back their wildlife into their own homeland. Otherwise, I think definitely we are going to see a very huge impact on that. This is okay. We would have not thought that Russia, I think, one of the coldest part of a country in the world, but you see, like, even they face a heat wave in 2010. So that is the very important aspects of the global warming. So the protection of Earth is not lies with only with the government, only with the bureaucrats, or only with the industry people. It is with everybody's hand. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there's no hint that help will come from elsewhere to save us from the ourselves. Definitely, we are going to save our own planet. The technology can enhance, the development can happen. It today we have a one important instrument in our pocket. It's nothing but a mobile phone. We see mobile phone has eradicated so many technology, so many instruments like a camera, alarms, the FM, so many things. But it has come to a small instrument, and such a kind of innovations required. Same way, I think that should not exploit our own Earth, Mother Earth. So even we launch a rocket, we go to the other satellites, other Earth. Definitely, it is our duty to protect us. How we can do that? So improving the technology is not only like creating a huge amount of the next generations of mobile phones, or next generations of the internet or networking. We also need to create a clean energy generations. One, the important, I think, solar energy, energy from the ocean, wind, and also the EV, the electrical vehicle using an hydrogen or other batteries. So definitely this is going to play an important role, whereas we can able to reduce the climatic disaster change by using so much of the coal as one of the gasifications to burn it, and explore the so many amount of the coal gases into the atmosphere and create a ozone layer depletion. We can convert it. The sun is there. We can harvest the complete solar energy, and we can use as electricity. We have a wind energy. We have a ocean. Completely, we can use a tidal wave, and so many technologies has come, and these all can be used for us to save our earth. It is not only we make a green cover by planting huge amount of trees. Our technology also has to become a renewable one in the coming days. So with all the thing, the sessions what we it has been given to us, the Abdul Kalam's the innovation. Definitely, I think Sheikh Dawood has narrated about Pura. Even he was a people's president, and even he was a rocket engineer. But he always cared for the nations. He not only care about the Indian, India is only a country. He also care about Pakistan. He also care about Bangladesh. He also care about Sri Lanka. And he asked, what is the vision for another 10 years or 20 years? Definitely, I think he has created a big vision for our entire world, and which means like in 2020, I think they thought like India is going to be a developed nation, but definitely, I think ISRO has developed. We are so proud, but still, so many departments, so many areas they need to develop it. It is not everybody can become a prime minister, everybody can become a chairman, or everybody can become an Abdul Kalam. Each people have their own unique nature, and everybody contributions for the nation is huge. Definitely, when we try to contribute by our own technology and digitalization, the opentification, India is facing a huge problem. Still, 70% of the people going outside the opentification, and they're creating a huge problem, and it is losing 1% of GDP.
Gokul,
Yeah, it's 2 minutes.
sorry
Yeah,
to
I'll
interrupt
give.
here. Okay,
Yeah,
Gokul. Okay, thanks. Go on.
yeah. Yeah, so 70%, I think everybody start making a toilet for all our people in our country. I think we can reduce 1%, it becomes 69. And and we so many people are sitting in the dark places. Definitely it is our duty to harvest the solar, and we can able to give back the energy. That becomes an innovations, and that is becomes like the visionary thought of Kalam sir. And education for all, definitely we all try to contribute. India is only one nation, and so many other nations facing the same huge problem, and engineering is the one important tool where we can use this tool to eradicate the poverty, to bring build up the sustainable development goal of 13 goals into the picture of entire world, and make our earth as a green and clean, and say that this is only one planet which we have. Till we need to explore other planet, we can live happily. The technology enhancement and the innovations can also lie to our mother earth and create all the species and a livable home. Thank you so much for this opportunity. Thank you.
So thank you, Sheikh, and thank you, Google. So it was really a wonderful opportunity to see a big personality like you on the stage in sharing about the information on the innovation and the technologies we are having in our Indian Space Center. Even though we had a lot of glitches in the bandwidth due to network issues, we can able to see just you have broken the struggles and you have just come up with the great information. So we are looking forward in excitement to have another great session with you in our upcoming events. And once again, thank you, Gokul, and thank you, Sheikh.
Thank you for the opportunity.
Thank you so much. Thank you.
So, hi Keshav.
Hi, how are you?
Yeah, fine, Keshav. How are you? So, and once again, thanks for joining with us today, Keshav. So, let me give a short introduction about Keshav here. So, Keshav is going to share his knowledge about Power Microsoft 365 Defender with the Azure Central. And Keshav is working as a technology security associate manager at Accenture. And Keshav, the stage is yours. Please go on.
Sure. So, yeah, before we proceed further, just a quick confirmation like my screen is visible.
Yes, Keshav, we can able to see the screen.
Perfect. So first of all, a great thank to the previous session. Actually, it was a very inspiring, and uh, along with working on the technology, we should have to take care of our Mother Earth as well. And thanks for organizer as well. Like generally, we have all technical sessions, but was a very inspiring, and it's all our duty. So thanks a lot. Uh, with all that, today. Let me welcome you again to our Azure Community Conference, and I am proud that we are part of the India largest Azure conference. So today, I'm going to talk about how you can power the Microsoft 360 Defender with the Azure Sentinel. Uh, Once you set up the integration with the Microsoft 365 Defender and the Sentinel, then it becomes a full-fledged cloud native SIEM, SOAR, and an enterprise defense solution. So before we start further, let me tell you a small story. So if you are from the uh, 90s or the 80s background, then you must have seen over the TVs, right? The old movies uh, where the dacoits used to come on the horses, and uh, they used to like do a theft in the bank, or they used to rob a lot of rich people. But during that all process, there used to be a very risky scenarios for their life as well. There used to be a gunfight and lot many things, so there used to be a big risk for them. Now what happened is those people have like the generations who are still doing the same kind of things, they have adopted the digital transformation. Now they thought, why to risk their life? I mean, if you can do everything with the help of the computer, with one computer and one a good internet connection, then why to risk the life? And with this way we can earn a lot. So the generations, I mean the people who were working with them uh, during those times, they have also adopted the digital transformation, and now they are doing the digital theft. They are kind of disrupting the digital information. If they have to rob a bank or anything, they don't have to do a gunfight or anything. That can also be done using a one laptop and a one computer. So now our present state is we have to do a protection. We need a protection from these all cyber criminal. And with the way we are going on, uh, like due to this COVID and due to the uh, ask of the modern infrastructure, things are going uh, things are becoming more and more digital. Earlier, we used to say handful of employees used to work from home, or it used to be a very big thing. I mean, if somebody is working from home, it used to be a very big thing for him. But now, almost everyone is working from home. Uh, Companies are adopting more digital transformation, and they want their employee to work from anywhere. So to do that, we need a very robust and a very strong and a very secure infrastructure, because threat actors, the person who perform the attacks, right, they are also adopting the digital transformation. They are adopting all kind of sophisticated method to disrupt the resources which are there in the organization. They have their own way of identifying the vulnerable resources. They also do the analysis, right, the way robbers or the thieves, like the way they do the assess or they assess the area, they also have their things of doing the assessment of the environment. And uh, what we need is we have to protect our system from this kind of uh, assessment, or we have to kind of keep an eye on the intruders, or keep an eye on some unwanted activity. So like the threat landscape has changed completely, like the way it used to work in 2010 or 2015. There we used to have handful of attacks, and it was very easy to kind of analyze those attacks, right? But now it's becoming more and more difficult. Although we have a very sophisticated tool, but if this tool works in a silo, then uh, we are very limited. I mean, we cannot uh, response to each and every threat. We cannot protect our organization. So the need of the present condition is that we have to do integration between these tools, and how efficiently we can utilize the the we will be more protected from these kind of threats. Now, I hope it was a good story. Now let's move to the technical part. So I talked about lot of threats, lot of digital disruptions, right? So why we actually need the protection? Why we need uh, these all things, right? So let's take a simple example. If companies is adopting the digital transformation, they also uh, aim to earn more from the digital transformation, and the entire digital transformation can be impacted by a small threat. I mean, if some kind of threat happens, some kind of uh, attack happens over any platform, then it actually disrupt your business. And the more important thing is it's going to bring up the bad name to the company. For say there is a food delivery company, and somebody hacks his database, and somebody hacks his username, then definitely it's going to hit his revenue. If that company is listed in the stock market, then its reputation, its stock, its valuation, everything will get disrupted. So to protect from these all things, right, we have a tool, we have a category of tool that's called XDR. That's we can call that as a extended detection and response. Some people call that as a cross detection and response as well. So it's a tool that has a capability of collect and correlate the data across multiple security layers, emails, endpoint servers, cloud workload, and network. And with this, it will allow you to faster detect of the threat and do the improved investigation and response times through the security analysis. Now, what is the exact definition of the XDR? So if we go by the Gartner call it as a software as a service tool. It could be the vendor specific. There are a lot of vendors that provide the XDR tool. Uh, so it's a vendor specific security threat detecting and incident response tool that natively integrates with the multiple security products into a cohesive security operation system. So what XDR can do? XDR can do the identify the threats that are highly sophisticated, all kind of modern tool. It has a ability to identify all the modern attacks. It can track the threats across the multiple system components, help you in improving the detection and response, uh, speed your response process, or it can kind of investigate more efficiently and effectively. Um so we can call it like what XDR can do. XDR enables the organization to prevent successfully at cyber attacks, as well as simplify and strengthen the security process. it knows how to block the known and unknown threat with the powerful endpoint protection. Uh, it can help you and gain visibility across all your network endpoints and lot of things, right? Now coming to the what Microsoft has. So under the XDR platform, Microsoft provides Microsoft 365 Defender. So as we go by the definition of the XDR, Microsoft provides all the capability that one XDR tool can can provide. So it's a pre and post. You can call it as a pre and a post detection, a tool that can like help you in detecting the breach, defend all kind of breach. It's a pre and uh, post breach enterprise defense suites that natively coordinate and prevents investigation and response across the endpoint, email, applications, and lot many things. So Microsoft has a Microsoft Defender has a capability to protect your identities like the machines or the endpoints that are there, uh, endpoints, cloud apps, email, and documents. It has lot of things. So it what it do is it leverages the Microsoft 365 security portfolio to automatically analyze threat data across the domain, building a complete picture of each attack in a single dashboard. Uh, it can help you in stopping the attack before they happen. It can help you and detect and automate across the domain. It will provide you the hunting capabilities as well. If you want to hunt a threat, you can do it with the Microsoft 365 Defender. uh, small information about the Defender suite. So I'm sure like you must have read it somewhere, that there is some naming convention change. So that happened like I think 1.5 year ago. So all the Microsoft threat protection, it will be known as a Microsoft 365 Defender. Defender for endpoint. So Defender for endpoint, earlier it used to be known as a MDATP. It will be known as a Defender for endpoint. So it uses the endpoint behavioral sensors, cloud securities, analytics, and threat intelligence to help enterprises uh, to, to protect their networks, prevent, detect, investigate, and respond to the advanced threats. Uh, Coming to the Defender for Office, so earlier it used to be known as Office 365 ATP. It's a cloud-based email filtering service that helps protect an unknown malware and viruses. Defender for Identity, uh, it used to be known as a Azure Advanced Threat Protection, but now it's uh, it will be known as a Microsoft Defender for Identity. So it help you and protect on-premises identities, correlate signals with the Microsoft 365. It will help you to eliminate on-premises vulnerability. So in this session, we are going to talk about how we can do the integration of the Microsoft Defender and empower the SOCs. So we are going to do the integration of the Microsoft Defender with the Azure Sentinel. Basically, we wanted to set up an integration with the SIEM tool and SO. And as far as I know, Azure Sentinel is the best in class SIEM tool that is available at the moment in the market. It it's a it has capabilities. It has all the capabilities of SIEM. It has a capability to provide you a automation. It can collect the data from the I mean, to be precise, it can collect the telemetry from the third party cloud, from the Microsoft cloud, or from the anywhere. Like it can easily integrate with the firewalls and many things. So it's a modern day tool. I mean, the advantages with the Azure Sentinel is you don't have to manage the SIEM environment. It is capable of doing it on own Microsoft because it's hosted on the cloud. So the cloud provider team will manage it. You don't have to worry about the license, or you don't have to worry about the elasticity of the tool. It is good enough to handle any kind of data, any kind of data volume. So, like once you set up this Defender and the Azure Sentinel, it's actually help you in setting the security operations center. So once you can do the integration between these best in class products, so both the products are from the Microsoft, and it will be very easy to set up the integration, right? So once the your integration is over, uh, or once your integration is successful, SOC can become more predictive, proactive, preventive. I mean, they can be a more preventive. So basically, what happened is like SOCs are always security or operation centers are always burdened with the alerts and the incidents, right? So there are a lot of data that are related to how many incidents at an average they get, but always they are buried under the incident. So they also need some time to do an analysis, right? When you have a lot of incidents, when you don't know how to identify the false positive or how to segregate the incident, then it becomes very difficult. And on top of that, like you need a correlation with the database. uh, Correlation between the data that is collected from the multiple sources. So once you do the integration between this XDR and the SIEM, and more precisely between the Microsoft uh, Defender and the Azure Sentinel, then it can help you in stopping the attack. I mean, before the attack can happen, both the tools can give you analysis. You can identify someone is trying to seek into your information or seek into your organization, or trying to identify the threat vector in your organization. You can prevent those all things. It can help you in detecting the threats across the domain by integrating the threat data for rapid and complete response. And it will, more importantly, it will allow security team to take a breath, and it will give them a time to do a proactive hunting for the sophisticated across the attack that can happen across the domains. So once you have like for the SIEM, we have the Azure Sentinel, and for the XDR we have the Defender. There is a inside the Defender we have a Azure Defender as well that can help you in protecting uh, the Azure resources as well. So once you have integrated, it's gonna give you the comprehensive security. It can help you in identify the advanced threats. It can help you in prioritizing the incident. So you, as a SOC, when you work on the SOC, you have to generate a, a thesis, or say a skill, how you can identify which incident should get the priority and which are the less prioritized incidents. So once you do the integration, you can easily prioritize these kind of incidents. And more importantly, you can build the automation. So most of the small kind of attack can be automatically tackled once you have the proper automation inbuilt, right? So now coming to the portals and everything. So I'm sure like you must be knowing how the Defender portal looks like. So this is the Defender portal. I'm gonna open it, and it'll gonna give us the information about the security scores, lot of things. I mean, I can view the incidents and the alerts that are generated over the Defender portal. So here I can see like I have configured few sample alerts, so that I mean I can give you a demo. So these are not the very serious kind of alert. These are just a small small kind of incidents that are generated. Okay, so coming back to the Defender portal, so here we have these all incidents generated, some related to the network, some related to the mailboxes, or some related to some script execution. So I have defined Bangalore location is my head offices, and I only want the VIP user to log in from these all locations. So if some normal user or anyone logs from the Bangalore location, I just have to review the things, because it's my prestigious location, it's my prestigious office. So I don't want anyone to log in from the Bangalore, but if someone logs in, there will be alert generated, so that I can analyze who is logging from the Bangalore location, and is he a legitimate user, because legitimate user to access my high priority resources or high valued resources. So there are lot kind of alerts, but when I start doing the analysis, maybe i I might be able to get the information uh, that is needed to troubleshoot in these simple kind of alerts. Yeah, it's very possible that I may have enough of information over the Defender portal, but when you get a very serious kind of attack, you may find that the information is not complete, or you may need some integration with some other kind of a tool, or you may need to do some correlation over the data. So let's look into the Defender. So here's my score, and a lot of things are there. this is my endpoint thing, and this is my security center. So these are the Defender portal where I can see my incidents and lot of things. I can do the threat analytics, but then very important thing is I will be needing two two SOCs, like the two incident queues. One will be for the Defender and one will be for the Azure Sentinel. But once I do the integration, I can have the single incident queue. So here is the Azure Sentinel. Uh, this is the workspace which I configured for our conference. So I will just log into it, and I did some correlation earlier to set up the thing. So once you log in here, you can see all the incidents that are generated in the Sentinel for rest of the thing, as well as the incident that are generated for the Defenders for the XDR platform. So it's gonna take a little bit of time. So let it load. Otherwise, you can see, right? Like right now, I have a zero alerts. I have a three incidents, and this kind of graph I can see a lot of information is coming. These are the incidents, right? Uh, so if you have the separate Defender as well as the separate SIEM, then you might have to manage the two different incident queues. But once you set up the integration, uh, everything can be done using one single queue, uh, one single incident queue. Here you can see we have uh, the the incident that are generated for the Defender as well as the other kind of incidents, right? Now the big question is how you will do the integration. What are the prerequisites? So now to do this kind of integration, there is, like, this can be done completed in the minutes, even in less than a minute. Only thing is you need a valid license for the Microsoft 365 Defender. If you are working in, like, if you're doing it for the organizations, you may approach the Microsoft and you can take their help for understanding the licensing. Lot of kind of the Microsoft also customize these licensing things, or can help you in uh, getting more with the licensing. And another important piece is you have to be the global administrator or a security administrator to do the integration. If you are like if you don't have these privileges, then you may have to open some incident or some case within your organization to get someone on the call who has these privileges. And believe me, it's not going to take more than a minute. So in one meeting you can set up these all things. So let's move to how we can do the integration. So if you don't know how to create a Sentinel workspace, you can go to the Sentinel, and from here you can create the Sentinel. So basically Sentinel doesn't have its own workspace. It uses the log analytics capability for creating the workspace. So either you can create the new log analytics workspace, or you can link it with the existing log analytics workspace. So I will just give you a 1 minute demo how to create a workspace. So here you have to define the resource group. So I will just call it as a demo, Azure Community Conference 2021, and I'm going to just put it in the East US region. And simply I'll do the review and create. And then once my workspace, log analytics workspace is ready, I can link it with the Azure Sentinel, Azure Sentinel. So it'll hardly take 1 or 2 minutes. So here you can get the deployment status. So this deployment process is going on. It's very easy to create the configure the Sentinel as well, or to configure the log analytics. Basically log analytics is something that do the uh, end-to-end monitoring. It can help you with the availability monitoring. It can help you with the performance monitoring of the resources or the application. Log analytics is a part of the Azure monitor. So anyways, now our workspace is ready. We can just integrate it with the Sentinel, and once you do this, add your Sentinel, your Sentinel will be ready. So let's see, it'll not gonna take 1 minute. So here you can see you have best in class SIEM tool ready. So how easy it is, like if you compare it with the on-premises uh, SIEM tool, that where you have to configure the databases, you have to configure the licensing, lot of things, machines, servers, everything you have to configure, and you need a very big team to manage those all environment. But here, with few clicks, you can do all the things. So this is my Sentinel configuration is ready. So this is how you can create it, but I'm just gonna go to my pre-configured Sentinel workspace because that has lot many things that we can see. So overview page, once you are at the overview page, you can see the snapshots, like how many events you have collected, how many alerts you have, how many incidents you have. You can see some recently generated incident. Here you can see lot many graph that can tell you about the increase in the in, increase in the data, the telemetry, or you can have this world map also. So if any potential malicious activity is getting performed, then you can see it over the this world map as well. Okay, now coming how you can do the integration between the Defender and the Azure Sentinel. So what you have to do is you have to go to the configuration, and basically here you have to configure the data connectors. So if you are running the SIEM, right, you need some data, right? You need some resources that can send the data. So data can be collected into your SIEM using this data connectors. So data connectors are someone that's going to collect the telemetry from the devices or from the endpoints or from the services. So there are a lot of data connectors available at the moment. There are around 116, and it's gonna, like, it's not something that you always have the 116 data connector. In future, this number can go up to anything, like every month you will see increase in the data connectors. So our thing is we have to configure the Defender thing. So you have to select the Defender. At the moment it's in a preview, but very soon it will be out of the preview. So what you have to do, just select the data connector Defender and open this connector page. So open the connector page, and once you open this connector page, it will have all kind of instructions that are needed. So here you can see all the instructions that are needed, and here you can read about the Defender, I mean about this data connector. So what this data connector is going to do is a Microsoft, it'll tell you what is Microsoft Defender. And once you integrate, you can have these many workbooks are kind of a dashboards. You will have these kind of queries, you will have lot of analytical rules that can generate the incident, and these are the data type for which you will be having the data, right? So what you have to do is, I mean, it's always good to read about these all things, and I have all the privileges, like I have all the permissions, I'm the global admin, so I'm not getting any error. But if you not a global admin administrator or a security administrator, then these things might be grayed out, or you will see these things in the red. So once you met all the prerequisite, you met licensing criteria, just come here and simply do the integration. So uh, you can see, right, like you have to first click on this connect incident. If you don't want the duplicate of the incident, you can uncheck this box and click on connect incident. So once you click on the connect the incident, what it is going to do is whatever the incident that are generated over the Defender portal, those all will be arrived into the Sentinel. And if you want to collect all kind of data sources that are there in the Defender, you can select all of them from here. Once you configure uh, these data sources or data types, then you will have the these data types in your Sentinel as well, and then you can correlate with the other tables, right? So for say these all brings up the device specific information, device info, like information about the machines, lot of things are there. And in the same way, we have it for office also, email events, and lot of things are there. So once you do this one, check these all things, you will have this data in your Sentinel workspace. So it's just doing the validation. Hardly it takes a minute or two. So once your validation is done, your configuration will be ready for the deployment. So while we are doing this, let me generate some test alert on my one virtual machine. So I'm just gonna run some PowerShell that will help me in generating some incident. Let me run some command. And let me send out some malicious email as well. So I have configured some sensors. So what I will do is, okay, I will just forward this email to my users. Sorry, let me pick up something. This email to the users K1, and then I will just try to attach some executable so that this email will get identified as some threat or something. So, and I will just put some URL here. Say, let me open some. Okay, so I generated this email. So within a minute or two, we will have some alerts generated in our environment, and you will see those all alerts are arrived into the Sentinel as well. So yeah, so once your integ- integration is done, you will see like something like this one. You can go to the next steps also. Here you will have uh, some workbooks or say some of the sample queries that you can do for doing the integration, or you can use these analytical rules for uh, generating the incident. So let's see, this integration is generated. So this Microsoft 365 Defender, it can bring all the uh, incidents that are generated over the Defender portal to the Sentinel portal. It can help you in getting a lot of telemetries, data types, everything into the Sentinel. So let's look into the thing. So once you do this setup, you will have capability of doing the incident integration. As I said, you can stream all your Defender incidents into the Sentinel. You can do the correlation. These incidents are like a bi-directional sync. Either if you are making any changes to the incident on the Defender portal or over the Sentinel portal, both will be reflected at both the places, right? So we have these many data connectors. So one which we have configured like 365 Defender. So the difference between these rest of the connectors is this: once you configure the 365 Defender, it has capabilities of bringing the data types, incident, everything. But if you choose any of the individual incident individual data connectors like this one, then what it'll gonna do is it'll only get you the alert or the security incident, not everything. So it'll only get you the alert. So these can also be configured, or you can same way if you select this identity. So it'll only get you the security alerts that are generated, not everything. So these are kind of already configured. Okay, so let me go back. So uh, as I said, like we have the connector capabilities. Connector can pull the data. In the same way, the Defender connectors are there, and these can be configured. So here you can fetch the alerts. You can fetch the the telemetry, you can create the rules and lot many things. So these were the prerequisites. So let's first see what all data we are getting that are related to the Defender. So let's see logs. I can go to the logs, and here let me run some query. I'll say search Defender and say distinct dollar table. So it's going to give me the list of the table in which I have the keyword Defender. So these are some of the tables. So let's look into the device event. So device event at the moment is showing me the information which is very much specific to the XDR, but I need to correlate it with the other things, right? So I process some of the PowerShell command uh, over my machine. So let's try to do some kind of correlation. So this is the device event and the Sentinel that is uh, helping me in collecting the event log. So I'm just trying to do a correlation between this event table as well as the device events. So events are connected using the SIEM. This is just an example. In a practical world, you may have to do a integration between bigger scenarios or a bigger tables, but for a time being, I'm just using this event table. So event is a event log table that's collecting the system specific event logs from the machine, and device event is something that's gonna getting me information using the XDR. Now, how you can do the correlation? Either you can do some join statement like this one. So here, what I did is I have done some filtration. So PowerShell command that I executed. So if I just run this command individually, let me run this KQL query here. So this is gonna tell me about the PowerShell information. Now I just wanted to understand when this is executed, is there anything into the system or the uh, application or anything into the event log? So what I will do is I'll just try to do the join. So right now I'm just using the very basic join statement. Uh, Only thing is when I run this query here, when I run only this query, then the name, I don't have any computer name, a column that can be used as a computer name. So here it is a device name, and in the event it is a computer name. So I might have to, like, if I go this way, I may not be able to join because there is no column, common column, right? So what I did is I have just extended one computer and uh, converted this into the upper cases, because the issue that I see is here the device name is in the small, in the lower case, and when I run it for the event, they are into the mixed cases. So what I will do is I will just convert both of them into the upper cases, right? So here you see I converted into the upper cases, in the upper cases, and once I do the join, I can have the correlation between the system event logs as well as the device event, right? So let's say if we are getting, so I'm also collecting the syslog from the Linux environment. So this is the syslog. The name of this computer, my first RHEL, it's a Red Hat Enterprise Linux. So let me search in what all tables we are collecting the data for the RHEL. Distinct dollar table. Okay, perfect. So see, I am collecting the data into the device event, device info, device log on event as well. So these all are the XDR specific tables. So let me just see what are there in the device log on events. So this is information about uh, the account, right? So let's do a correlation between this one and the syslog. So let me see if I have anything in the syslog that can map it to the user. No, I think I can just do the mapping at the level of the host name. So what I will do is I will just pick up the something called device events. to a device. So here what you can do is device name contains. So I will just include. So if you like, if you're new to these queries, then you can make use of this UI for generating the queries. Simply, you can use these options, include, you can do the extend operations as well. So I did this thing where device name equal to this. And then uh, you can shorten these all things, or device event distinct device name. Okay. Can use extend what syslog is using. So syslog might be using something like host name. Extend host name equal to device name, and then do a join syslog on host name. So we may not be able to see the data at the moment because some more formatting is needed, but basically once you have these all kind of data, it will allow you the options of doing the correlations. For example, like if you have some email, I created one query for the email information as well. So uh, email attachment is there, and then I can do the integration, I mean the correlation with the UEBA, like UEBA, uh, uh, user entity behavior analytics is there into the Azure Sentinel. I can do it. If we are collecting the sign-in logs, right? If you are connecting the sign-in logs in the Azure Active Directory, then you can do the correlation between these all things as well. So it will allow you to do the correlation, and more importantly, you will have one single queue where you can view the incidents. So here, this is a single queue. Here I can view the incident that are generated into the in the Defender portal. So once you select this incident, it will directly allow you, either you can work it using the Azure Sentinel, or if you want to do the analysis over uh, the Defender portal, then you can simply just one click and it will take you to the Defender portal as well. So you can gather the information here over the Defender portal as well, or like see, you can see three alerts are generated, three users are impacted, these three users got a email, or like it's a external email found, or these three mailboxes are there. And here also, once you start doing your full analysis, full detailed analysis, then you can view it, these all information over the Sentinel as well. So here it will give you the name of the computer as well. You can like do some kind of a further analysis. So once you have these kind of incidents, right, it'll uh, uh, you can do a lot of kind of correlations. You can have the single unique incident queue and lot many things, right? Now coming to the presentation. So yeah, uh, like if you want to do further customization over the incident, then if you want to create some analytical rule and you want to do some kind of customization, then you can create this using the Microsoft incident creation rules. So this incident creation rule is something, it will make use of the existing security services. So I'll say uh, ACC defender alert, and I will just choose bring the alert from the Defender for endpoint. So whatever the alerts that are generated into the Defender for endpoint, that will be that can be integrated into the Sentinel. So these things are actually done using the data connector, but here I just want some kind of customization. So I just want to collect only the high or say medium alert. I don't want to collect low or information, right? And I can apply specific kind of a alert, or I can do specific kind of alerting, right? So I will just do this, review and create. So my incident creation rule is also ready. Now it can bring up the data from the Defender portal, right? Uh, so this is how you can bring this configure the incident creation rule, and it will help you in bringing the data, right? uh, Bidirectional sync we have seen here. I mean, you can make any changes to the incident, right? Like you can add a comment or anything, the same will get reflected to say test alert, please ignore, and I will just assign, change it to the active, apply. Let's change the severity to high, apply, and owner, I will just assign it to. So now whatever the change I did, after some time, the same thing will be reflected to the to to this portal. It may take 1 or 2 minutes or around 5 minutes, and but then it can be reflected here as well. So that's called bidirectional sync. It'll allow you to do the bidirectional sync as well. Uh, and the most important thing is the hunting capabilities, right? Hunting is something like you can do the proactive search to identify how many resources are compromised, or what all at the stage that can be uh, compromised, right? So if you have these all tables, these all are few tables that comes from the Defender. We were doing one example here, right, when we were trying to write some correlation queries. uh, Once you have this device info, device events, you can do the uh, correlation over the Sentinel tables. One example was here, I was just trying to do the correlation between the email attachment, or uh, there is heartbeat table also, like when attack happened on the machine, was that machine able to send out the heartbeat? Those kind of a correlation can be done here. So in nutshell, like once you set up this kind of integration, it's gonna help your SOCs, right? SOC will have one single incident queue. They have the options to do the automation as well. They have lot many options, right? So once you set up this kind of integration, you are actually powering the Defender tool, as well as uh, the SIEM tool for doing the for enabling your SOC to work more efficiently, right? So yeah, that's all about the sessions. uh, my session, I hope you enjoyed and learned new things. So if you wish to reach out to me, if you have any questions around the around the Sentinel or the Defender or this kind of integration, you can tweet me over uh, my Twitter ID at KeshavJan13. You can reach out there, or like there are few blogs that I write. You can refer to those blogs as well. And yeah, a very big you thanks to our title sponsors, Microsoft, eBay, community partner, learning partner, uh, Fathian, Packet developers, Road Ahead, and to our communities as well. So yeah, that's all about my session. So let me know if you have any questions. I will try to answer those all questions.
So, Keshav,
Yeah.
yeah, thank you very much, Keshav. So one of our participant, his name is Hema Raghavan, has just raised one question. So, like, when does the well architecture session starts?
Okay, I think is he referring to some uh, other session or not sure like about this question. Uh,
Okay,
is
Keshav,
he,
just not an issue. Just we can skip it out. No problem.
yeah,
So really, thanks for spending your time, Keshav. So we are grateful, and the effort you took to share your thoughts and the experience with us was very good. And also, just we are looking forward to join with you on another great sessions in our upcoming
sure.
sprints. Okay.
Okay,
Yeah. Thank you,
thanks.
Keshav. Thanks for your time. Yeah.
Thanks a lot. Okay, bye.
Hi, Sriram.
Hi Jyotish,
Yeah. How are you?
I'm doing good. How are you?
Yeah. Fine. So shall we start, or just we can wait for?
I'm ready to start. So the question was about my session, the well architected thing. So I'm not sure the person was asking, and it got directed to the previous speaker. So he should have had no clue at all.
Yeah. 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 I think he got surprised.
Yeah, exactly. So,
Okay, Sriram. So really, thanks for joining with us today. So before we get into the sessions, just I want to give a short introductions about Sriram. So he has a 13 plus years of experience as a techie, and he has started his career as a .NET developer, and currently is working as a Azure Solutions Architect at Secure Cloud Technologies. Also, he is a passionate about cloud technologies, distributed systems, site reliability engineering, and architect practices. With following it that, now he has joined with us here to talk about Azure Health Model as a well-architected resiliency practice. So, Sriram, the stage is yours. Please go on.
thank you, Jyotish. Let me go ahead and share my screen.
Yeah, please.
So before I get started, kudos and applause to the Azure Community Conference organizing committee. So you guys are doing a wonderful job, and thank you for the opportunity as well. Uh, a brief summary about me, and Jyotish already briefed you, and that should be sufficient. But in addition to that, I am a practicing Azure Solutions Architect. Uh, so all the solutions that I try to implement, I try to document pretty much all of them in my GitHub. So that's my GitHub handle, and you can connect with me on LinkedIn if you're interested in if you share the architecting journey. And I do make sure that I blog all the technical findings along the way. So Ram's Easy Tech Page Stratton is where I blog all my technical articles. Today's topic is going to be about Azure Health Model as well-architected resiliency practice. Um, okay, so if people have already heard about the health model term, and if you have been working in the ASP.NET environment for quite some time, you would have already come across this particular term. And the health model should have been a practice you'd implemented at some point to understand the health of the dependent components that your ASP.NET website is talking to. But that becomes a system at a smaller scale. In this session, we'll be trying to look at a system that's much bigger in scale, consisting of many moving parts and many multiple components that are deployed on the cloud. And we'll try to see how the health model can solve the problem of understanding the reliability of your system. So I'm trying to structure the content of the section into three portions. Wherein the first portion will be talking about the problem that we're going to try to solve. Okay. In the section two, we'll come up with a conceptual architecture or a proposal that will uh, address the solution, address the problem with a suitable solution. And of course, that solution can be expanded and implemented in many different ways. And the last section is going to talk about how the solution can be adopted in different environments, be it a product-based setup or just a system running in the cloud. Okay. So this is just a split of all the content. So once you get the slide after my session, you can probably go ahead and read through all the technical information that I tried to capture. Okay. So starting with the first section, which is about talking about the problem, we'll be talking about monitoring of the distributed systems and the inherent problems, and why just the monitoring of distributed systems using the conventional ways is not going to be sufficient. Uh, all this while you would have seen that people who have been running distributed systems on the cloud, be it public cloud or hybrid cloud, you would have seen that all the components in the system would be instrumented, and we would be collecting the metrics and the logs of those components, and then we would be examining those. And there is a reason that these are called raw data, and there is also a reason why we want these data to be kept raw and not processed. And when I say raw data, the monitoring data that you receive from all the components in the system, we're talking about the CPU percentage, disk read rate, the memory pressure, and so on and so forth. And when we talk about distributed systems, we cannot, of course, skip to mention about the application. So the application will also be instrumented using an appropriate, instrumenting mechanism, and then we'll be collecting the application level metrics. That can be HTTP statuses of your request, the latency, connection status, and so on. Talking about public cloud, if you have your systems running on the Azure or AWS or any other public cloud, of course, you should be using some of the platform features as well. These are called the PaaS offerings. And sometimes IaaS or IaaS offerings are also important, and I would be using a mix and match of those. Okay. So this is a sample collection of charts that make up a dashboard, and this is a picture that is taken from a Grafana dashboard. As you can see, this whole dashboard consists of multiple charts, and the majority of information that you find in this dashboard are about the request status and the success rate. If you see the green colored box, it says 92.6% of success. So if you think about it, in this case, it's going to be one web application that operates over HTTP or HTTPS, and we have pretty much tried to gather all the metrics that matter to us, and all the metrics that pretty much tell us about how the system is working, and is the system keeping up with the expectations of the latency, the availability, and other SLOs. But the main problem with this kind of a dashboard is that we are just focusing on the metrics of one application or one component of the whole system. If we want to understand the performance and status of all the components, then imagine the total number of charts that you would end up with. Okay, so that is the problem when we're talking about a simple vanilla flavor of monitoring of distributed systems with so many different charts. Many of the companies that have embraced this kind of a culture, having specific charts, capturing specific metrics of interest, are still learning or getting used to these kind of monitoring things. Of course, these are very important, and these will form the the backbone of your system's resiliency. But this kind of a monitoring or this kind of a dashboarding mechanism will not give you an exact picture of all the problems with respect to reliability that your system has. Okay, so a couple of questions. One is that when you have multiple components in your system, people are now starting to again embrace the microservices architecture with containers and Kubernetes. So if that's the case, you have multiple microservices running, and each microservice using a different kind of a deployment mechanism in its own database. Then how do you know at real time or near real time if your component's health is deteriorating, or is your component working really well? The second question is that how do you derive the reliability status of the entire system, the bigger picture, just using the raw data? Even if you manage to instrument every single component in your architecture, which is going to be one of the mandatory practices in designing and architecting a system, you have checked all the boxes saying that all the components, your infrastructure components, your platform components, your application, everything is instrumented. But how do I get a picture of the reliability status of my entire system? So this is the problem statement for today's session. And the next few slides are going to talk about, will gradually slide into the solution, not immediately jump into it. But, this is the problem that we're going to talk about. Okay. So before we start talking about the solution to this problem, we would want to quickly touch upon a few of the site reliability engineering concepts. I'm not going to go deep into all the concepts because SRE is a topic of its own, and it does not require just one session but multiple sessions. First topic that we need to be familiar with is the critical system components. So when do you call a particular component in your architecture to be a critical system component? Is that if that particular component or a set of components fail, that can ultimately lead to the failure of the entire system in more than one way. Okay. And the set of components that are in the line of path, the critical system flows, are of course categorized as critical system components. To give you examples, I'll quickly talk about the critical system flows and then go on to tell you an example. What are critical system flows? The flows that represents the key functionalities of a system or product, and those which directly impact the end user experience. Okay, there might be portions of the application when a particular application or a product is designed, there might be portions of your application that are running in the background. This is a very common thing. This is known to every single person. But those portions of the application which are exposed to the end user, taking Amazon.com as an example, everything or any feature of your e-commerce app that the end user uses, be it your catalog search or product price comparison or checkout and payment and so on. These are all used by the end user, and these are going to be categorized as critical system flows. And all the system components, and again, if you want me to simplify that, all the microservices or the microservices attached databases and the Active Directory, the identity system that are tied to these critical system flows are called the critical system components. Okay. And since we're talking about reliability as a well-architected resiliency practice, the only SLO of interest in today's session is going to be availability. There can be multiple SLOs that will be jotted down when you start designing a system. The common things when your application is an end user facing application are going to be availability, latency, and the performance, the customer satisfaction, and those are going to be a few of the many. Talking just about the availability, for people who are familiar with all the SRE principles, it's going to be quite straightforward. Just bear with me. But for people who are getting familiar with the SLOs and the other SRE terms for the first time, availability is the uptime objective of the system represented as the percentage for a specific period. So if you've been working on Azure or any other cloud platform, you would have seen that some of the services are given an uptime SLA guarantee of 99.9% to 99.95%. And they call it SLA, but actually it is an SLO, and sometimes they are used interchangeably. But what do you actually mean by 99.95 is that Azure provides you a guarantee that that particular service, be it an infrastructure or platform service, would be available 99.95% of the time. So when you start designing your own system, a distributed system in cloud, you might want to start small and then expand. That's a different topic again. You would pretty much start with an SLO of saying 99.9% for 3 weeks or any rolling window period. And availability also tells you how reliable the system is. SLOs are sometimes tied to the whole system, and the percentage or SLA that I just spoke about is one example wherein the SLO is tied to the entire system. But you might have SLOs that dictate the performance of the system components internally. How is my database performing? How is my logging system performing? And these are not going to be of any concern to the end user, but these are going to be SLOs that need to be paid attention to. And the availability is going to be dictated by the availability of the critical system components. Like I mentioned, failure of the critical system components can lead to the failure of the system in more than one way. So it will affect the availability of the entire system. So taking the same example that we just quoted a few moments ago, if in Amazon.com, if your payment processing set of microservices fail in production, and it is not a transient failure and is taking some time for these services to get rectified, in that case, the end user experience would be affected. Even though the user can log into Amazon.com, the users will not be able to check out and make a payment and complete that process. So that would be a disastrous experience when it comes to any e-commerce shopping app. So the solution that we are trying to propose to address this problem, the disparate metrics and the sprawl of charts, the dashboard, and how to get information from all these metrics and charts to combine and get an information about the health of the whole system. Okay, health modeling is going to be a practice. I'll get into the details of the health modeling. Before that, modeling the state of the system's critical components. Okay, so when I say modeling, I would be pretty much focusing on what is the current state of the system's critical components. So are they working perfectly fine? So if you want to answer that question, are they working perfectly fine? Then there should be a few yardsticks or a set of metrics that will dictate the efficient working level of your components. Okay. Should indicate at real time the reliability state of the entire system. So we touched upon this point in the previous slide. Ultimately, if these components are talking to each other to complete a transaction, then a cumulative availability or reliability status of these systems will indicate the availability status of the entire system. Even if not the entire system, at least one particular flow of the end user experience is going to be impacted. But in cases wherein if your system is using Microsoft's Azure Active Directory and you are relying on Active Directory to complete your end user authentication and authorization to a certain extent, and out of the blue, the Azure Active Directory goes down, then you would be in for a surprise. Your entire system might be down, and there is nothing that you can do about it unless Microsoft rectifies it. So that will be an example of the reliability state of the entire system being impacted or being brought down by one single component. Okay. When we talk about health modeling, the ultimate purpose of health modeling is to surface the health of critical system flows. And while doing that, during the modeling of the system components, we would be classifying the components as either healthy or unhealthy. Okay, so what Microsoft is suggesting as a part of their well-architected framework's reliability pillar is to use a traffic light model, and this is the reason I said that people who have been using the ASP.NET's health model system would be familiar with the term, but you would get to see how we are applying that in a different context. So talking about traffic light model, it is quite simple comparing to the traffic light in our signals. We'll be using 2 or 3 signals. Green indicates healthy, and the other 2, amber and red, might indicate needs attention and unhealthy. So it is up to you to use 2 or 3 signals. Amber might be optional, but in general, a component which is in the degrading state, which is not reached the state wherein the component is totally not available. In that case, it'll be in the amber status. Okay, and 2 important things when you're designing your health model system are the health model system should focus not only on the infrastructure, but should focus on the application level matrices also. Okay, and the second point is that, excuse me, your health model or the way that you instrument your distributed system and have the information collected from that distributed system should be aware of transient failures. So there should be a way that you distinguish recoverable failures and the true disaster state. If a particular component goes down for a very brief period of say 5 seconds, and you do not want to create a signal that instructs the health model as a whole to mark that particular component as unhealthy or mark it as in the red status, and then take the subsequent actions to either bring another system up or try to repair it and so on. Okay. The last point is another key point. So where does all the monitoring data that we're gathering today fit in the picture? So all the monitoring data that you've been gathering or the systems have been emitting, the metrics and logs and traces, of course, would help in building the status of the components and the health model. So we're not trying to do anything different. We're not trying to reinvent the wheel. We are trying to build a couple of layers atop your monitoring solution that you've been using today with multiple matrices, dashboards, and charts. Okay. So this is a reference system architecture that we'll be using today. Just a reference system architecture. And if you are interested in knowing where the system architecture is, this is an architecture that's prepared from two reference architectures from Microsoft's architecture library. Highly available n-tier system. So we got a couple of tiers. So we are going to focus only on the components in the primary region. Okay. A brief walkthrough of all the components of the system and how the traffic is going to flow. We're not pretty much interested in trying to execute the system as a whole, but we are trying to touch upon the points wherein we categorize a set of components as critical and non-critical. Okay. In this case, any user who is trying to access the application would, of course, be directed using the traffic manager. And we have a layer 7 load balancer, and your web application is running in virtual machine scale sets. And then we have a SQL server always on availability group running in a set of virtual machines. Okay. And we have the same setup deployed to an alternate region as well, with some asynchronous replication configured. And as mentioned or as discussed, one of the topics or one of the ways in which you're going to handle authentication is going to be using Azure Active Directory. And before any health model can be designed and implemented, of course, there's going to be one of the several checkboxes that you tick when you are designing and architecting for the cloud scale systems, is that you want to know that all the systems are instrumented. We would want the diagnostics logs and matrices from the Azure managed layer 7 load balancer as well. And the similar thing is applicable to the virtual machine scale sets and virtual machines. And as mentioned in the previous slide, we would want the application level matrices of the application that is running within the virtual machine scale sets. So I've used the Azure's native monitoring capabilities. For application level monitoring, we're using the application insights, and for a consolidated solution wherein you can bring everything under one roof, you're going to use the Azure Monitor. And application insights is a solution that is made available under Azure Monitor. But just to differentiate the purpose of these two solutions, I've put them separately. Okay. So this is the reference system architecture. So I would want you to visualize that this is a system that we're talking about that has been deployed in the cloud. So if we were to build a health model system that indicates the reliability state of every single component that is in the line of critical flows, and provide us an information of the reliability status of the entire system. Okay. I'm going to zoom this a little bit. So this is a concept architecture that we have come up to address the problem that we've been talking about all this while. I've not taken all the components from the previous system architecture. I've taken only 2 or 3 components. One is the layer 7 load balancer. The second one is the virtual machine scale sets, which is hosting the ASP.NET application, and then the application itself. Okay. So the things that you see in the boxes would be the things that you've been doing even today. Okay. If you've been instrumenting the application gateway, not using an external agent because it's an Azure managed service, but you would be configuring diagnostic settings in the application gateway. If that's the case, then you would want to determine the set of matrices that are of importance to you when determining the state of the entire system. Okay. So in this example, since the application gateway is the one that receives the end user request, we would want to know the number of healthy hosts, the number of healthy backend instances, okay, and the gateway total time. If SLOs, if the set of SLOs that you are concerned about also includes latency, for the reason that your system is going to be highly performant, but the end users cannot tolerate any kind of latency in the system, then your system latency is a key metric that you need to be worried about, and the total number of failed requests. Okay. And similar to that, you will have corresponding metrics in the virtual machine scale sets and an application. So one thing that you would be doing when you have an application running on the cloud are the dependency failures. If you've not been doing, then it is the right time that you pay attention to this, because all this while we're talking about critical system components, and these critical system components work together to complete a transaction or a flow. And without these components talking to each other, then these components would be in isolation. So for that reason, one component can be related to the other component as a direct dependency. So in the previous system architecture that we uh, yeah, we just assumed or we used. In this case, the SQL databases that are running in the always on availability group is a direct dependency to your web application. So if you're using a cache for all the read scenarios, then the cache is also a direct dependency of your the web application. And the layer 7 load balancer is a critical component. I wouldn't call it a single point failure, but it is a critical component, because without the application gateway as the entry point into the region, you would not be able to receive the end user request even if traffic manager is working fine. Okay. So modeling the application to capture the dependency failures and the latency and application availability tests, these are also important. The other two important things that Azure provides, but many of us are not mindful of the fact that these are also important matrices, and these have to be considered are your service health and your resource health. So when we are talking about application gateway or Azure AD or any service that is being managed by Azure, Microsoft Azure provides you a way to be notified when any of these components are impacted, right? So these are called the service impact and then resource impact. A service impact can be global if the resource that you're talking about is a global thing. It is not if it's not a regional one, and it can be a regional one. In that case, the Azure components or Azure services that are hosting all the virtual machine scale sets of all the customers in East US 2 is impacted. There can be a number of reasons. It can be due to a network failure. It can be due to any other reason that happens in the virtual machines and the instances being used. Okay. And other one is a resource level failure. So for all the components that you can access an instrument, be using the log analytics agent or Microsoft monitoring agent, or if you are a person from the open source world, then you can use any other kind of agent for that matter. For all those components that you can instrument using your own agents, that is going to be a mandatory step before you get ready for the system to be rolled out to production. But what if some of the components, in addition to the diagnostic settings, if you need to be notified if the system is impacted as a whole? So in that case, you will have to also subscribe to Microsoft's resource health alerts. So these are the two additional things that you need to add to your checklist. Okay. In this case, the first part is about instrumenting and identifying all the key matrices that are going to decide the reliability state of a system, and what matrices are going to decide the health modeling of your system. Okay. And in this case, it depends upon the team that is adopting this architecture or this solution. The alerts from these systems can be processed by a set of processes. So the primary mechanism can be in an Azure function. In this case, I've used just one function. I'll show you the code if time permits. Otherwise, it should be made available through my GitHub repo. But you can separate these into multiple functions if you're dealing with a very heavy system, and each function needs to have its own set of resources, and you would not want to have multiple functions sharing the whole Azure function space. So in this case, we've got one function each handling a particular type of an alert. One function for service health, resource health, platform health, and application health. Okay. One other mention that is really important at this point is that these alerts need to be in a very common format, so that the code that you write in these functions can be standardized. Microsoft has come up with something called a common alert schema. So before the introduction of the common alert schema, all these alerts are using a different set of schemas. So for that reason, there was no specific way of processing and validating these alerts using a common schema. Yeah, before we move to the part wherein we talk about how these alerts are processed and then taken to the health model, we would be mentioning also about a pull-based system. If you do not want a push-based system, if depending upon your alert processing requirements, if you want to perform multiple set of actions and not just the health model update, you don't want to stop at the health model update. You want to perform multiple actions like running an Azure automation runbook and then notifying a person and so on and so forth. So it's going to be a complex workflow. Then you can probably do an Azure Logic app and then configure all the steps that need to be taken when you're processing the alerts. Okay. And from this point, this is a very common architecture, and you would have seen this being adopted for a variety of purposes. We have made use of it to address our requirement as well. All these processed alerts, right, and these processed alerts would be converted into a definite model, would be persisted on the document DB. And the document DB would be making use of the Cosmos DB change feed processor. We'd be enabling that. And another function app that would work based upon the Cosmos DB change feed trigger would take all the processed alerts, and then using a SignalR service, we would be updating our dashboard at runtime. So be mindful of the fact that we are talking about updates to every single component in the whole system. So any change in the health of the system would be processed and appropriately updated in the health model dashboard. So in the next slide, I'm going to show you how a health model dashboard will look like. Okay, but the key part of the architecture in making the health model updates to your system near real time. I wouldn't call it entirely real time, but near real time is having the Cosmos DB change feed processor and SignalR. This is the first version of the prototype that we developed when we were trying to implement well-architected reliability in our organization. But you are free to expand this architecture to any levels and add multiple different capabilities to the entire system. Talked about all the components, I've listed them. So once you have the tech, you can go through the set of components to understand what each component does in the health model system architecture. So before going into how a dashboard looks like and probably showing you a demo, you would have seen alerts that get triggered from the system components, be it from a virtual machine scale set or even the application gateway. But the other part, when I was talking about the service health and resource health, this is one example from Microsoft side. And this is talking about an issue in the Azure's ARM. And people who have been working in Azure for quite some time know that, would be knowing that without ARM in its healthy state, your entire Azure system is going to suffer because ARM is the backbone of Azure. So we're talking about a case wherein the ARM isn't working fine, experience degrade availability. And Microsoft was working on getting the ARM back up. The start time and end time should give you an idea of how long the ARM system has been down. This is the kind of alert, or these are the fields and the information that you would receive from the Microsoft Service Health alerts. Just to give you a picture of how that would look like. Okay. Yeah, I was talking about a common alert schema to have a standard schema to standardize your alert processing capabilities. I've included a link or a reference to this common alert schema from the Microsoft documentation. So after the session, you can go back and take a look at that. The key points to highlight in this slide are the sections that are present inside the common alert schema. So the first section is going to be essentials, and the next one is going to be alert context. And within essentials, we're going to be interested in having the alert target IDs and the fire date and time and few other fields. And the alert context is going to tell us about what specific metric was this alert triggered for, and what was the scenario in which the alert had to be triggered, and how long did it take the Windows start time and end time, depending upon the configuration that you've done. Okay. So, and also people have been coding in .NET or any other language using JSONs. You should be familiar with the fact that it is a common practice to validate the schema even before you process the data within the payload. So in this case, if you want to validate the alert, then the common alert schema is what you would validate on using. Okay. Before I show you the actual dashboard, I just wanted to show you a conceptual dashboard that we came up with when we were designing the health model system. So this is how you would have to picture it. You will have to have the components listed, and with each component, there might be subcomponents, and the subcomponents actually tell you the resource health. Again, resource health and service health are from Microsoft, and the platform metrics, whatever you're interested in, depending upon your use case. And we would try to do the same thing for application gateway, the web service, and application insights, of course, going to give you a picture of how your application is performing, and then the SQL service. And if you are a person who is working on some kind of a lift and shift migration, wherein you haven't yet adopted the past services in Azure, so it's not going to be quite straightforward to understand the status of your system with respect to reliability. And if you've been using technologies like WSFC and always on availability groups, then probably you should try to tap on the features of PowerShell for SQL. We haven't really tried that, but you can try to run a PowerShell script that tells you the status of your Windows Server failover cluster and also the SQL on availability group. And that data can be retrieved from the cluster and then used to be projected on the health model dashboard. In addition to that, as shown in the reference architecture, any highly available system, if the system has been designed to be present in 2 different regions, then we'll have the status of the entire system in 2 different regions represented using the appropriate traffic light. Okay. Another point that I would be showing you using the prototype implementation is that in this case, taking the web service, the virtual machine scales as an example. If any of these matrices indicate an unhealthy state of the virtual machine, okay, a CPU percentage spike or failure of health probe instances or total number of failures that is beyond the tolerance limit to SQL service. If any of these are in the unhealthy state, then the cumulative status of your web server is going to be unhealthy. It cannot be a scenario wherein you have your virtual machine scales, it's working fine, but the internal ASP.NET application is not working fine, but still you can call the component healthy. It has to be the case wherein every system component or subcomponents work well to actually name or actually uh, tag the status of the component to be healthy. So in this case, if the failure request count goes beyond the tolerable limit, then the application gateway's overall failure state is going to be either in amber or in red. And since we are trying to create a dashboard that gives you a near real-time picture of your system, you would want to capture the status when the last check was made. Okay, this is a visualization of how the dashboard should look like. So I can show you the dashboard and then we can quickly jump onto the demo. Okay, so some of the data has already been retrieved from the Cosmos DB. I'm going to show you the setup before actually doing a demo. But visualizing the dashboard that I showed you from a spreadsheet, this is how it would look like. So the virtual machine scale set, we're talking about general thing, resource health and service health. Do not mind the date because this is old data. And if you're going to talk about the platform, then the percentage CPU is only metric that we configured because it's just a prototype, but you might be having many. And the same thing with web applications. using application insights, things that we were worried about, or things of concern were request failed count, dependencies failed count, and request duration, if latency is to be addressed quickly. Okay. So I'm going to quickly jump on to Azure portal and then give you a brief of all these settings that I had to do. So for the purpose of this demo, I'm using just one virtual machine that is running the site. Instead of deploying the entire system architecture, which is going to be really, really heavy, I had to simplify and then deploy the site to just one system. So this is the e-commerce on web application that's available as a part of Microsoft's GitHub repo. So if you want to experiment with any website for that matter, you do not want to code something from the scratch, you can very well use the e-commerce on web. But if you're a person who's been practicing on containers and then you want to use the containers and Kubernetes, then there's an equivalent called e-commerce on containers as well. So you can use either of these repositories from Microsoft's GitHub and then get started with it. So the first information that I wanted to quickly show you is the configuration of alerts. Nothing fancy here. Since instrumentation is going to be a key to have the health model giving you the actual data, we would want to have all the components instrumented and the right set of alerts configured. The only metric that we are concerned about is the CPA percentage. Okay. For the purpose of this demo, I've configured the condition to be the percentage CPA is greater than 50. Okay. And yeah, this information is important. In the action groups, the notifications and actions are to be configured. You would be doing this as a part of your regular practice. Notify the admin, the person who needs to react to the change in the system status. In addition to that, according to the proposed system architecture, the other part, the action that you need to configure should be your function app. If you recollect the architecture, would be having a set of functions, either within the same function app or a set of function apps that will be receiving the alerts, that will be processing the alerts, and then would be storing them in the Cosmos DB. So for that matter, you would need to create an integration between uh, the Azure's monitoring system and Azure functions. So I've selected one function app that is also running uh, in the context of the same system. This is important when you configure this and the previous one. Since we are placing more emphasis on the common alert schema, you should be mindful to toggle the switch. Even if you're not configuring using the common alert schema, it is quite okay. It is not a deal breaker, but you should be mindful of the fact that you're processing a schema that would probably processing an alert that would probably correspond to a different kind of a schema, even before the common alert schema is introduced. So your processing logic should be written appropriately. Okay. So the set of functions that have been running in my function app, as shown in the architecture, are one function per component. So this is for the platform related notifications or health changes, and this is for the Azure resource level health alerts and Azure service level health alerts and application level health alerts. If you want to actually test the application, even before having all the components put together and the system working as a whole, taking any common alert schema that gets triggered out of your experiment, be it a spiked CPU or a memory pressure, whatever it is, you can take that alert and use the code and test feature of your Azure function to actually test it out. If your function is written properly, then feeding the common alert schema should be able to process that alert and store it in the Cosmos DB. Okay. And the last part of the setup that I wanted to show was that The Cosmos is a NoSQL database, needs no introduction, and it is a schema on read but not on write. But again, in this case, we would be declaring a view model. When I say view model, people who've experimented or people who've used MVC to any capacity, be it with ASP.NET or be it with any other MVC framework, knows about a view model. Corresponds to how the model can be used to represent the data in the view. Um, I hope this is visible. In this case, we have processed the alert and captured all the necessary details as such. Okay. Uh, Component name, ID, the model type, and in this case, the model type is necessary to actually build the component name is necessary to build the accordion, as you see in the health model. We should be categorizing all the matrices that are present for a particular component within that component. So the model subtype will actually tell you what is the matrix or the system information that we're capturing. Okay. The other details are going to be about when the alert was triggered and what is the severity of the alert. In the case of health model, we wouldn't, in majority of the cases, be worried about severity 3 or severity 4, where these alerts are strictly informational. A normal email to the admin should suffice. But severity 2, 1, and 0 should be acted on immediately and would, of course, change information in your health model as well. This is the structure of, or this is the model of data that is getting persisted in your Cosmos DB. The same case with the application gateway, and the data is going to vary. But otherwise, since we're talking about a common alert schema, we are also making it a point to have the view model capture just the information that is required, not everything. Okay, so this is about the setup. Quickly jumping on. Yeah, before I show the demo, this is how the actual dashboard would look like. I showed you that. I'm going to show you a demo also. A brief explanation of the code after we actually kickstart a process that will trigger an alert. By the time the system has or system is in a position wherein we have a case wherein the component is in a critical state, it would take some time for the Microsoft monitoring and Microsoft monitoring tool to create the alert and then send it to the function app, and the processing happens from there. Okay. So I'm going to keep it to a resized window, and using just the virtual machines, we're going to demonstrate how the health model gives you an information of the overall status of the system. Okay. The alerts are already in place for the virtual machine. The virtual machine is running and the application is also running. In this scenario, we are worried only about the percentage CPU. So if the percentage CPU goes beyond a particular tolerance limit, the actual scenario in production might be different. If your virtual machine scale sets have been configured to scale out, then that will take care of it. This is going to be a transient phenomena. So please note that this is just a prototype. And the actual implementation in the production environments is going to depend upon a case wherein the failure happens past all the reliability measures that I put into the system. So if you're an architect like myself who's been architecting for cloud scale systems, and it becomes a duty to think about reliability in the design phase, then you will be including all the reliability based measures in the design phase. The system would have all those in place even before it is getting deployed. And if a particular failure happens beyond a point wherein the reliable system can handle it, or due to a shortcoming of the design decision, then you would be having this kind of a scenario wherein the health model of the system or the components in one system critical flow would be impacted. Okay, to simulate a situation wherein the percentage CPU of the virtual machine goes beyond 50%, right? We'll be using the chaos engineering technique. If you haven't used chaos engineering or interested in knowing more about chaos, I'll be speaking about the chaos engineering as a SRE principle and how it can be done in Azure at 3 p.m. But for now, uh, just ride along. I'll show you how to run this thing. In this case, the virtual machine that is running on Azure would be instrumented with the chaos agent, which means that the chaos agent would already be running on the virtual machine. And in this case, it makes connection to the chaos dashboard, and you're free to run any kind of attack for that matter. So I've chosen the one host, which is the virtual machine in the context. So with the free tier, Gremlin provides you with these options. I don't want to get into the details of all these. Resource, state, and network. For this demo, we'll be using just the CPU-based chaos. So we have configured the attack to be running for 90 seconds, and the CPU capacity would be 80 cores and would consume all the cores within the virtual machine. For any kind of configuration, the virtual machine could have been created. Okay. So to begin with, the status of the system is in healthy state because green indicates healthy. So started with the chaos experiment. It will take some time for the system to for the CPA percentage to spike above 70 and stay there for a while so that the system knows that it should raise an alert. Because we talked about a concept wherein your health model shouldn't be reactive to transient phenomena. And even after that, all the matrices that the log analytics agent or the Microsoft monitoring agent collects from your virtual machines would not be sent to Azure immediately. There would be a little bit of delay. And that little bit of delay is what actually separates the real time and near real time. Okay. Let this go on. I'm going to have this window alone, the actual dashboard alone. So we'll see what happens after the alert gets created. Okay. The application scenarios of the Azure Health model. So where do you actually apply the health model? We have talked about this enough. It can be applied to any complex system that runs in the cloud with so many moving parts, and it is distributed wherein you do not have all the pieces of an application running in one virtual machine. You have it running in multiple different services that are deployed in multiple regions and so on. So we have talked about the first point wherein it should be mapped to the individual user flows. Okay. And I just wanted to quickly talk about the second point as well. So if you have been an organization that is working on product development, but you have your product deployed on the cloud or uses a product uses a subset of the cloud features. Okay. Even in that case, there could be scenarios wherein a failure of one particular component can potentially take out your entire product as such. So we also talked about the case of Amazon.com being an e-commerce shopping app. If there is one service that fails along the way, then it can pretty much bring down the entire shopping experience of the customers. So this health model does not necessarily apply to only systems that have been running on-prem or legacy systems or any web-based application. This is pretty much applicable to any product-based organizations also. The only thing is that the dashboard is going to be purely internal for internal consumption purposes only. This dashboard is going to be used by your SRE team if you have a separate SRE culture, or it's going to be used by the DevOps team to understand the status of the components on the system. Okay, so the attack is done. So it will take some time for the status to be changed, because the status would be modified only when the actual alert is received, processed by the function app, persisted in the document DB, the change feed happens, and then again processed and then pushed onto the dashboard. Okay, so if you see the status of the the virtual machine platform subcomponent has changed to red. In this case, I'm treating the CPU percentage spike to be a totally disastrous state, which might not be the case in your scenario. For production grade machines, many of these scenarios are going to be self healing. Like I mentioned, if you're auto scaling with the virtual machine scales, it's going to handle it. Then probably you might have to mark it in the amber state. Again, it at least gives you an information saying that if your virtual machine scale sets contain about 5 instances at that point, and if 3 of the instances are having an increase, okay, this is the alert that has been triggered, the email notification for that. If 3 out of the 5 virtual machines are having a percentage CPU consumption of over 70%, which actually tells you or gives you a picture of what's going to happen in the next few minutes if that trend is going to continue. If that percentage CPU is not going to come down in the next few minutes, then ultimately the blast or the impact radius is going to expand from 3 virtual machines to 4 and then on to 5. If you have set the total scale out limit to 5, then you'd be in for a surprise, because if all the 4 or 5 virtual machines have the CPU percentage going above 90, then of course your application would start degrading gradually. So this is the alert that has been triggered. I'm in the virtual machines monitoring window. If you can see it clearly now. So this is the excuse me, the monitor screen from your function app indicates that your function app has been invoked. And very quickly jumping on to the Cosmos DB, yeah, the Cosmos DB actually tells you that we have an alert that was triggered on the 30th at UTC. And the percentage CPU, yeah, the component is a virtual machine, subcomponent is platform health, And the subtype is percentage CPU, and it's unhealthy. And once that is marked as unhealthy, we'll have the Cosmo change feed processor triggering this information about an update of the document that carries the details of the system. Okay, now you see that the system has gone back to the component has gone back to the green status. Okay, let me get to that quickly. But after this, the signaler gets the update from the function app that processes the change in the Cosmos DB, and this app gets the real-time update or near real-time update. Okay, the reason that this is changed back to green is that since the chaos experiment was run only for a duration of 90 seconds or 2 minutes, the systems of the virtual machine CPU did spike, and it lasted only for 2 minutes. After which, the CPU percentage came down. So in this case, the virtual machine is no more in the alarming status. So, when you create an alert, you can probably decide if you want the alert to be resolved automatically when the condition that is given for the resolution email, but the condition that you've given to create an alert or trigger an alert is not met anymore. Which in case, in that case, it tells you that the system is not in the alarming state anymore. If you want your system to mark it accordingly, then you can toggle an option saying that automatically resolve alerts. So this is the prototype implementation of the whole health system model. You would be implementing it for all the components for all the key matrices, but um, try not to get over ambitious and configure every single minute detail. Then you would be reacting to pretty much every change in the system. So when you're designing for reliability, highly reliable systems are going to require careful design. And beyond design and architecting, in the portion wherein you talk about monitoring, and of course a health model is a solution that Microsoft proposes in the monitoring section of well architected. Try to make judicial decisions of what really matters and what will dictate the reliability of a component. And if that component is critical, then should the system be marked in amber or red as a whole? Or if it is, affecting a specific flow, like in the case of Amazon.com, the payment is affected. Then the scope can be wherein this health model dashboard mm, will be showing information in the context of that team alone. If there is a particular product team that handles the payment gateway and checkout process, and they own a set of say 20 or 30 microservices and their appropriate databases and other dependencies, and they deal everything in an isolated way. Of course, it gets integrated into the shopping site ultimately before rolling on to production. But if they need information about all the services and the databases and dependencies that they handle, not to mix it with the whole system status, and you might want to create a dashboard that specifically talks about the components in their line of flow, A to B to and then Z. Okay. Yeah. Mention the references, health modeling for reliability. If you want to read about Microsoft's suggestions of what a health model is and suggestions of why a health model is needed, then go on to the well architected framework documentation. And if you want to know more about the common level schema, then that's available in the documentation as well. The implementation is available in my GitHub repo, but this repo is at present is a private repo, so I'll be making it public in the next couple of days. So if you're interested to try it out, just taking this as a base and then expanding the whole system in whatever way that you want, or probably build a very big health model system or take it up from there. I'd be happy to provide more information, but this report will be made public in the next couple of days. Yeah. So yeah, thank you to all the sponsors, Microsoft, EY, Elastic, and the learning partners as well, and our communities. Of course, they are these are the people that are spreading the the love for Azure and the information, which is a wealth. I'm open to questions now.
So, hi Sriram. So,
Hi,
yeah, just have a water.
I'm ready.
Okay, fine. So, thank you very much, Sriram. So, that was a wonderful presentations actually. So, I
Thank you.
have spent more time to prepare. I think it's a guess, but really it was a very grateful time, and the effort you took to share your knowledge was it's completely amazing. Okay. So, once again, thanks for your presentations, and we look forward to our next interaction soon.
Yeah, which is at 3 p.m. So if you're
Yes.
interested in, if anyone is interested in chaos engineering, then I'll be talking about it. It is a very interesting topic, and you'd be welcome to join me on that.
Sure, sure, definitely, Sriram. Yeah. Take care, Sriram. Bye bye.
Okay, thank you.
Hi, Ashirwad.
Hi Jyotish, how are you?
Yeah, fine, Ashirwad. How are you?
I'm doing good. Thank you for asking.
Yes, and thanks for joining with us today, Ashirwad. So, for next 60 minutes, Ashirwad will be speaking about the topic on build a real-time soil moisture monitoring system with Azure Functions and Azure IoT Hub. So before we get into the session, let me give a short introductions about Ashirwad. Uh, Ashirwad is working as a software engineer at the Mindfy Solutions. Also, he has expertise in building scalable applications with the .NET Core and a deep understanding of building applications using .NET Core and Azure POS. So, Ashirwad, the stage is yours. Please go on.
Thank you for the warm welcome, Jyotish, and it's always a pleasure to host a talk at EasyCom. So let me share my screen and let's get started.
Yeah, please carry on.
Okay. Just give me a heads up if you're able to see my screen.
Sure, Ashirwad.
Okay. So I'm ready to start the session, right?
Yeah, sure, Shirvat. You can go ahead.
Okay, perfect. So, hello everyone. As Jyotish has previously, gave a really good introduction about myself. Let's talk more about the topic, which is quite self-explanatory. That is, build a real-time soil moisture monitoring system with Azure Function and IoT Hub. So, in this particular talk, we'll be trying to build up a solution using which we can get real-time updates about the soil moisture level of our crops and plants wherever they are with the help of a sensor, and process them using IoT Hub and Azure Function. At the end of the solution, we'll be sending alert to our users to notify that the soil needs some water, or your crops or plants need some water, because the water level is really low with them. So this has a lot of scope in the agriculture sector. Like, you can use it for smart irrigation and many other purposes. So let's get started. Before diving deeper into the topic, I'll just list out some of the prerequisites that we need to follow along with this talk. The first thing that we need is an Azure subscription, because we are using Azure IoT Hub and Azure Function to build the solution. The second thing would be some experience with .NET, but yeah, it would be really helpful if you have some, because all the demos are based on .NET. So yeah, some experience with C# programming would be really helpful. General understanding of Microsoft Azure is sufficient to follow along with this particular talk. So I'll be talking about what IoT Hub is, what Azure Function is, before starting up the demos. So don't worry about that. The next thing is, what are the key takeaways from the talk? After going away from this talk, what you're going to learn? The first thing that you're going to learn is how you can create an Azure IoT Hub in an Azure portal, and how you can register a device in Azure IoT Hub. The third thing would be, you'll be able to create an IoT device simulator, because it's not really possible for all of us to get our hands on the hardware devices. We just got an idea and we wanted to build a quick prototype of a solution. We wanted to get started, but due to some constraints, we were unable to buy the hardwares that were required. So we can make a device simulator to prototype the whole solution, and you can use the simulator to send the telemetry data to our IoT Hub. So we are going to learn that after this session. The next thing is, we are going to also see how we can send messages to IoT Hub from our device simulator. And finally, we are going to create an IoT Hub message processor with the help of Azure Functions. And with the help of this function, we are going to store our data in a Cosmos DB, and as well as send an alert to our customers, notifying them or alerting them that your crops or plants need some water. So let's get started. What is IoT? It's a trivial question, right? What is IoT? So I'd like you folks to just type in what your thoughts are about IoT in the chat window, and we can obviously discuss about them at the end of the session. But just take a minute and write something over there, and we are going to talk what IoT is before jumping deeper. Okay, I'm pausing for 15 seconds. You can just type it off, and we'll see what are your thoughts on IoT and the scope. Okay, so maybe this picture would help us visualize what IoT is. We have some set of devices, and we have some thumbnail in the middle, which is looking like a cloud or an internet gateway. And we have a human brain kind of a thing, which should represent something like processing. And then there's a machine which can represent something like an action. So if you ask me what IoT is, I'll say that it's a connection of a set of devices which are sending telemetry data to a cloud gateway or to a network server, where these telemetry data are being stored, and these data can further be analyzed and processed to gather some insights, and we can take some data-backed decisions using them. So this is what a typical IoT solution would look like, and the definition of IoT is pretty much justified here. So if you wanted a more formal definition, then I would say that it's a network of physical devices that can connect and exchange data with other devices and services over internet or any different communication protocol, like MQTT or AMQP, something of the sort. So now that we have some idea what IoT is, let's look at some of the scenarios that we can face in our day-to-day life, which comes under the umbrella of IoT solutions. Let's say you have a smart home solution. Let's say that after you go out of your home, and let's say you miss to turn off the lights of a couple of your rooms or fans of a couple of your room. You want to, you want these devices or these fans and lights to be automatically shut down when you close and lock the door while going out. So this comes under the umbrella of IoT solution. So let's say that somebody uh, let's say that somebody is in front of the door and you want to open the door whenever somebody is in front of it at the proximity of 10 cm or 20 cm, you automatically wanted to just open the door. So that also comes under the umbrella of an IoT solution. So there are a plethora of examples out there in the real world which comes under the umbrella of IoT solutions. Now that we have uh, explored some of the use cases, let's see what kind of solution, what an IoT solution would typically look like. So just like any software solution, an IoT solution would also have multiple components, multiple modules that are associated with it. So here you can see that in the image, I have a set of devices which are in the orange, which are inside the orange colored block. So one of them is IP-enabled devices. Then there are a set of low power devices. There's something called field gateway. So all of a sudden, if you look at it, it might be confusing you a bit. But if you remember in the previous slide when we were discussing what IoT, IoT solution will consist of some set of devices which can connect with each other or with a different service with the help of a communication protocol like internet or like the HTTP protocol, or just like AMQP or MQTT. You do So for that, we need to be connected with the internet, right? So how do you get, how can you connect with the internet if you don't have an IP? So the IoT devices which have the capability of some devices which don't support, don't have this power to connect with the internet directly. So this can be small microprocessor, or embedded devices which don't have the capability to directly, connect with with the internet directly. So they can use the separate protocols like MQTT or AMQP to connect to our cloud gateways or. So now that we have discussed what IP-enabled devices are and what field gateways are, let's look at what's a cloud gateway. So we're trying to send the data gathered by our IP-enabled devices or the field gateways to somewhere, right? We want to store this data somewhere. We want to get this data from the devices and store it somewhere so that we can process it later. So where do we store it? So we use something called a cloud gateway, which can ingest the data that is being generated by these devices every second or every minute, depending upon the case that we have defined while building up the solution. So these cloud gateways act as a message broker kind of a thing, in which which stores the telemetry data for some certain of time. So typically, you define a time to deletion, time to deletion for each of your messages. So until that particular duration is over, these messages are going to store at the cloud gateway. So the next thing is an event processor. So we don't have something explicitly known as an event processor, but I mentioned it because we want to process the data at the end of the day. We need to the data, or it's in the JSON format as we are defined. So, but we needed to be structured in a particular format, right? So we do that with the help of an event processor. So event processors comes into the picture here when we want to process the data that's there in the cloud gateway, and we want to store it in a structured way or somewhere, right? So we process our data here, and we wanted to store it to gather some insights, or do some analytics, run some models on them to gather some insights about the data that was generated from the devices. So what our process the data like an or else maybe blob storage. If the frequency of accessing data is low, you can store it in a blob storage as well. Then you can do some analytics and perform some insight on it. So you can do a stream analytics job on top of it. You can show some charts, something like that, using Power BI. So these kind of things we can definitely do. So now that we know how a typical IoT solution would look like, let's see what's the requirement that we have in our hands. So the requirement that our client gave us was that we need to build a mechanism to get alerts whenever our crops need water. Looks simple, right? So, but the scale of the solution is huge, and this particular gentleman, who is our customer, has over 100 acres of land, and he wants to monitor whichever crops need some water, because he is living in a place where the water level is very low, and he wants to monitor whenever the crops need water. Hello. Okay. So I think I'm
Yes, Ashirwad, we can hear you. Please continue.
okay. Perfect. So we need a mechanism to get alerts whenever our crops need water. This mechanism is built in a
Ashirwad, we couldn't able to hear your voice.
Hello.
Yeah,
So
still
the
we couldn't
thing is,
able to hear your voice, Ashirwad. For some time, your voice is getting muted, and later on it's getting on.
okay, just give me a moment. Okay, now it should work well. So if you face any issue while hearing my audio, just let me know, and I'll work on that.
Sure,
Okay.
Ashirwad. Please continue. Yeah.
Okay. So I'll just just say it again. What the requirement was? The requirement was that we need to build a mechanism to get alerts whenever our crops need water. And this gentleman, who's a customer, is living in an area where the groundwater level is very low, and he wants to use the water really efficiently. So the thing is, he wanted to get a solution that he get a solution through which he can understand when the crops actually need water, and just not start up his drip irrigation mechanism just all the time. He wanted to have an intelligent solution so that he can use the water smartly. So we came up with a solution to solve this problem. So the solution was something like, we'll put some of the IoT devices in certain sections of his crops. Let's say in one acre we are going to put something like 3-4 sensors. So total we are going to have we are going to put something around 400 sensors across the 100 acres of land that he has. And what we're going to do is that we are going to send alert every time the conductivity level of the particular area in which we have put this particular IoT device has gone below a certain threshold. So then we are going to send this we are going to gather this information about the soil conductivity level every second. So, and we are going to send it to IoT Hub. So IoT Hub acts as a cloud gateway over here, and our IoT device sends the telemetry data to this IoT Hub. And when when this message comes to our IoT Hub, and IoT Hub triggered function will start running, and this will act as an event processor over here, and this will try to check whether the soil conductivity level was above or below a certain threshold. So if if the value of our sensors go below a certain threshold, then we need to send an alert mentioning to the customer that at this time your crops or plants need some water. So you can start up your drip irrigation mechanism to put some water over those areas of the crops. So we are also storing this data in a Cosmos DB, so that we can do some analysis over it over time. Let's say that we have been using the solution for over 5 years, and we have sufficient data. So for later purposes, we decided that we are going to store these data in a Cosmos DB, perform some analytics over time. So So we are going to send emails to Cosmos DB is going to be our the data storage option, and the event processor is Azure Function. Cloud Gateway is going to be an IoT hub, and the IoT device will be simulated with the help of a device simulator that we are going to build using the Azure IoT Hub device SDK. So here you can see that I have added a column of low power devices and field gateways. So right now in our solution we're not using one, but typically if you have a scenario in which you're using an embedded device, or else maybe a microcontroller based device which doesn't have the capacity to send the message directly to the IoT hub, you can always use the help of a field gateway. In our case, it will be an Azure IoT Edge device, so we can use that to send the data from our low power devices to IoT hub to the solution. So this is how the overall solution looks like. And let's before diving deeper into the code, how it will look like, I'd just like to give you a small understanding of what IoT Hub is. So we are using a couple of components here, right? So as you can see, we are using IoT Hub, we are using Azure Functions, we are using Cosmos DB and SendGrid. Not many of you would be aware of some of the components. So I'll just give you an overview about it. So what IoT Hub is. So IoT Hub is a fully managed IoT solutions offering of Microsoft Azure. It provides you with a couple of features. One of them is device authentication. You can authenticate your device using the access keys, or let's say it's more like a SaaS token that can be generated when we register our device over there. Or they can also use certificates to authenticate your device. So with this particular feature, it helps us keep a tab on the devices which can send data to our IoT hub. So if you don't have the security mechanism, then what will happen is that any device that's connected to the internet can just start sending data to our IoT hub, and we don't want that, because the number of messages that can be sent to our IoT hub is pretty limited, and we don't want to compromise on that, right? We don't want unnecessary data or malicious messages to go inside our IoT hub. So with the help of this device authentication feature, we can restrict a set of devices to only send, or the authenticated devices to send telemetry data to our IoT hub. The next thing is to store metadata for a device. So normally, I won't have just one device and just have a couple of information like the device ID and all the stuff. So sometimes we have some requirements, like we want to store additional information about the device, and we want it to be visible in the device registry, or else we want to have a database which will show us about this device information. So let's say that we are a big manufacturing firm, and we are deploying a lot of what do you say IoT solutions, and we are sending IoT devices to our customer on the basis of a subscription. So we wanted to store a couple of data about about the customer with the IoT device. We want to add some tags. So we can absolutely do that with the help of device twins. What we can do is that we can tag a particular device with a particular customer and specify for how much time this particular device is going to be active, and after also define when this device is gonna be available, or it can just start sending messages to our IoT hub. So there can be a lot of things that we can do. So the next thing is multiple communication option. As I have previously mentioned, that an IoT device can send data to an cloud gateway using multiple communication protocols. So suppose an IoT hub supports multiple communication protocols for which it can receive messages from devices like MQP and MQTT, or else HTTP. So the next is client and cloud SDK. So developers are provided with client and cloud SDKs, which they can leverage to build their own custom solutions. So if you wanted to build a solution from the scratch, and you wanted to have all the say about it, and wanted to use IoT Hub, then you can leverage the power of this SDKs or client packages, whatever you call it in the language that you prefer. So you can use them to build a solution. Like in this particular demo, we are going to use the client SDKs of IoT Hub to create a simulator and send telemetry data to IoT Hub. So with the help of the cloud, similar to this, with the help of cloud SDKs, what you can do is that you can retrieve the number of devices that are registered in the device registry of IoT Hub, or else maybe activate or deactivate a particular device by changing the status as enabled or disabled or something like that. So there are a plethora of options. Apart from that, you get first-class integration support with the other Azure services like Azure Event Grid, Azure Event Hub, or maybe Azure Function, Azure Logic App, or Azure Stream Analytics Job. You get a lot of support over there. So that's all about IoT Hub. So what is Azure Functions? it's a fully managed serverless service, and we are going to use it to, what do you say, process the telemetry data that has been sent by devices to our IT hub. So what is serverless? You may have this question, what is serverless? So serverless basically means that you're building a solution for which you're only going to be charged every time they are running. So whenever your server or your application is not running, you're not going to pay any money for that. So that's what serverless is. So let's look at what else it is. So it's a function as a service. So you can create multiple functions, and it's like a small chunk of code. You're creating a small chunk of code for the respective business, and you're deploying it over Azure to work. So this can have multiple bindings and triggers. The triggers are something like an event which starts your Azure functions, and bindings are a declarative way in which you are going to connect with a data source or write something into a data source. So we are gonna discuss about the triggers and binding later in this session, while creating the Azure function to ingest the data from an IoT hub to an Cosmos DB. So next is it provides microbilling, as I told you that you're only going to be charged every time your function runs or your application runs. So it comes up with a microbilling plan. So you're sorry. So you're only going to be charged for every second and every compute that you use. Nothing more, nothing less. I support multiple languages. You can build your functions using .NET, Java, Python, and if there is not a language which is supported yet and you want to use it, you can create your own custom handler to build one, I guess. So that's about Azure Function. So what is Cosmos DB? So Cosmos DB is a fully managed NoSQL database as a service offering of Microsoft Azure. It's a highly scalable offering, and you get enterprise-grade security. It supports multiple APIs. APIs in the sense, let's say you're using MongoDB and you wanted to interact with that the way you normally do with your MongoDB workload and move it to Azure for scalability, for security reasons, and you want to remove that, but you still wanted to use, want to communicate with it the way you are doing it right now. So you get the MongoDB APIs for Cosmos DB, which you can leverage, and same with Gremlin and Cassandra. You get the respective APIs to do those kind of operations. So what is SendGrid? So SendGrid is the final block of our solution, and we are going to use it to send emails to our customers as alerts. So email is a alert mechanism that we are going to have in a solution. So SendGrid is a cloud-based SMTP provider that allows you to send email without having to maintain your own email servers. So you may say that I can why can't you use something like use SMTP to do it? The thing is, we don't have the port access to any of the any of the servers inside which our function runs. So yeah, you have to use something else over here. Maybe a graph API is a good option, or else maybe you can you can use it with the help of a logic app by sending the email to a message queue mechanism and then trigger it with the logic app and do something with that. But again, that's a tedious step. So yeah, I'm using SendGrid. So the thing is, you get a SendGrid output binding out of the box. But the thing is, I'm not going to use it because it's a pay-per-use kind of a thing. And if I use the SendGrid SDK to build our solution, we get a free trial of sending 100 emails per day. So why not use it for free? So yeah, so that's about SendGrid. So let's get started with the demos. Enough with the talks. So the first thing that we're going to do is that we're going to create an IoT hub in Azure Portal. So let's get started and go to Azure Portal. So as I told you, you need an active Azure subscription. So I'm in my Azure Portal. So let's create an Azure IoT hub. So let's search for an IoT hub over here. So I got my IoT hub over here. Let's click over here to create one. So in this particular screen, you're going to see the list of all the IoT hub that you have in your subscription. So right now I don't have any. So I'm going to click on create to create a new one. So now we have to enter a couple of information. So I have a resource group already, so I'm going to use it, rgazconf. Then I'm going to give this IoT hub a name, Azure Conf Hub. Let the location, let the region be as ACS for the time being, and give the connectivity configuration as public access. Next, the management. So here you can configure, the number of S1 IoT hub units. So this actually depends upon on the basis of this, you can also, determine how many messages you can consume, your messages per day that your IoT hub can consume. So, but I'm gonna go with the free tier because we are doing a demo and I don't want to be incurring any cost for it. So with the F1 tier, you get these things, like you can send 8,000 messages per day, and the cost is 0 because the free tier. Then, but you don't get defender for IoT, or else there are a couple of restrictions. So, but you can send device to cloud messages, and you can have your own message routing, as well as send some cloud to device commands, like your IoT hub may be running on an Raspberry Pi or something, and you wanted to update your operating system, you wanted to send command, you can absolutely do that by using cloud to device commands. So it also supports IoT Edge. Like in some of the tires, you don't get support for that, but yeah, you also get the support for device management. Like you can enable a device, disable a device whenever you want. So rest, the role-based control, I'm going to let it be as it is, and then I'm just going to have two partitions, nothing more. So I'm keeping everything as they are and move on to next. So I'm not adding any tags over here, but if you're building a solution and for you're building an enterprise solution, then it is highly recommended to give tags so that it will help in your building purposes. Let's click on review and create our IoT hub. So it does a validation check before letting us create. So the validation passed. So let's click on create to create our IoT hub. So it will take a couple of seconds maybe to provision our IoT hub. So in the meanwhile, let's go back to the slides and see what's the next thing that we want to do. So the next thing that we want to do is that we want to register our devices in IoT hub. So how do we do that? To send data from our devices to IoT hub, we need to register them over here, so that they will be identified as authenticated devices which can send data to our IoT hub. How do we do that? So let's go back to the Azure portal and wait for a few seconds till the deployment process is complete. Let's give it a few seconds. It shouldn't take longer. Okay. Let's wait a minute. Usually it doesn't take such a long time, but I think the demo guys are not pretty happy with me. Let's see. Well, let me refresh it. I hope it does get completed. Okay, so the resource is created. I'm going to the resource, and our IoT hub is almost ready. So we can start with the registration process. So you can see all the information that you had entered, well, the provisioning process, like I selected F1 tire, the location and everything. You can see it over here, as well as, you can see the number of messages that were consumed, or else the number of active devices or devices that are there. So connected devices refer to the devices which is actually sending data to your IoT hub. And the total devices are something like the total number of devices that we have, and we have been creating. So device to cloud messages are nothing but the telemetry messages that are being sent from the device to our IoT hub. So that's the thing. So to register our device, we need to go to device management and click on devices. So once we go to devices section, we'll get an option to add a device. So right now you can see I don't have any devices as of now. So let's create one. So to create one, or to register a device over here, I'm going to click on add device. So once I click on add device, I'm going to say simulator. Let's keep it as AZCOM simulator. So as I told you, there are multiple ways of authentication. So I'm using the system metric P1. It's going to give me a connection string after I click on save. So it's going to automatically generate that for me, and I don't need to give it. Alternatively, you can also use this, CSIM certificate or self-signed certificates for authentication. But yeah, I'm going to use with the system metric key. So then you have this option to enable or disable a device when they're being created after they are created. So I want it to be enabled by default. So you can add parent devices too, but I'm not interested in the parent devices for the time being. So now that the device has been created or registered in our device registry of IoT Hub, I'm going to get the primary connection string of the device. Okay, so that's how you do it. And if you wanted to send any device message to the device, you can absolutely do that using this option. But we can also do it with using the cloud SDKs of Azure IoT Cloud. But before going to the part of creating a device simulator, I wanted to show you something else. So let's add one more thing. Let's add a few more simulators. One. I'm just quickly adding a couple of devices so that I can show you how you can query for devices over here in IoT Hub, as well as activate or deactivate an device from the IoT Hub port, from the Azure portal. Okay, so let's say I'm getting as device 2. So right now I have 3 devices. Everything is enabled by default. So I have an EasyComp simulator, device 2, and EasyComp 1. Now I'm going to disable this device. So how do I disable this device? So to disable this device, we just need to click on disable over here and click on save. So this is for enable connection for IoT Hub. You just need to select it. It's disable over here and click on save. So once you do that, this particular device too will not be able to send any messages or telemetry message data to our IoT Hub. So let's go back over here and see how we can query, about devices from our Azure portal. So let's say that you wanted to know the list of devices, so which are actually what we say, which are enabled. Okay, so by default you can get all the information over here. Just click over run here, and you'll be able to get the result of all the devices. By default you would get all the devices over here, but okay, now this is, again, just give me a moment. Portal is acting a bit weirdly. So let's go back to queries. Okay, so here you can see this query is pretty much similar to our SQL queries, and it's just select restrict from C. So C represents the whole device registry table over here. Let's click on run, and this will give us the result set of all the devices that are there along with the metadata. So you can see the update time. So it's just randomly given there. So yeah, but you can get the other things too. So here you can see there's something called connection state is disconnected, and but the status is enabled. So what is status? What is connection state? So the connection states represents as connected whenever the device is being sending data actively in a uniform frequency. So if your device is sending data every second, then the connection state will show as connected instead of disconnected. But the status, if it is disabled, then the device is going to fail in authenticating itself to send telemetry data to our IoT Hub, so they won't be able to send the data in the first place. So this is the difference between the connection state and status. So let's copy the status, and let's try to write a query to find the list of devices which are enabled. So it's pretty simple. So I'm just adding a where clause over here. C.status is equal to enable. So if I run it, I'm going to see the result set of all the devices which are enabled. Okay, did I make a mistake anywhere? Things happen wrong. So enabled. Okay, let me go back and remove this over here and see. Probably we are going to get the results. Okay, so I shouldn't have used the C over here because it was in the parent key value pair itself. So yeah. So here you can see that all the devices which have their status as enabled are being shown, not the one which is disabled. But if I wanted to see something which was disabled, how do I do it? Disable. So we are going to see device 2 over here now. So as I told you, we are able to see the device 2. So the next thing that we need to do is that let's go back to the slides and see what's the next thing. We have registered our device, we have created the IoT Hub. The next thing is send telemetry data to the Azure IoT Hub from the device simulator. So we need to create a device simulator and send telemetry data to our IoT Hub. So tough task, right? So for this, we need to go back to the devices, and what we need to do is that we need to get the connection string of the devices. Okay. So for the simulator, we need this primary connection string, or we can use the secondary one. So I'm copying the primary connection string and going to my Visual Studio. So here you can see that I have a couple of projects already. So I created for the in the interest of time, and So the first thing is, you can see that there are a couple of projects. So the function project we are going to discuss later. Okay, so the first thing is I have created a console project, so whose name is soil moisture device. So I'm going to use this console application as my device simulator. So the first thing that you need to do after creating your console application or the console project is that you need to install this particular SDK, which is Microsoft.Azure.Devices client. So with the help of this client SDK, we are going to send our telemetry data or the simulated telemetry data to IoT. So once you add the device, we are good to go and start, building our, device simulator. So the next thing is that you need to create a device client. So for creating a device, for creating an instance of device client type, the thing that we need is the connection string. So where do you get the connection string? So I copied it from here. If you remember, I told you that I'm copying the primary connection string, and I'm going to use this connection string to create our device client object. So I'm hard coding it here, but it's advisable for you folks to use something like store this information in an application request, or else maybe app setting in the data or something like that. It's not really advisable to hard code it over here. The next thing is that here you can see that I'm creating a device client object using the connection string, and I'm using the transport type as MQTT, but you can use other communication protocols as well. Like if you do this, you'll be able to see a lot many protocols, but let's keep it as MQTT for the time being. So next, I'm trying to send 5 simulated messages. So I have this count in using a wait clause over here to send 5 messages. So I have this method called send message. So it's like I'm sending in a gap of, first I'm waiting for 10 seconds to start the program. Then I'm putting up a delay of 1 second after, to send each of the messages. But, you can send it real time. But I've defined the frequency as 1 second to send each of the messages. So that's the purpose of this task of delay here and here. The next thing is that we are making a call to the send messages method over here, which is taking a parameter of device client type. So this is the device client that we have created over here, and we are passing it to the parameter. And the purpose of this method is to send data from the device simulator to the IoT hub. So we are creating a random value over here. So here I am just hard coding again the device ID, but you can always get it from you can use the device SDK to get the device informations. So I'll just show you how we can do that, but on the scope of this talk, to be honest. But let's say I'm just having something like a string. Okay, so it's a dynamic object, right? I don't know. So I'm going to go out over here and just say the string device name. Okay, let's not name it as string. I'm just going to keep it as for name. So what you need to do is that go to the device client and get the data. There's this method for that. Get between async, and this method is going to give you back a result of set.clean object. So here you can get all those informations. Like you can get the device ID. So from this ID, so this ID is the device ID or the device name that we had created when it was, when we were creating it. We can also get the status and other things. So we can do those things over here with the help of the device client object. But we are not concerned with it, and we are gonna, just create a sensor data model. So this is a custom model that I built. See here, you can see that there is another project over here. So this is a shared library. So it's a C# library project, and basically just contain one model, which I'm using in my function project as well as in my device simulator. So it consists of 3 properties. One is device ID, recorded at, and the moisture level. So what is recorded at? So I'm using it to just let my customer know, or my data or my application know when this moisture level was recorded from the device. So that's about it. I'm generating the moisture level value randomly over here. So I kept it as 700 to 500, but let's keep it as 500. So normally what happens is that a soil moisture sensor acts more like a conductor. It has, it tries to send a small amount of current to this file, and depending upon the conductivity, the conductivity numbers that it shows up as an output. And normally, if you consider the output an analog output, and it normally ranges from 0 to 1000. So higher the number, let's say it's more than 700, then this represents the resistance is pretty high in the soil. So that says that the conductivity is really low. So why would the conductivity of the soil would get low? If the amount of water that's present in the soil is low, then only the conductivity of uh, conductivity numbers would go low, right? So it's just like we learned in our 12th standard, if the conductivity is high, the resistance is going to be low. So so if the conductivity level is more than 750, we want to send an email alert. So this our case that we are going to build up. So I'm generating random data over here from 500 to 1000. So I have this method over here, get random numbers in range. I'm passing a range over here within which I need to create a random number. I'm using the random.next double method to generate it. So it's a simple thing. So after I created my dummy data over here, I'm serializing it in I'm serializing this into a JSON format. Then I'm encoding it. So the next thing that I do is that I use the send event async method of the device client object to send our data. So I'm passing in the parameter, I'm passing in the data that we had created over here, and sending it as a parameter and waiting for the result. Once it returns, I'm just returning a bool value of true, and display a message that message 1 was delivered. If there was any issue, and the bool would give back a return false, and then it will say message was failed. We weren't able to deliver the message. So now that we have discussed what the whole flow of the program is, let's run it. So I'm going to set it as my startup object and click on run. So in the meanwhile, go to the portal and see whether we got any messages prior to this or not. There will be a couple of messages because we were registering our device. So you will see that there were a couple of messages, I guess. Yeah, the total number of messages used. This was during the registration process, but we didn't get any device to cloud messages. So when we will start sending messages, we are going to see the numbers over here, but it normally comes in a delay of a few seconds or minutes normally. Let's start sending our messages. So I started it, and now my console application will mock the data and send a couple of messages. So as I said, there was a delay of 10 seconds before sending the first message. Then there would be a delay of 1 second before sending the rest of the messages. So it's waiting for the first 10 seconds to go. Then it will start sending the message. Message 1 was delivered, 2 delivered, 3, 4, 5. So 5 messages will be delivered. So once the 5 messages are delivered, let's go back to the portal and see whether the numbers changed over here. The device to cloud messages number changed. I told you it usually takes some time. So yeah, you can see the stat that the total devices that we have is number 3. So it usually takes some time, So, okay. So let's go back to the next slide and see this particular thing next. After we go and see what's the next thing that we need to do. So we have created we have created the IoT device. We have registered the IoT device. The next thing we have done is that we created also a device simulator and sent our messages to the IoT hub. So what's the next thing? We need to create an IoT hub message processor with Azure Function to process the data that's there in our IoT hub and do something with it. So what's that something that we are going to do? We are going to process it and check whether the moisture level was above 750. If it was above 750, then we're going to send an email to our customer saying that, hey, your plants need, your crops need some water, start up your irrigation process, whichever you have, and water them. Or else, at the other case, you just send the data and store it in a Cosmos DB container. So let's go back to the portal and just refresh one last time to see whether it updates the count. If it doesn't, we'll just go and get back. Okay. So you can see the message used today was 20. So here were the 15 number of messages we used, but additional 5 were there. So that's what was representing the number of messages that we sent from our simulator. So the next thing is that we need to create a function project. So you can create a function project by right-clicking on your solution, click on add, then click on new project, and select a function project template. So It's a pretty easy process, but for this, you need to have the Azure Function Runtime Code tool installed prior using this, or else your function is not going to run. Search for it, like go for cloud, and you will see the function projects, all platforms. Okay, here you can see the Azure Function template. Select on that, click on next, and put up your function project name and other things. So once you do that, go with a blank template, then or else you can just select an IoT Hub triggered function starting off. Then it will create a function over here that will be with the name of function one. So here I have created an IoT Hub triggered function. So to do that, what you can do is that after creating your function project, you can click on new functions. Then you need to just give a random name over here or a meaningful name. You can always change it after, but here you need to update the IoT Hub trigger name and the route of your IoT Hub, from where the messages are actually being stored. So the path is pretty much well defined over here, messages less events, but we can customize it if you wanted to send it to a different route. Then you need to specify the connection string setting name is the key name of your it's the key name in which uh, you're going to store your connection strings endpoint. Okay, so you're going to store your values for your function project in app setting.json. So here the thing that I did was that I have my I have created a key value pair called IoT Hub Con. So here I have given my endpoint URL over here for this particular key, so IoT Hub Con. So you need to put that one over there, and once you do that, you need to go back to the portal again. Let's refresh it one more time and see whether we received any device to cloud messages according to the stats here. If we don't see it, no worries. So we need to get the endpoint of our IoT Hub. So how do you get the endpoint URL? So for that, you need to go to the Hub settings section. Then you need to click on built-in endpoints. Now you need to go down and copy the Event Hub compatible endpoint. So under the hood, IoT Hub uses an Event Hub to ingest data. So yeah, so let's copy this one and go back to our connection string, app setting.json, and update the connection string over here. So this was some other value that I had used for one of my previous demos. So now that we have updated our connection string, let's have a look at the function project. So in the function, you can see that I have a trigger of type IoT Hub trigger, which accepts a message from the IoT Hub. So this message is gonna get the data about the telemetry message. So it's like you need to get the telemetry data from the message body.array to process it. So so this IoT Hub would again IoT Hub trigger would need the connection string. So it's gonna get the IoT Hub connection string from the local settings.json files, IoT Hub con, which we just updated. So the next thing that we will need is a route. So we have specified the route while we were configuring our while we were creating our IoT Hub trigger function. The next thing that we have here is the a Cosmos DB input binding. Sorry, output binding. Okay. So what we are doing is that we have specified the database name of our Cosmos DB, then the collection name and the connection string. So before telling you anything more, I'd like you folks to add a NuGet package before jumping deeper. So when you add the what we say IoT Hub triggered function, you're gonna you need to install these things like the event hub bus and event hub and service bus one. And the third thing that you need is that you need this to install azure.webjobs.extension.cosmos.db to use input or output bindings of Cosmos DB. So you need that. So you need to install this particular package. So once you do that, you'll be able to use the input output binding features of Azure Cosmos DB in your function projects. Okay, so once you do that, it's gonna you need to define. You need to first deserialize the values of the telemetry data. So it's like we had encoded the data before sending it to the IoT Hub from the device. So now the thing is we want to deserialize the object, and the next thing that we need to do is that we are performing a check whether the moisture level was above 750 or not. If it is, then we are invoking the send email async method. So here what we are trying to do is that we are trying to use the SendGrid SDK. Like let me go back to my NuGet package for this project. You see that I have installed the Nugget package of SendGrid, the SendGrid email SDK. I'm using this SendGrid SDKs to interact with SendGrid services to send emails. So what I'm doing is that I'm getting the API key. So the API key is there in my app setting.json. Okay, so I'm getting it over there, the SendGrid API key. So for that, you will have to create a SendGrid account and get your API key from there. So I've already created one in the interest of time. So the next thing that I'm going to do is that, okay. So the next thing is I'm creating an object here. I'm specifying the email address from whom this email was sent. The next thing that I do is I specify the email subject. I have pasted these things in my appsetting.json. So when I deploy this into my Azure function over in Azure, I can always customize it by going to application settings and modifying the key value pairs over here. So I can modify the value pair of these keys, and I can always customize it instead of hard coding it. So I have specified the email subject, recipient email, and email name. So the other thing that we are doing is that after we have configured everything, we are creating and creating a message object with the help of mail helper classes, creates a single email object. Then we're invoking the send email method of our client, SendGrid client object that we have created, and passing in the message. So once we do that, it will send a message, send this data to the SendGrid client, the SendGrid server, and then they are going to send the email to our customer. But at the end of the day, we also want to store all the data. So how do we do that? So we are going to do it with the help of the output binding. Cosmos DB output binding. So the Cosmos DB output binding have this particular thing called document out. So we will be using this particular object over here to this particular object add async method to add our data, add the telemetry data to our Cosmos DB. So I'm trying to convert it to an async method by using wait over here. But we can have a completely asynchronous function method as well. Since I was using a static void run, I just added a wait over here, but it's completely okay. So what I'm doing is that I'm creating a random GUID over here, GUID over here. I'm assigning it as my ID. The next thing that I do is that I give it a property named device ID and pasting the device ID here and record it, and just assigning all the values that my device actually sent. And I'm also logging those information over here so that we'll be able to see in the function runtime code tool. So that's the whole thing how we do. So prior starting the demo, what I did was that I had created a Cosmos DB account already in my Azure portal. So I'm gonna show it to you people. So I've created this Cosmos DB account. You can see that I have a database named. Let's go to Data Explorer and see how many databases and other stuff that we have over here. So let's wait for the Data Explorer to show up. So yeah, so here you can see that I have a database named MyIoTDB. So I have defined the database name as MyIoTDB over here, and the collection name as DevStore. So that's the collection name, or you can, if you're coming from a relational background, then you can consider it as a table. So then we have items. So prior to this, I ran some couple of demos, and these are the data that we have over there. But now when we start our function project, new data will be ingested over here or stored over here as items. So here, these are a couple of attributes or properties that Cosmos DB generates out of the box. But these are the properties that we are assigning with the help of our Azure function. So now let's go back to IoT Hub and see whether we got the message updates or not. So the messages are already there, but it takes some time to reflect those things over the graphs over here. So here you can see that the telemetry device messages received was 5. So now that we were able to see it finally, let's start the function project and start processing the data and consume it and start consuming it. So I'm setting it as my starter project, and then clicking run to start my project. It's going to start the function runtime tool, and we are going to process it. So everything is happening locally right now, but you can obviously deploy it to Azure and look at the scale and the power of Azure building such kind of solutions. So I can deploy it right now and do it too, but since we are left with 8 more minutes, I'm not going to do it. But yeah, this IoT Hub function is going to run 5 times now and going to consume them. So it just happened in a fraction of a second. So yeah, It was able to process all the messages, and it executed 5 times over here, and it was able to process the data. So here you can see the informations like, the Marshall level and everything. So the Marshall level was 843.797.817. So yeah, so we were able to do it. So let's see how many times it exists. So we have 1,500. We have 187. Okay, 2123. Okay. So we are going to get a couple of emails now. So if you remember, I told you that I've configured the recipient email somewhere in my local setting with JSON as ashurasatpuri.outlook.com. So let's see whether we got any emails yet or not. So here you can see, since 4 times the value was more than 750, the threshold that we had defined, we are getting 4 emails. So that's the thing. So we can always restrict it, like having a queue or something, and seeing that if we have already sent an email, let's not send it multiple times, so we can have those kind of mechanisms and improve our solution. But as you can see, our demo was working really well, and we were able to send an alert to a customer saying that, alert crop needs water, hey, the soil moisture level is low and we think it's time to water your plants. So that's how you build the solution, using IoT Hub and Azure Function integrated with the help of SendGrid and Cosmos DB. So we were able to create the IoT Hub. We were able to register our devices. We were able to create a simulator to send our messages. And we were also able to process the data with the help of Azure Function and store it in a Cosmos DB, as well as send alerts to our customers. So that's all for the demo and the session, and just bit of self-promotion. So this is a book that I have published of late, Azure Function by C#. So you can find this book using this link, bit.ly/AzureFund, or else you can always go to Amazon.com or Appress website to find this book and grab a copy of yourself. And do share your feedbacks, whether you like the session or not. I can always work on that. Constructive criticism is always welcome. Thank you. You can find me at Twitter using my Twitter handle @Ashirwad_1998, or else you can search about me on LinkedIn if you wanted to talk anything about this session. So that's all from my side for today's talk. Are there any questions? I'm open to taking them.
So, hello Ashirwad.
Hi, Jyotish.
Yeah, Ashirwad, thank you very much. That was a wonderful presentations, to be frank, and we are grateful for the time and the effort you took to share your knowledge with us. So once again, thanks, Ashirwad.
Thank you, Jyotish. Thank you for accepting the proposal. And yeah, it was a pleasure talking at this conference. And I would like to thank all the sponsors and community partners and the volunteers, for pulling up such a big event. And it was really a pleasure to, be a part of the conference. And I would like to just share the GitHub repo of this project so that, if anybody is interested, they can always go to the repo and have a look at it, and maybe they can play around it and build their own solutions. So if you can just share it in the comment sections, it will be really helpful.
Sure, Ashirwad. Just I will be doing that.
Perfect. So are there any Q&As, like any questions? We can take it up. We have some 4 more minutes, I guess.
I think just we can quit it off, Ashirwad.
Okay, Jyotish. Thank you for the time. Have a great day. Take care.
Same to you, Ashirwad. Take care. Bye-bye.
Bye.
One thing I just wanted to tell is, I myself personally.
Hi, Karal. Hi, Vim.
Hi.
Hi.
Yeah.
Good morning from our side. I think it's almost evening at your side, I think.
It's a warm evening from our end.
Yeah, over here it's raining, so
Yeah.
not such a nice day to go outside, I think. So what
Okay,
time it's
Karal.
at your side at the moment? Is it almost
It's a 4
5?
p.m.
4
It's a
p.m.,
4
yeah?
p.m. It's a 4
Okay.
Okay.
In the afternoon.
Yeah. So at our
Yes.
side it's 11:30 a.m. So
Almost noon for us.
almost noon for us.
So then I should wish you as a very good morning, right?
Yeah.
Okay, Karal.
So
and
normally
Vim.
Carl and myself need to be able to switch our screens, but I think Carl just takes over the screen 2 times and that's it. And I will present the slides normally.
Sure. So before going there, just let me give a short intro for both Coral and Vim to the participants, so that they will become to know, right? So for Coral is a cloud solution architect, and he works for Dexmox as a technology enthusiastic and a community member. Carol frequently shares his knowledge about experience with Azure and other Microsoft technologies. Additionally, Coral is also a board member of Tech9 IT Pro, its user group. So warm welcome, Carol.
Thank you.
Yes, and Vim. So Vim is an Azure technical advisor who has more than 15 years of experience with Microsoft technologies, and Vim is also an Microsoft MVP in Azure category, and founding board member of MC2MC. It's a user group. So, as a passionate community member, he regularly writes a blog and speaks about his daily experiences with Azure and other technologies. So, once again, warm welcome, Carol and Vim. So, the
Thank
stage
you.
is yours. Please go on.
Yeah. Let
Thank
me
you.
take over the screen. Let me see. Share screen.
No, you should share Wim his screen.
Yeah, but it should be showing after. I should be sharing. Yeah, there it is. Let me take my slide deck. Carl, it's showing, I think.
Yes.
Okay. So hello everyone, and welcome to our session at the Azure Community Live Conference. Before we go any further, we first of all want to thank the organizers and everyone involved for setting up this event and for allowing us to deliver this session. And of course, also a big thank you to all the sponsors, because I think without them, organize such a huge event probably would not be possible. Our session is titled, Let's Get You Started with High Availability and Resiliency on Azure. And Carl and myself really hope that by the end of our session, everyone will know a little bit more about how to foresee high availability on one side and resiliency on the other side in any of their Azure environments. Let us also shortly, really short, introduce ourselves. So, like I already said, my name is Wim Matthijssen. I live in Belgium, where I work as an Azure Technical Advisor. I'm an Azure MVP. I'm also my MC2MC board member. You can see my socials on the screen. You can always contact me through Twitter at Wim Matthijssen or through LinkedIn, or you can simply scan the QR code at the bottom of the slide. That will make connecting a lot easier. I also have my own blog, http://wimmatthijssen.com, where I blog about my daily experience. And I think with that being said, Carl, you can introduce yourself a little bit more, I think.
Thank you for having us, and also thank you for the sponsors for organizing this event, this big event. So my name is Karel de Winter. I'm indeed a cloud solution architect working at Dexmark. It's a Belgian company. And yeah, you can find me on Twitter or LinkedIn. And if you have some spare time, please go to my blog and read my articles.
So on our agenda today, first of all, we'll look at what availability and resiliency in Azure really is. We'll also look into auto-scaling and all options available for data replication. And next to that, we will also tell you about high availability and resiliency on the networking level. And of course, in between, we show some demos. And before closing off, we hope we still have some time for a Q&A, where we would love to answer any of your questions. And otherwise, you can always contact us later on through Twitter.
Yeah, so if we think about availability, so what is it? Normally, it's defined as the proportion that is available of services, and also in your total services, what is available. So it means that we can see availability as some sort of quality, some sort of criteria, and also a measurement for a specific system. Or a service that's, for example, on Azure or on any cloud platform. So in the following sections, we will explain you which different availability options you can have on the Azure platform. And under availability, we also know that you can have planned maintenance, for example. You can have unplanned maintenance. If something occurs, then you know that you have to fill in that gap and make sure that your services are highly available across regions, across the globe. So you can make sure that if an application has an error or the platform has an error, that you can make sure that the service that you're hosting or the application that you're hosting is still available to your end customers or to your service in general. And also you need to take into account if there is some damage, for example, a data center, that also is part of the availability, that you have to make sure that the repair time that you can have to fix the things, for example, if data center is broken or some parts of the data center, what is the repair time that you need to make sure that the application is up and running again. So these are the topics that we want to discuss in this session.
So, and when we look at availability, it is quite important that you also know what an SLA is. Well, an SLA is a contract between you, yourself, and your cloud service provider, which in case of Azure, of course, is Microsoft. This SLA will guarantee you a certain degree of availability for all the services you use. So in a way, it describes Microsoft commitments for each Azure product's uptime and connectivity. So SLAs together with availability is described in terms of nines. For example, 4 nines means 99.99% uptime, which at least translates to 1 minute or less of potential downtime per week. However, you should keep in mind that your applications or workloads mostly depend on multiple services, for instance, virtual machines in combination with storage, in combination with networking, and all those services together mostly have different SLAs, which can affect your overall workload or application SLA. So in a way, you need to do some math to get the composite SLA and see if that composite SLA, that combined SLA, meets your SLA requirements for that complete workload or application. So maybe one part has 99.9%, another part has 99.99%, and another one has 99.95%. So you need to make the calculation to see what the combined SLA of the complete package is. So, and now, for example, if we look at the SLA for Azure IaaS VMs, you can see that there is an SLA for every single instance virtual machine, which is, like you can see, different depending on the disk type being used. Those SLA connectivity numbers range from 95% up to 99.99%. Just know that this is a financial backed guaranteed uptime SLA, where you only will get your money back in the case you submit the claim. And of course, next to those, you can also foresee high availability for your VMs, which guarantees an SLA of 95.9% in case of an availability set and 99.99% in case of an availability zone. Of course, like I already said, and like you can see on this slide, there are SLAs for all Azure services. So if you want to look into them, you can use the link at the bottom of the slide, and from there look further into them.
Yeah. So if we look at resiliency in Azure, then we can talk about three main topics and also possibilities that we have. So first of all, you have the high availability in Azure, so you can make your service or services high available to use the capabilities of the platform itself. And the other thing in resiliency, so to make your application resilient, is to use Azure Backup or Azure Site Recovery. So these three main topics or possibilities are available in Azure to make sure that your services are resilient across different regions and so on. And on the next slide, we will tell you a little story. So our two friends here once had a major damage in their data center. So it was flooded away. They had some troubles because nothing works in that moment, but they could still laugh, and that's because they had made sure that the data center was high available. So they had an exact copy of all the applications, the VMs, and the applications that were running in the data center where the water was flooded, that they had all those services made available into another data center. So that's the main point here. Make sure that your services or your resources are highly available, not only in your on-premises data center, but also think about that if you design an application in the cloud. If you think about creating services in Azure, creating resources, always think about the three main topics that we've just said. Make sure that your application is highly available, that it's spread across regions, that you take the capabilities of the platform, and in that case you can, like these two guys, still laugh when when something really bad happens into your own data center or into your own environment.
So, like Carl just said, availability is one element of Azure resiliency. In case of your Azure IaaS VMs or Linux VMs, you can foresee high availability by use of an availability set. And you can see an availability set as a logical grouping for isolating your VM resources from each other whenever they're deployed. And this will ensure you that during planned and even unplanned maintenance, at least one virtual machine will be available. In the back, these VMs will be spread across different fault and update domains. And a fault domain is a logical group of underlying hardware that shares a common power resource and a network switch. And you can see it similar to a rack within a non-premise data center with its own switch, its own power supplies, and so on and so on. And an update domain, however, is more a logical grouping of hosts which are updated or, in the case, can be rebooted together. So, to foresee resiliency for your IaaS VMs, you should at least place your production workloads in a separate availability set. You can have an availability set for your domain controllers. You can have one for your SQL always-ons. You can have another one for your web servers if you're still running IaaS web servers, for example. And every other workload you can even think of. And for complete redundancy until the storage level, you should always use managed disks for the VMs you place in such availability sets. But I guess most of you, if they're still deploying IaaS VMs, will be using a managed disk by now, or even migrated from the unmanaged ones to the managed ones. So Azure makes sure that the VMs placed within your availability set run across multiple physical servers and network switches, all in their own compute racks, with their own storage, with their own power units, just like you can see on the screen. And then if a failure or software failure happens, only a subset of your VMs will be impacted, and your overall solution normally will stay operational. So you can see an availability sets that those are essential for building reliable cloud solutions, workloads, applications, or whatever you're creating. And this will ensure you that at least one of those VMs will be available if something happens, like a hardware malfunction, and this in a single data center. So next to availability sets, you can also place your VMs in the availability zone, which is kind of the next level to foresee Azure Virtual Machines high availability. So all VMs in an availability zone will be placed in a different physical location within an Azure region, well, just like you can see on the slide. And this physical separation will protect those workloads from complete data center failures. The only thing you should keep in mind is that availability zones don't support all VM SKUs. So definitely check those out before you start using them. So you should also know that placing VMs in a single region will reduce the physical distance between these instances, and placing them within a single availability set or availability zone will even bring them more physically closer together. However, for example, a single availability zone may span, like you could see on the previous screen, multiple physical data centers, which can or may result in network latency, which can have an impact on your application. And that's why to get VMs as close as possible together, and by this also achieving the lowest possible latency, you can deploy them within a proximity placement group. You kind of can see proximity placement groups as a logical grouping used to make sure that your Azure compute resources are physically located close to each other. And they are especially useful for workloads where low latency is a requirement. Just keep in mind that you need to create those proximity placement group before you can use them with any other resources. So if you want to use it in combination with an availability set or with separated frames or whatever, you first need to create a proximity placement group, and afterwards you can deploy and create all other resources. So next to those proximity placement groups, you also have Azure dedicated hosts. An Azure dedicated host is an Azure service that provides physical servers which can host one or more virtual machines dedicated to your or one Azure subscription. You can provision dedicated hosts within a region, an availability zone, or in a fault domain. And once created, you can place VMs directly on your provisioned host in whatever configuration meets your needs. So using dedicated hosts provide you with hardware isolation, and this at the physical server level in the Azure data center. So no other VMs from any other customer will be placed on any of your hosts. A thing to keep in mind is that by using them, you will have control over the maintenance events initiated by the Azure platform. So you have more control than normally when you run your VMs. There's also
it's good to know that we have a lot of options, but if you are thinking about using availability sets, then you first create the availability set and then you create the VMs, Wim?
Yeah, that's true. Yeah, always, and the same with the proximity placement group. First create the proximity placement group, then create the availability set or zone in combination with your VMs. If you forget those, you can't put them. You need to rebuild to get them into an availability set, and even to get that one into a proximity placement group. So that's indeed a good point, Carl.
Yeah, and what we do a lot is that the VMs obviously need to have the same role. So you can't mix a domain controller and a file server. So you need to make sure that the VMs that you are hosting an availability set are running the same service. So if one fails, then the other can take over, like a domain controller, for example. Then
Yep.
you have the Active Directory synchronization that is taking over between the two VMs or more VMs if you have them. So that's also important to.
And they should also be capable to run a high available workload.
Yeah.
So if your workload can be spanned over multiple VMs or whatever, it's you can't run two different workloads in one availability set because then the purpose is completely gone, and that doesn't make sense. So another service Carl and myself use a lot, I think. It's a free service. It's called Azure Service Health, and which you can use Azure Service Health to be informed about your planned or unplanned maintenance events or service issues, like they are being called. And Azure Service Health will notify you at the moment an issue in the Azure backbone impacts your Azure resources. It will not only tell you what the impact is, but also how Microsoft is resolving it. And at the end, it will notify you when the issue is resolved. And next to that, if you bring it together to this, you can also get visibility when planned maintenance is ahead from your Azure VMs. But I will show that in the demo a little bit later.
Yeah. And so building reliable systems on Azure, that's a shared responsibility. So you have to know that Microsoft is responsible for the reliability of the cloud platform, and therefore you get those SLAs. And that's also including the global network and the data centers globally, and all those services that are globally available and so on. So therefore, you as a customer or as an end user, you are responsible always for the reliability of your cloud application or the services that you're hosting. So those services or those applications, these need to be they need to use the best practices and also the requirements for each workload. So customers or end users that need to design an architecture or a specific pattern, you need to make sure that you take care as much as possible of the built-in reliancy and resiliency of the platform. So that's what we see here on the slide. You can use app service, but you have different SKUs of the app service. So make sure that if your application needs to be highly available, that you pick a SKU that makes sure that your application is highly available. That is, for example, spread across regions, that you take into account that you need some other service to make your app service highly available. Another example is with storage accounts. So you can have the different storage account flavors, where Wim will tell you a little bit more about. But take into account, if you are building an application, that you always look at the possibilities that you have, the different SKUs that you have to make your application resilient. And always take into account that you need to build your application with a global reach. So make sure that you can have that for example, when one region goes down in Azure or something happens, that you can have a failover to another region, or that your application is built high available so that an automatic failover happens to another region. So that we mean, for example, with an active geo-replication for an Azure SQL database. And that's something that we see on the next slide, is that you can have a design like here, that you have Traffic Manager in front of your application. So your application is decoupled in the sense that you have the same application in region A as in region B, that is spread across the world in whatever data center there is in the Microsoft Azure platform. And for example, you can have the SQL geo-replication. So you have an active situation where the data in your SQL database is replicated across regions. So in that case, with the Traffic Manager, you can make sure that you only have one DNS record, one URL, one entry point for your application. And then you can spread not only the load, you can load balance, but you can make sure that your application is always available. If there is something happening in one region, then you can fill over to a next region. And also building resiliency in your application does also mean that you can that your application needs to be scalable. So for example, you can scale out. That means that you can scale horizontally, so you can add more instances, add more smaller instances to your workload, so you can have a bigger application to add instances. Or you can scale up, that's scaling vertically. And that, for example, like Wem said, if you are using VMs, just make sure that you are using a bigger SKU of the VM, so you have a bigger VM at your service to host your application. So those are also two important things that you can use, so scale out or scale up. And make sure that you use the platform and that your application is highly available. And I think, Wim, on the next slide we can tell something else to make the application highly available.
Yeah, something completely different.
Yeah.
So, like Carl already mentioned in the beginning, there are also some other elements to foresee resiliency in Azure, and one of them is backup and disaster recovery. And just for clarification, backup is not the same as disaster recovery, but in a way it can be a part of your disaster recovery plan or procedure. So in the case of Azure, you have Azure Backup for backup and Azure Site Recovery for disaster recovery. The Azure Backup service keeps your data safe and recoverable by backing it up to Azure. For example, a user deletes a file and you can restore that file, or a virtual machine is not responsive anymore and you can restore the complete virtual machine. You can restore a specific disk, and this all from your backup. But Azure Site Recovery and Microsoft Azure's disaster recovery service is something completely different, because it replicates workloads running on physical or virtual machines from a primary site to a secondary site. And when an outage occurs at your primary site, you fail over to the secondary location and you will start accessing your apps, workloads from there. And when the primary location is up and running again, so you fixed everything, there's no problem anymore, then you can start failing back from your secondary region to your primary region. So you use Azure Site Recovery, or any other form of disaster recovery when a complete data center fails. You do not use it to restore a single virtual machine or even more virtual machine, and especially not to recover from any kind of data loss. So that's the thing you should really keep in mind, because in practice we see a lot of people mixing those things up, or we're using disaster recovery, we have a problem with one VM, we just fail over that one VM and all the rest will stay in the primary region, and that one VM is running in the secondary region. That's not the purpose of a disaster recovery. So keep that one in mind. So, like Carl also said, data stored in the cloud, like probably a lot of you know, can grow at an exponential pace, and when that's the case, to manage cost for expanding storage needs, it can be helpful to organize your data based on how frequently it can be accessed and how long it will be retained. And that's why Azure Storage offers different access tiers, so that you can store your blob data in a more cost-effective manner on how it's being used. First of all, you have the hot tier, which is an online tier optimized for storing data that is accessed almost continuously or quite frequent. And just know that the hot tier has the highest storage cost, but the lowest access cost. Then you also have the cold tier or the cool tier, which is also an online tier optimized for storing data that is less frequently accessed than the data in the hot tier. Data in the cold tier can be stored for a minimum of 30 days. That's an important fact you should keep in mind. And the cold tier has the lowest storage cost, but it has some higher access costs compared to the hot tier. And then finally, we have the archive tier, which is an offline tier for storing data that is almost never accessed, so quite rarely accessed. Maybe for regulation purposes, you need to store data for 5 years, but it should be there, and if you have some kind of company that controls you, you need to get that specific data back. But for the rest, that data is never accessed anymore. That's mostly the data you place on an archive tier. So data on the archive tier can be stored for a minimum, if I'm correct, of 180 days. So pricing for storing is quite cheap, but whenever you need to access it, yeah, the access costs are a lot higher than when you're using the cold or the hot tier, for example. And in combination with those access tiers, and in the case you're, for example, working with a lot of storage accounts in your Azure environment, our advice will be to look into blob storage lifecycle management. It's a feature that's not long there, I think. And it offers you a rule-based policy that you can use to transition your data to the desired access states when specific conditions are met. Or you can even simply use it to expire data at the end of its life cycle. But enough talking. Let's show us some things in our first demo. So let me show my Azure screen. My screen is showing, Carl, I hope.
Yes.
So we're talking about that free service you could use, Service Health. So I just typed in my global search bar, click on Service Health, and that's that service. We'll give it a second until the screen opens. And you can see it will give you information about service issues. So something in the backbone at Microsoft side is going wrong, and it influences your resources. All information will be in there. And the thing we want to mention in combination with high availability is that planned maintenance. So I have some VMs running. Luckily, I don't have any planned maintenance on hand at the moment. But if one of those VMs somewhere in any of your environments, or you can add your different subscriptions, has planned maintenance, it will be shown up here, and from here you can redeploy it in your own on your own, or you can just see whenever Microsoft, probably they will put a specific date and time of time frame of a few hours probably. When they will redeploy your VM to the other side. A nice extra over here, and something I think, Carl, we use it every time there's something wrong in the Azure in any of our environments. Is almost the first thing we'll look into it. But you can also automate it with those alerts. So you can create a health alert because Azure Service Health is a feature available also and combined with Azure Monitor. You can create a specific alert. So if a service issue pops up, you have planned maintenance, there even are health advisories or security advisories. You just create that alert, and it will, for example, if you combine it with an Azure Monitor action group and you specify a specific email address, it will send, whenever something happens, it will send it to that email address, and you can look at it from there. And by this, you don't need to open the Azure portal all the time. You should, whenever you start working with Azure, you should try to automate as much as possible. So it should be that you never have to open the portal on a day, for example. So you only open the portal if something is wrong. You need to visually look at it. So we were talking about those proximity placement groups also. Normally I should have one in place. So I have one proximity placement group in place. So if we open this one, you can see there's an availability set in there. And in that specific availability sets are two VMs. So I first created through a script my proximity placement group. And then I created my two VMs in that specific availability set and placed that availability set in that proximity placement group. So if you then look at that availability set, let me open that one. So it was my management one, I think. So if I open that one, you can see I have my two VMs in there, my VM management 01 and my VM management 02. And you can see VM management 01 is in fault domain 0. And the second one is in another fault domain. It's in fault domain 1. And the same for the update domains. So if I place more VMs in there, I can go up to, like you can see in this one, 3 fault domains and a maximum of 20 update domains. You can also specify those number of fault domains and update domains whenever you deploy your availability set, but the maximum and by default is 3 fault domains and 20 update domains. Let me also show that storage lifecycle. So if I open my storage account, I think it was this one. I hope, because I have a lot running in my environment. If I go to lifecycle management, yeah, there it is. So it's quite simple to set it up. Yeah, you can automate it, but if you want to do it through the portal for the first time, you want to look into it, how it's working, you just go to your storage account. Under data management, you go to lifecycle management, you click add a rule. I already have a specific rule in place. Let me show me that one. So I have my data is primarily stored at the hot tier. After 30 days, it will move to cold storage. And after 60 days, it will move to archive storage. And then after 90 days, it will completely delete the blob. So that's the idea. But yeah, it doesn't need to be always this flow. We can have 2 rules in there, just 3 rules or whatever you want. But our advice is, if you're working with a lot of data and yeah, which is not accessed the same all the time or can be deleted after a certain amount of time, just configure those blob cycle life management rules, and it can really automate your work and keep your data flow under control. And with that being said, we can go back to the slides, I think, Carl. So let me show them again. Yeah, there is.
Yeah. Okay. So like I said before, you can scale out or scale up your application, but make sure that you're using those possibilities of auto scaling. And what we see here on the slide is that auto scaling is built in a lot of services, so you can make use of it for free. So for example, you can all the Azure cloud services are highly available. You can use Service Fabric to scale out your application. The default Azure App Services you can also make highly available. The Azure VMs, like Wim said, you have the availability sets, the availability zones that you can use to make sure that your application is also highly available. And like the previous session, use Azure Functions, because Azure Functions are part of the Azure App Service, of course. So if you scale your Azure function, it's actually the function app that is going to scale. So make use of that. Make sure that you are using the right SKU, so you have that auto scaling in place. And also, like Wim said, make use of the VM scale sets that you can make your application highly available.
Then another important thing to be aware of is that there are different types of data replication you can use within Azure. And if you look into them, you will see that first of all, we have locally redundant storage, LRS, which simply copies your data synchronously 3 times within a single physical location in your primary region. Then you have also zone redundant storage, ZRS, which copies your data synchronously across 3 Azure availability zones, and also this in your primary region. Next to those 2, you can also choose for geo-redundant storage, GRS, which first copy your data synchronously 3 times within a single physical location in the primary region using LRS, and then it copies your data asynchronously to a single physical location in a secondary region. And then finally, you also have geo zone redundant storage, which copies your data synchronously 3 to 3 Azure availability zones in the primary region using ZRS. So with GRS and ZRS, you also have the read access options, which allows you to read the data in the secondary region. So like you can see, and like you were just talking about, there are a lot of options available, and you should definitely keep those in mind whenever you start designing a new solution or workload, because depending on which data replication option you choose, price can be higher. but also redundancy and the replication can get higher. So if you need to follow specific regulations or you need to follow specific compliances, definitely put those next to in place of this and choose the right one. And because it's not always possible to change the data replication options whenever, for example, if you choose GRS, for example, whenever you deploy a recovery services fault for Azure Backup, and you put your first backup data on there, you can't change it afterwards from GRS to LRS, for example. So keep those things in mind, because it's easy to deploy something with a specific setting, but from time to time, it's quite difficult to change a specific setting, or you completely need to rebuild or redeploy that specific resource.
Yeah, so next up is then how do you do network design and also the management of it. And the first topic we want to talk about is the Azure Load Balancer. So the Azure Load Balancer, like in the name, it will evenly distribute the load across different backends. So the Azure Load Balancer delivers high availability and also network performance. And that's to the backend, so to your applications. Very important here that it operates at layer 4 of the OSI model. It also has different SKUs, so you can have the basic or the standard load balancer, and yeah, your endpoint can be public or internal. So it can be used for internal or so for inbound, but also for outbound scenarios. And like I said, yeah, you can have a load balancer that has a public IP address assigned, so you can use it for public access or for internal access only. That's also possible. And think next up is a little demo. So if you can
I
share,
I will stop sharing at least.
So I think my second screen is still shared. If someone can share that.
I'm just seeing you. Yeah,
yes,
there
yes,
it is.
Thank you. So within the portal, you can search for load balancer. And what I've just made a load balancer that has a basic SKU. And what I want to do is I have 2 web servers, so 2 VMs that I want to distribute the load of. So, or in case one server is down, that the other server is taking over. So you can see in my front-end IP configuration that I have an internal IP configured that is available into my network. My backend pools will be the 2 NICs of my VMs. So I have 2 web VMs, like I said. My 2 NICs have an internal IP address also, and those 2 are configured in the backend pool. And then you also have the health probe. So I have one health probe, an HTTP health probe that is looking at a specific URL or a specific path in this case, and that's the root on port 80. And then you have the load balancing rule, so you can mix and match what you want to do with the load. So like I said, if you want to create a load balancer, just keep in mind that you have the different types, but also the SKU is important, and take into account that you now can have the regional, but also the global tier. If I then go to my first VM, so I have 2 VMs, I'm connected via Bastion. Of course, that's a very secure way. If I go to localhost, you will see that I'm running the service, of course, on the Web 1 server. If I go to the second one, you will see that I have Web 2. Now, for example, if I go to my IIS manager and I just stop this service, then you will see that the local host, of course, is not responding anymore. So it will time out. And if I go to the IP address of my load balancer, yeah, now you will see that Web 2 is responding. And if I do the same, so if I run this again, I start the service again, and I then go to my Web 2, then it means that the Web 2 should also be disabled, and we will see the same, of course, that the load balancer is taking over. So my service will time out, and then you will see here that if I refresh again, that my Web 1 is taking over. So the internal IP address of my load balancer will distribute the load of my 2 VMs, but also it will take over if one VM goes down, then it will make sure that the service is high available, that the service is still running. That's it for the demo, Wim.
Yeah, and I think, Carl, for production workloads, whatever, if you use a load balancer, that you mostly use the standard version, and not the basic one. And so mostly basic means use it for POC, test, and dev, and from all the other things, use at least the standard versions or the lowest standard version. Otherwise, it's quite difficult to upgrade afterwards also, because there are also resources you also completely need to redeploy if you want to put them a SKU higher than the basic one, if you primarily were using the basic one. So let me share my screen again. It should be showing, hopefully. Yeah, there it is. Let me get back to my slides. So next to an Azure external load balancer, like Carl just demoed quite nicely, you also have the Azure Application Gateway. So an Azure Application Gateway, simply said, you can see it as a web traffic load balancer, which enables you to manage traffic to your web application. And differently than the load balancer, external load balancer, it operates at layer 7 of the OSI model. So like you can see on the slide, it can make routing decisions based on additional attributes or on HTTP requests, which can be an URI path or even host headers. And for example, this will allow you to route traffic based on the incoming URL. Next to that, it also allows you to redirect your traffic, which can help you, for example, to automatically enable HTTP to HTTPS redirection. It can also combine with a WAF, a web application firewall, and by this it can protect your workloads from common exploits, like, for example, SQL injection attacks or cross-site scripting attacks. So if you want a load balancing between your servers in the region at the application layer, you should definitely look into using an application gateway. And if you just need to do it at the network layer load balancing, you just need to use the Azure load balancer.
Yeah, so the next service that we can use is Azure Front Door. So one of my favorite services. It's mostly like what the application gateway is. So it's also working at layer 7. That means that it's working at the HTTPS layer, and then you can, like Wim said, route the traffic based on a specific path or a URI. So you can have one part of the application that goes to one backend and the other one going to another backend. But mostly important, this is a global service. So that means that it works or that it operates within the edge network of the global Microsoft network. So your service can be highly available across regions, across the world. You can, Front Door ensures that the end user also connects to the nearest Front Door POP. So the POP, those are the point of presence in the Microsoft network. So an application that is or the backend of your application that is internet facing, that can be using Front Door that is hosted inside or even outside of Azure. And in that case, the Front Door provides you a range of traffic routing methods also, like we see on the slide, the path-based routing, for example. And it also has a backend help for monitoring your backends. And you can have different application needs and also different failover models, like making sure that your application is always in an active situation, or it will only route traffic for a specific percentage of your load. Then it goes to the other end of the application. You can have custom domains. You can have Front Door letting managing your certificates also. So it's a very nice service that we can use. And next up is the I think the traffic manager. Yeah, so the traffic manager is working at it's a DNS based service, so that means that it will use DNS to host and to align your traffic. So it uses the endpoints. It's also a global service. That means that it's also working like the front or on the Edge network, on the global Microsoft network, and it will have the network or the service routed through the endpoints that are the best and the fastest. So in that way, you can have a very simple routing mechanism that is based on DNS and is based on DNS routing. So your application can be available in one region, but also fail over to another region if region A, for example, is not available anymore. So important, traffic manager is also a global service and works on DNS level.
Yeah, and Carl, maybe to give an example. So in the case you have, for example, plant maintenance, Traffic Manager can really help you to do this without any downtime of your application, because it can redirect the traffic to an alternative endpoint while the maintenance in progress is, and afterwards route it back to both of them.
Yeah, correct. And then next up is the Azure CDN. So the CDN is next to the Traffic Manager, also a global service that you can use. It will route your traffic also, but it will make sure that your if you have, for example, a site that the site, the images or the videos are cached in a local region. So once again, it will make use of the point of presence, so the POPs within the global network, and it will make sure that your traffic is reduced, so you don't have to go always to your main region, because the workload will be cached in all the regions across the Microsoft Backbone network. And for that, you can have very, very fast responding websites, for example, because your main traffic is being cached. You can also use your own or custom SSL certificates, and you can have the global monitoring traffic with also the metrics that are available for that. Yeah, and I think the most important part is what can we choose between all those services. So we have just made a short list of them. So very important, you have two global services. So Frontor and Traffic Manager are working on a global global service. And the Frontor is used for HTTP or HTTPS traffic, and Traffic Manager, like I said, DNS traffic, so non-HTTP traffic. And then you have the application gateway and the load balancer. Those are regional services. That means that you have to use more than one application gateway if you want to make sure that your application can be reached globally. And application gateway, like Wim said, is for HTTP, HTTPS traffic. The load balancer can be used at the layer 4 at the layer 4 OSI model. So that's for non-HTTP, HTTPS traffic. So those are a high level of the different services that we've discussed.
And it really depends on the use case, which one you need to use. So definitely look at them, look at all the differences, see if it's needed globally. And the ones mostly seen at company and customer sites are Azure Frontor and Application Gateway these days. But we can even combine them. You can have Frontor in combination with Traffic Manager and vice versa. So, but definitely look into it, read about it, see what the differences are, and pick the one that's has all the requirements to fulfill your specific use case.
Yeah.
And I think, Carl, with that, you can show us a demo, I think.
Yeah, if we can switch to my screen again, that should be nice. So in the demo, what I will do, I will give a demo about Frontor. So next to my load balancer, I also have created a Frontor. So that means that I want to make a service globally available. And what I've created, just simple, I created 2 storage accounts, one in West Europe, and the other one in West US 2. So this is my second storage account. I've just enabled the static web site on that storage account, and I hosted a very simple website. So that means that my 2 storage accounts. So this is my first storage account that is hosted in West Europe, simple storage account, nothing different or difficult about that. Like you see, I've enabled the static website functionality, and then what you can do is just place a simple website on the storage account. On my first storage account, what I've did is that just a simple text that says that it's hosted in West Europe, and my second storage account, the same text, but it is hosted in West US too. So if you have a look at Frontor, what you need or what things you need to host your Frontor, in the backend, you have your different components of Frontor. So in the Frontor designer, it's very visually available to you, but if you are using scripts or templates, you have to think about all the different components that you need. So you need a front end, you also need the backend pools, and then you also need the routing rules. You have the health probes that you also see in the load balancer. So all those components are used by Frontor. So that means that we can have, like you see here, different front ends for different domains. We can have a front end that's pointing to your dev environment. You can have a front end that's pointing to your production environment. And for that, you can here create different front ends. And those front ends are pointing to backends, one or more backends. The backend, in my case, if I have a look at the backend pool, you will see that I just added the web URL of my storage account. So if you enable the static web function, then you can you get the primary endpoint of your storage account, which is the web primary endpoint, and then you just go to the URL, and you will see that that the site is hosted on that. I'm not supporting HTTP, so I need to fill in explicitly HTTPS. So you see here is just a simple website that is stating that it's hosted in West Europe. Now, what I want to show you is that Frontor is taking over to host that application. So if you look at my Frontor, I have created, like I said, a front end. It's HTTPS enabled, of course. I've used the Frontor managed certificate, so it does that for you. You just request a certificate, and it will manage that certificate itself. Of course, you can host your own certificates, use your own certificates. I enabled the web application firewall, so that's another component that you need to create. If you are working with scripts or templates, you first need to create the web application firewall policy, and then you assign a policy to your Frontor. It's all explained very visually in the portal, so you can see what's happening in the back of the Frontor. So I have my front end, my backend pools are just my 2 storage accounts, and then I have routing rules that just point. For example, if you go to HTTP, it will redirect you to HTTPS, so you don't have to fill in manually HTTPS for that. And my second one is the routing rule that my front end is pointing to the backend pool. So if we have a look now in a browser, I use Opera because you have the feature of using the VPN. So if I go to my front end, so that my URL is frontor.kareldewinter.com, you will see that is pointing to West US because I'm using the VPN connection. And if I go and surf via a Europe endpoint, it should point to West Europe, like you see here. So now I'm just hacking a little bit. So I'm making use of a VPN to initiate the connection from a Europe location. And on the other side, if I probably use the Americas, then I'm surfing from the Americas. If I refresh, then you will see that it's hitting the other storage account that is hosting the simple static web app that is saying, hi, I'm hosted from West US too. So this is very fast explained what Frontor can bring you, what opportunities that you can have with Frontor. But even if you want to make your, for example, Azure Web App highly available, then you can, of course, use front door, and the backend will be your different web apps instead of static storage accounts. So that's basically it for the demo. Wim, I think it's back to you.
Let me share my screen quite quickly, just to close off.
Yeah.
And wrapping up. So it should be showing. Yeah, there it is. So I don't know if anybody has a question. Maybe if you look at the time, it's maybe better that if you have a question, just contact us through Twitter. We'd love to answer any of them, and we probably have a lot of more time to answer them. So with this being said, thanks again to all partners who helped organizing these events. Also to all communities, there are a lot in there for helping and organizing this. And then to close off our session, we just want to thank you for your attention. We hope you learned something new related to high availability and resiliency. And if you have any other question, just scanning the QR code or just ping us through our Twitter handles. So thank you for your time, and see you next time, hopefully.
Thank you. Bye-bye.
Bye-bye.
Yeah. Thank you very much, Carol and Wayne. That was a wonderful presentation. And we are grateful for the time and the effort you took to share your knowledge with us. So take care. Bye-bye. Have a nice day.
You're welcome.
Bye-bye.
Have a nice day.
Bye-bye.
Bye.
It's almost the evening.
So, hi, Vaibhav.
Hello, can you hear me well?
Yes, Vaibhav, we can able to hear you. And thanks for joining with us.
No
So,
problem.
before we get into the session, let me take a few minutes to make short introductions about you to our participants. So,
Okay.
Vaibhav is a thought leader and a seasoned cloud architect currently working at Kivit Corporations, where he is responsible for envisioning and creating a cloud strategy, leading and coordinating a cultural change for a cloud adoption, and also continuously building and improving the cloud platform's foundations that development teams build upon. So once again, we thank Vaibhav for joining with us, and for next 50 to 60 minutes, just we will be trialing with him by discussing on the topic about writing stateful functions in serverless environment using Azure durable functions. So Vaibhav, the stage is yours. Please go on.
Can you bring up my screen? Awesome. Hey everyone, a very good morning, evening, good night, depending upon where you are joining us from. I welcome you all to my session. I hope you and your family are doing well and safe and healthy. Special thanks to the organizers for giving me an opportunity to speak at AZConf. Hope you would have gained value out of the conference so far and you will like my session. As you already know, in this session, we'll talk about durable functions, which lets you write stateful code in serverless environment in Azure. The session is level 100 to 200, where I will start with the basics and talk about different concepts. I will also try to show some quick demos if time permits. And before we jump onto the agenda, let me quickly introduce myself. I'm a cloud and DevOps architect with over 15 years of experience. I was born and brought up in India and moved to Omaha, Nebraska, here in Midwest Omaha in 2016. I've been awarded Microsoft MVP award in Azure category, and I'm also a Microsoft certified trainer. I run a local Azure user group here in Omaha where I conduct bi-weekly meetings, which are currently virtual. For more information, you can check out the website omahaazure.org. I have earned numerous Azure role-based certifications, including Azure Solutions Architect Expert and others. I have also earned AWS Certified Cloud Practitioner exam. With that, let's go through what we are going to talk today. As I said earlier, this session is going to be a level 100 to 200. We'll start with the very basic. What is serverless? We'll talk about Azure functions and some concepts related to Azure functions. We'll talk about some of the challenges that Azure functions have and how durable functions can solve those. We'll talk through different concepts in durable functions and talk about different patterns that you can implement using durable functions. And I have planned few demos, and I'm hoping to cover most of them in a time permitted manner. Lastly, I would not mind hanging out after the presentation to answer any questions you might have. I will try to answer to the best of my knowledge, or else we all will learn something new together. With that, let's keep moving. So starting with the very basic, what is serverless? Let's talk about it a little. Serverless has been a hype word in the last few years. Serverless could be misleading term. Literally, serverless translates into something which has no servers, which is not true. Serverless workloads still need servers to run on, but they are abstracted away from the consumers. So it is misleading to say that there are no servers. Instead, think of it as less servers. Serverless architectures essentially removes the need for server management. Servers, infrastructures, and operating systems are provisioned on demand for execution time and decommissioned when execution is done. It is important to understand some of the benefits we can get out of serverless architectures. Most of us would have come across situations where we would have deployed our resources on a hosting platform, and we would be keeping a server component always up and running 24 by 7, so that whenever the actual request comes in, the server is able to respond back. But unfortunately, that approach came with a cost. Just to handle requests at a specific time, we were required to maintain the servers up and running 24 by 7. In serverless, though, as the cloud provider provisions the resources on the fly whenever the code is executed and deprovisions the resources thereafter, it essentially removes the need for server management, and retaining always on server components is not required. Likewise, not only the resources are provisioned and deprovisioned on the fly, resources are auto scaled depending upon the events and the workload. Best part is that you are only charged for the time during which the code is executed. The result is an immense cost savings. We'll touch upon that aspect shortly, but that's the in nutshell. You save lots of money using serverless. One specific use case for serverless is termed as function as a service. Under function as a service, you can run independent code pieces which are executed as functions. Some popular examples of function as a service are Azure functions that we are talking today. And then if you have been using a different cloud provider, you would have heard of AWS Lambda and Google Cloud Functions. They are also the example of function as a service. Let's talk about Azure Functions. Azure Functions is a serverless compute service offered by Azure that can run code on demand. You can call these small pieces of code as functions. Just think that if you can write the code you need for the problem at hand without worrying about the whole application or the underlying infrastructure to run it, how great that would be. Moreover, you can deploy that piece of code independently and execute it on demand. Azure Functions offer out of the box templates for some of the most common scenarios that we come across daily as a developer, ranging from connecting to storage, image processing, exposing HTTP based APIs, IoT based scenarios, or in fact, just running a script or code in response to an event, and so on. Azure Functions come in pretty handy in some of these scenarios. Further, you can share these functions across your applications and developers' productivity gets a boost. Lastly, I assume if you would have worked on Azure Web Apps, you would have also heard of uh, what are known as web jobs, which allowed us to run background tasks in the same context as a web app. Think of Azure Functions as a serverless evolution of those web jobs. In fact, if you will notice, Azure Functions SDK that you use in your applications utilizes Azure Web Jobs SDK under the hood. Here are some key features that Azure Functions offers. Some of the languages that it supports include C Sharp, F Sharp, JavaScript, Java, PowerShell, Python, TypeScript. As I was saying earlier, you only pay for the time when your code is executed. If your code is not executed, you don't pay for anything. It does support NuGet and NPM packages. It comes with support for OAuth for your HTTP triggered functions. You can have authentication on those functions. Since it's part of Azure ecosystem, it has seamless integration with other Azure services. And there are different ways to develop and deploy Azure functions, but it makes development quite flexible. As a developer, I can work on one function using C Sharp, and my fellow developer who loves JavaScript can work on another function using JavaScript, and we can utilize both these functions in a single solution. Lastly, Azure Functions Runtime is open source and is available on GitHub. If you are interested and if you would like to contribute, you can check it out. And as I said, the most important call out is that it is pay per use. You only pay for the execution time. We'll talk about how pricing works for Azure Functions shortly. Here's a quick snapshot of the three versions of Azure Functions Runtime available and the language support for them. Version 1.0, it was built on top of .NET Framework. It was not cross-platform. It supported C Sharp, JavaScript, and F Sharp. Starting with version 2.0 and 3.0, they are built on top of .NET Core and they are cross-platform. You can use them on Linux and Mac OS as well. And it also extends the support for other languages, including Java, PowerShell, Python, and TypeScript. I provided the link down below there. You can check out the updated and up-to-date list of all the supported language. Since functions is part of Azure ecosystems, they can be integrated easily with many Azure services, as well as many of the third-party services as well. Any of these services that you can see on the screen can be integrated with Azure Functions to either trigger the function execution, or they can also serve as input or output for your code. Azure Functions, as you can see on the screen, can be integrated with services like Azure Cosmos DB, Azure Event Hub, Event Grid, Notification Hub, Service Bus, Storage, and so on. All these are Azure services. But Azure Functions can also be integrated with third-party services like Twilio for SMS integration, SendGrid for email integration, Kafka, Dapper. You can also integrate Azure Functions with webhooks. Let's see how the life cycle of an Azure function works. Essentially, the very first step in the life cycle of an Azure function is when an event gets triggered. And an event could just be as simple as a message being dropped to a service bus queue, or a file being uploaded to a blob storage, or a webhook being called. Once that event happens, it triggers an Azure function, which in fact triggers your code and which gets executed within your Azure function runtime. And then after the execution, it returns an output, which can go to a persistent storage, or it could go back to service bus, or it could go to anywhere, wherever you need it to go. Azure Function uses a component called a scale controller under the hood to monitor the rate of those events and determine whether to scale out or scale in, because sometimes the events can happen at a large scale. For example, you might write thousands of messages on your service bus queue within a short span. So essentially, under the function runtime, there is a scale controller which uses a heuristic for each of those event and trigger type. The unit of scale in Azure function is called as function app. So when a function app is scaled out, additional resources are allocated to run multiple instances of Azure functions. Conversely, as a compute demand is reduced, the scale controller removes the compute host instances The number of instances is eventually scaled down to zero when no functions are running within a function app. Again, to summarize, a function app is a collection of multiple functions. You can run multiple functions inside a function app, and a function app is the unit of scale. It gets scaled up and down based on the incoming events. And when function app scales up or down, all the functions running in function app are scaled up or down. And there is a component known as scale controller, which monitors the rate of events and accordingly scales up or down the function apps. Do note that a single function app can only scale up to maximum of 100 instances, and a single instance may process more than one message or one request at a time though, so there isn't a set limit of number of concurrent executions. And whenever scale controller is scaling up, it can only allocate at most once every 10 seconds. Let's talk about two crucial concepts in Azure Functions. Starting with the trigger. One of the Merriam-Webster's dictionary's definition for a trigger says a trigger is something that acts like a mechanical trigger in initiating a process or reaction. This defines pretty much what an Azure function trigger does. It essentially defines how a function is invoked. Triggers are out of the box templates to trigger execution of an Azure function. A function can have exactly one trigger. A trigger can have an associated data, which is usually the payload that triggered the function. Some of the examples of triggers include HTTP trigger, through which you can invoke your function over HTTP call. Timer trigger, through which you can trigger your function on a regular schedule. You can use something like blob trigger, which triggers the function whenever you upload a file on the blob, and so on. Similar to triggers, there is a concept of bindings in Azure Function, and Azure Functions has two kinds of bindings: input and output bindings, which essentially provide declarative way to connect to data from within your code. Bindings are optional, and a function can have multiple input and output bindings. Uh, Trigger and bindings, in a nutshell, lets you avoid hard coding the details of the services that you are integrating your Azure function with. Essentially, your function receives data in function parameters. You send data by using the return value of the function. So the parameters that you receive work on top of input bindings, and the return value of your function works on top of the output binding. Now, a few points to remember in regards to bindings. A function can have multiple input and output bindings, as I mentioned earlier. Input bindings are decorated with in, output bindings are decorated with out. Some bindings support special binding direction called in-out. Starting Azure Function runtime version 2.x. Binding extensions are provided in NuGet packages, and to register an extension, you need to install that package. Now, a function contains two important pieces: your code, which can be written in a variety of languages, and some configuration, which is stored in function.json or host.json file. For compiled languages, this config file is generated automatically uh, from annotation in your code. For scripting languages, you must provide the config file yourself. What you are seeing here in the example is a example of an Azure function written in C#. What we are essentially doing here is returning a person object from our function, which is triggered. Here is our function name, queue_trigger table output, and here are the bindings that we have declared. We are using a queue_trigger binding, which indicates it's being triggered whenever a message is written to a queue, and we are to a storage account queue, and we are passing the connection string to that queue. And the output binding is of table type, where we are returning back to the appropriate table, and the connection string to the table storage is provided there. And here is how the functions.json file looks like for our Azure functions. Here is the input binding for queue where we have the connection string listed there, and then here is the output binding. As you will see, output binding is denoted with the name $return. It indicates it's the output binding. And let's quickly talk about the pricing plans. There are 3 pricing plans available for Azure Functions. It starts with consumption plan, where you pay for the time the code is executed. It's the default hosting plan when you create an Azure function in Azure. This is a true serverless plan, as you simply pay for the time when the code is executed. But there are certain scenarios where you might want the underlying infrastructure to be available 24/7 so that your um, function response back. There is a problem called as cold start problem. What happens is, if sometimes your function goes into an idle state, and whenever it receives a request after a certain time, it takes some time to respond back to the first request, or it takes time essentially to warm up. You can resolve that issue by using a premium plan and running your function uh, in a premium plan. What it really ensures is there is at least one instance which is always running, which essentially gives you a view that it always have a perpetually warm instance so that it can avoid cold start. Another advantage you get out of premium plan is it comes with virtual network connectivity. You can run your function within a virtual network in Azure. Lastly, you can run your Azure functions in dedicated plan, which is similar to an Azure App Service plan on which you can run your app services. When you are running your Azure function on an app service plan, remember to enable always on your Azure function. When you are deciding between consumption plan versus premium or dedicated plan, here is a graph that you should be considering. As you can see, for a dedicated plan, the cost is pretty much stagnant and you pay for it 24/7. Whereas for consumption on the premium plan, it is more based on your usage and it can vary based on how many times your function gets executed. To get started, you can, if you are a Visual Studio developer, you use Visual Studio 2019 or 2022 now, you can install Azure Development Tools as part of the Visual Studio installation to get started with the development of Azure functions. If you are a Visual Studio Code user, you can install this particular extension. I have provided the link down below there, which lets you write your Azure functions in Visual Studio Code. If you are using Visual Studio Code, you also need what is known as Azure Functions Code Tools that lets you develop and test your functions locally from command prompt or terminal. Oops. Your local function can then connect to the Azure services, as well as you can debug your debug your functions in your local computer. You can it also enables you to deploy your Azure function to an Azure subscription from a Visual Studio Code. With that, let me quickly jump to my virtual machine and show you how to get started with Azure function. Let me go to the Azure portal first. I already have created a resource group. Let me go ahead and create and show you an Azure function here. I'll go ahead and click on create. I'll search for Azure function. I'll go and choose function app here. I'll click on create. I'll choose a subscription. I will choose appropriate resource group. Let me give this a name, AZCon. Okay, this URL is a valid URL. As you can see, a right tick mark over the right. This URL needs to be unique. So if you don't get this right tick mark and you are getting instead a red cross, then that indicates you have to choose a different function app name. I don't have a containerized application. I will just choose with stick with code right now. I can choose any of these available runtime stacks. I will stick with .NET. I can go with either .NET version 3.1 or version 6, which is under preview. I'll stick with .NET 3.1. I'll stick with region as Central US as it is near to my location. Now, Azure Functions utilizes storage account under the hood to maintain the state of some of the Azure functions, so that whenever you execute it, it picks up all the metadata from that storage account. So you have to create a storage account as part of it. If you already have an existing storage account, you can choose from here, or you can create new one here. You can choose whether you want to run it on a Linux OS or Windows. I'll stick with OS for now. And here are the three different plans that you can opt from. You can go with consumption, which is the true serverless default option. You can go with a premium plan, which runs one perpetually warm up instance every time, and then it automatically adds more instances as required. And then you can run on an app service plan. I'll stick with consumption for now. I'll go ahead and stick with default options for networking and monitoring. If you want to monitor your Azure function, you can create an app insights as well. I'll go ahead and skip it for now. I'll click on tags. I don't want to add any tags, but if that's a requirement, you can add so. And I'll click on review plus create, and then I'll go ahead and click on create. It will take few seconds to create my Azure function. It should come up pretty soon. It has created the app service plan. As you can see, the server farm, it's now provisioning the storage account, and then it would go ahead and provision my Azure functions. As you can see, everything is set up. It's still now, my function has not showed up. Everything underlying is set up. So bear with me. It might take a minute or so. All right, the resource has been configured. I'll go and click on go to resource. As you can see, this is the function app that it has created. The UI is pretty similar to an app service. What I really want you to focus on the section under the functions. Go ahead and click under functions. Under functions, as you can see, I don't have any function created here. I will go ahead and click on create. There are different options. I can either develop it in Portal. I can develop in Visual Studio, in Visual Studio Code, or in fact, I can use any editor of my choice. I'll go ahead and choose develop in Portal for now. Here are different triggers that it supports. We are going to talk about durable functions shortly, but what I'm going to do here is I'm going to choose HTTP trigger for now. It will ask me the function name and the authorization level. I can leave the name as this for now for the demo purpose. At the authorization level, we can leave it at anonymous. We can make it make authorization at the function level or at the admin level. I'll stick with the function level right now and click on create. It will create my function and open up a window where I can go ahead and develop my Azure functions. As you can see, this created a C# script file for me where I can go ahead and edit it. It already created a boilerplate code for me. I can edit it based on my need. I'll leave it as is, but to show you how it works, I'll click on test and run over here. And you can see my input and output bindings here. As you can see, it's expecting an input here with a parameter called name. I'm going to change it to Azure Conf, and I'm going to click on run. And you will see here the Azure function runtime has come up and it has returned an output. Hey, EasyConf, this HTTP triggered function executed successfully. Let me quickly jump onto Visual Studio to show you the exact same thing. I already have installed Azure Development Tools. I'll go ahead and click on New Project, and I'll search for Azure Functions. I'll click on Azure Functions, click on Next. I can give a name to my function app here. I'll just keep function app as is. I'll click on Create. I'll put the solution and project in the same directory. Create, I can choose similar view that we have seen in Azure Portal. We can choose from different triggers. We are going to shortly see how durable functions work, but to show you the example, I'm going to use HTTP trigger. I can either provide a Azure storage account here to run my Azure function, but I can also use what is known as a storage emulator, which is a local simulator of Azure storage, and I can use for my local development, which I'm going to do today. And I'll stick with authorization level as function. I'll click on create, and it will create the same boilerplate code that you were seeing earlier in Azure portal. And if I go ahead and run, it will run the exact Azure function runtime, which we have seen running it in Azure portal a few minutes back. As you can see, you have this link, the Azure function running now, and my function is exposed on this link. I'm going to go to Postman. I'm going to go here, and I'm going to call that function. And as you can see, I had passed the same inputs here, and it returned the same output, and my function was running here, as you can see. Let me quickly show you how you can get started with Azure Functions in Visual Studio Code as well. I already have installed extensions for Azure Function. If I go and search for Azure Function, you can see I have this extension already installed. What essentially you can do is you can go and install this extension called Azure Tools, which comes with all the basic extensions that you need for getting started with Azure development, or you can just go ahead and install Azure Functions. But that being said, what I did was I went ahead and into the Azure plate here, and I have already signed it into my Azure account. As you can see, all my subscriptions are listed here. And here is the function that I just created in Azure portal. And as you can see, I can go ahead and see what functions. There was an HTTP function running in here. Here is the functions.json file that I can see. It takes an input parameter. It gets triggered on HTTP trigger, and it returns an output. I can also go ahead and click on create and create a new function within Visual Studio Code. I clicked on an add new function button here. I'll go and click on create new project. I'll choose a location. Let's say I'll create a directory VS Code. Select that. I'll use the language C#, but you can choose any language of your choice. I'll stick with .NET Core 3. I'll stick with HTTP trigger. I'll show you shortly how you can start with durable functions orchestrator. I'll stick with default names and namespaces. I'll stick with function authorization, and I'll open it in current window. And it will essentially open up the same boilerplate code, which I can certainly go ahead and edit it and work on it based on my requirements. But to demonstrate how it works, I already have installed Azure Functions Core Tools. So what it helps is I can then go ahead and build my function and run it in locally using Visual Studio Code and debug it. As you can see, it's building my solution in Visual Studio Code now, and my function is up and running here now. So if I go ahead and copy the link and go to Postman again, and as you can see, the function returned the same. That's just a quick demo on how to get started with Azure Functions. Let's quickly keep rolling. So here, there are certain things that once you start working on Azure Functions, you would like to implement. For example, you might like multiple functions to talk to each other. One of the pattern you might like to implement using Azure Functions is known as function chaining, where you have function 1 calling function 2, and then function 2 calling function 3. You can take it to the one more level. You can have to make them loosely coupled. You can have message queues in between those functions, so that function 1 writes a message on that queue, and then function 2 reads message from there and writes a message on second queue, which is then read by function 3. Now it's It looks pretty easy and simple to implement, but it comes with certain challenges. If you're using plain vanilla Azure functions, they are pretty good when you are executing your functions as independent units of code. But what happens is when you are trying to implement complex workflows like the one I'm showing you here, it really poses some challenges. For example, what happens when your function 3 goes down, or your function 3 errors out? Function 1 will never come to know about that. You have to really put in extra effort to keep a track of what's happening in function 2 and function 3. But if function 3 goes down, it's really very difficult for you to control your workflow and return back to function 1. Now imagine if you also have to implement a pattern like fan out or fan in. You might have similar challenges. You can trigger multiple functions from function 1, but there is going to be a lots of complexity in handling that workflow within your independent vanilla Azure functions. So here are some of the challenges that you see with durable functions. Uh, it's, as I was saying, it gets difficult to create complex workflows. And then there is no state, because when you are calling function 2 from function 1 really doesn't have any information on what's happening in function 2. There is no state management within Azure functions as such. And then there is no error handling in the workflows. You can have error handling within your individual Azure functions using the programming language constructs that you are using, but you cannot have error handling across the board in your workflows. Lastly, Azure functions work great when you have smaller execution durations, but as your execution duration increases and you have more, you result in more complex workflows, Azure functions really become difficult to implement. And to overcome these challenges, the durable functions really comes handy. In nutshell, durable functions is an extension on top of Azure functions that lets you write stateful functions in a serverless environment. The extension manages state, checkpoints, restarts for you. It lets you define stateless workflows in a new type of function known as orchestrator function. And here are some of the advantages of orchestrator functions, that you define your workflow in the code, and there are no JSON schemas or designers are needed. You can call other functions synchronously or asynchronously. We'll see that shortly. Outputs from one function can be saved to local variables and can be used in other function, and things like that. And if you are more interested on how durable functions is implemented under the hood, it utilizes what is known as durable task framework, which is an open source framework. And I have provided a link to the GitHub repo for that. You can go and check it out. So here is how durable function works. Durable functions work. To start with, there is a client function. There's a client Azure function, which is the triggering point, which is the entry point for your durable function. That client calls what is known as an orchestrator. Orchestrator is what orchestrates your workflow or manages your activities. So you trigger your durable function with a client. Client triggers an orchestrator. Orchestrator manages your activities. Now you can have nested orchestration as well, meaning you can have a sub orchestrator inside your orchestrators, which can manage other activities. Lastly, you can also have what are known as entity functions, which are built on top of aggregator pattern. And you can, it helps you in working with stateful entities within your Azure function. I'll show you shortly about that also. The difference between plain vanilla Azure functions and durable functions is that durable functions comes with 3 new trigger bindings, starting with the durable client binding, which indicates that it's a durable function. Then comes the orchestration trigger, which, I don't know what happened to my slide, but I had different screenshots here. But anyways, there are 3 trigger bindings. Durable client indicates it's a durable function. Orchestration trigger indicates it's an orchestrator function. And activity trigger indicates it's an activity function. With that, let me quickly jump onto my virtual machine to show you how you can get started with a durable function. I'm going to close the solution I created earlier, and I'll go ahead and click on create new project. I'll choose the template for Azure Functions. Click on next. I'll name the project as durable function. I'll click on create. Last time we have used HTTP trigger, but this time we are going to use durable functions orchestration. And I'll stick with storage emulator for now. I'll click on create. And as you can see, it creates a boilerplate code for me, but you can edit it based on your requirement. To show you what it did is it created the client function here, which is the entry point for our durable function. You can see here is the durable client binding, where it indicates it's our orchestration client. It's the starting point. As you can see, it is triggering a new orchestrator here. This is the command that it uses to trigger an orchestrator, the start new async command. And the orchestrator function name is function1. If I scroll up, here is my function1 orchestrator function. You can see it has an orchestration trigger binding here. And here it is calling some code here. It has essentially calling 3 activities in sequence. In this particular example, the code that it creates, it's calling activity called function1 hello in all those 3 methods, but in all those 3 commands. But you can actually go ahead and have multiple activities being called here. But going to the function1 hello method, here is your activity function. You can see its activity function based on activity trigger here. And right now what it's essentially doing is just returning back the string, and we are passing an input parameter of this city. So let me quickly go ahead and run this durable function and show you how it looks like and what it does. Oops. Let me go ahead and run it again. I see, because my code in Visual Studio Code is still running, I'm going to stop the debugging. I'll go ahead in my function and I'll run it again. So here's my durable function that just got started. I'll go ahead in Postman. And you will see it returns back certain URIs. I can go ahead. One of them is a status query get URI. If I click on that and click on send, it gives me the status of my function. And as you can see, it is still running. I'll keep polling that URI till the runtime status changes to completed. As you can see, it is still running. It is running all those 3 activities that I had written in sequence. And as you can see, it is completed now and it has returned. Here is the output that it has returned. You can do essentially the same thing that I've shown you earlier to create an HTTP trigger function. This time you can use a durable orchestrator trigger this time in when you are creating your Azure function in Visual Studio Code. With interest of time, I'll skip showing you that in Visual Studio Code. But essentially, if you will go back to Visual Studio, you can publish your Azure function, durable function, like how you publish your Azure web apps. I'll go ahead and choose Azure here. Click next. I can choose what type of operating system I want to choose. I can stick with Windows. And it automatically, since I've already signed it into Visual Studio, I can choose which subscription I want. The resource group, and you can see there is a resource group that it has identified. There is already a function app that it has seen. I can do that, or I can go ahead and click on plus here and create a new Azure function. Once that's created, I can click on finish and it will deploy my code to Azure. That being said, let me jump onto my presentation and let's continue. Durable function supports a subset of Azure function languages. It supports C Sharp, JavaScript, Python, F Sharp, and PowerShell. You can check out the updated list at the link I have provided down below there. One of the crucial concepts you should be aware of, not that you should really be an expert on that, but just for your understanding, there is something known as a task hub. As I was showing you earlier, an Azure function uses storage account under the hood to store its metadata so that it can help you in running those Azure functions. Azure durable functions take it to one next level, and it calls it as a task hub. It is essentially a logical container for your Azure storage resources that are used for orchestrations. Orchestrator and activity functions can only interact with each other when they belong to the same task hub. So that's a key point. So what you are seeing in the example is one task hub per function app in shared and dedicated storage accounts. So in storage account 1, you have task hub 1 and task hub 2. And within task hub, you can see you have orchestrator function in 2 activity functions. Those can only interact with each other, and they cannot interact with any of the functions that exist in task hub 2. Now, if multiple functions apps share a storage account, each function app must be configured with a separate task hub name. A storage account can contain multiple task hub too, as you can see in the picture. I'll show you how you can explore that, but that should be pretty much that you should be aware of. Here's a durable functions workflow when it starts and how it executes. It all starts with an orchestration getting started through the client. Orchestration gets started, it goes and starts activity 1, and then orchestrator goes back to sleep. Then when the activity 1 is completed, orchestrator wakes up, it goes and triggers the activity 2 and goes back to sleep again. Once the activity 2 gets completed, it goes ahead and orchestrator wakes up and gets completed. To show you how essentially it works, the replay behavior, it's very critical that you understand that. Where every time when you execute an activity, your orchestrator goes back to sleep and wakes up. And whenever it wakes up, it actually goes and starts from the very beginning. So what you are seeing here is, let's say we have the same code that I was showing you in the Azure Durable Functions demo a little while ago. We have 3 activities being called in our orchestrator in sequence. So what happens is the execution starts from this statement. It goes and executes this particular command. It sees that it has never executed activity 1 in the past. It goes and checks the metadata in the task hub and identifies that this activity was not called before. So it starts this activity and goes to sleep. Once activity gets completed, the execution of orchestrator starts again from the very top. It comes here. Now it goes in task hub and checks and finds out that activity 1 was executed in the last run. So it skips the execution of activity 1 this time, and it goes to the execution of activity 2. It checks the task hub that activity 2 was not executed last time. So it starts activity 2 and goes in sleep mode. When activity 2 is completed, it goes back and wakes up and starts from the very beginning. It comes and finds out that activity 1 and activity 2 were executed in last run, whereas activity 3 was not. So it starts activity 3 and goes to sleep mode. And whenever activity 3 is completed, it goes back, wakes up, and gets started from the very beginning. Then it sees all the activities have been executed in the last run, and then it returns the outputs and it exits. So you should be aware of how the replay behavior work, and especially when I was talking about the consumption plan, this is very critical because in consumption plan you pay just for the execution time, and every time your orchestration wakes up and executes, it counts as one execution. So it might increase your overall cost. So how do you handle errors in your durable function? So error handling can be implemented in orchestrator and activity functions using programming languages, native error handling features. Exception from an activity is thrown as a function failed exception to the orchestrator. So check out for that specific function failed exception type if you are working on .NET. So what you are seeing here is a regular construct that you have it in .NET for try and catch within your orchestration function. You can also have a automatic retry policy that you can use to call activities or sub-orchestrators to come out of transient failures. What you are seeing here is I'm calling a function called call activity with retry async. So what happens is it calls that function with a retry policy. You can also use durable timer to abandon a function call within an orchestrator if it is taking too long or you feel that it is hanged. Please check out the link that I have provided down below there if you are interested to learn more about how you can handle durable functions errors handling. Now, if you remember when I executed the durable function a little while ago, it has written 4 or 5 different URIs. So those are part of what are known as durable functions REST API. Those are used to perform management tasks on your orchestrations, entity functions, and task hubs. Webhooks authorized by Azure Functions. These are essentially webhooks which are authorized by Azure Functions host, but are handled by Azure Functions durable functions extensions. So here are some of the REST APIs that are available that you can utilize for managing your durable functions. You can start orchestration using that REST API. You can get the status of all the instances. You can purge history for single instance or multiple instances. You can raise an event using a REST API, a durable function REST API. You can terminate execution of an instance. You can signal, get, or list entity. We will shortly see how entity function works and how we can use these 3 REST APIs. Each of these returns only 2 status codes, either HTTP 202 or HTTP 400. HTTP 202 represents that it was accepted and it was successful. 400 represents it was a bad request. Here's a link if you would like to check out more about the durable functions HTTP API. Let me quickly jump onto my virtual machine and go back to my Postman. And as you can see, these are some of the URIs that it returns when I trigger my Azure functions. As you can see, this returns the status of my function. This is what I can use to send an external event. This is if I would like to terminate my durable function. And this is if I would like to purge history of my execution. If I go to Storage Explorer, which I have already connected to my local emulator, if you're using an Azure function running in Azure, you can connect to a storage account within this tool known as Storage Explorer. But what I want to really show you here is the task hub tables, queues that gets created as part of the task hub, where all the orchestration and activity data is being stored. As you can see under the tables, there is a table called test hub name history, which stores all the task hub history, and as well as it also stores a table called test hub name instances, where it stores all the names, a history of the orchestrators. And you can there is nothing much that you have to do about it, but this is just for your information's sake. And then there are different queues that are being used whenever you run orchestrators to coordinate between different activities. With that, let's quickly see the different patterns that you can implement using Azure durable functions pretty easily. The very first function that I've also shown in my demo earlier was called as function chaining, which refers to the pattern of executing a sequence of functions in a particular order. Often the output of one function needs to be applied to the input of another function, and the other this is the code that I was showing you earlier. It executes 3 activities in a sequence. You can, in this particular example, we are not passing the output from the first activity into the another one, but that is technically you can do that is possible using function chaining pattern. The next pattern is fan out, fan in, which refers to the pattern of executing multiple functions in parallel and then waiting for all to finish. Often some aggregation work is done on results returned from the functions. So here's an example. What I'm doing here is creating a list of tasks and running through all those tasks and then waiting on all of those tasks. When all of those tasks are completed, I'm returning my output. Another function you can implement is async HTTP APIs. What essentially it requires you to do is to implement a start function and a get status function. What the start function does is it starts a function and returns back a success code with a correlation ID, and then you can pass that correlation ID to the get status function to get the status of your execution. And whenever the do work function gets completed with its execution, it returns the output through the get status. You can also implement some pattern known as monitor, which you can utilize to monitor certain systems. It could be external systems too. And based on that output of that monitoring function, you can execute certain events. To show you an example, let's say you have a code here. What it essentially does is you are checking for an activity function called as get job status, and you are seeing what it is returning. When it returns completed, it sends an alert. Otherwise, what it does is it extends the check for certain time, and then it is checking if the time is already more than expired time or not. But essentially, as you noticed, here is the monitor pattern. It's continuously monitoring the another function and seeing what's the status of it, and accordingly it's doing its task. In some scenarios, you might also involve some kind of human interaction. The tricky thing about involving humans in an automated process is that people are not always as highly available and responsive as cloud services. Automated processes must allow for this, and they often do so by using timeouts. And that is what you can implement using human interaction pattern using Azure Durable Functions. So what you are seeing here is you are waiting for an external event called as approval, where some individual has to go and approve your budget. And depending upon if the person approves or not, you can execute different different workflows. You can check out the link that I have given down below there if you would like to implement human interaction. With that, quickly check out a couple of patterns that I already have created. Here is the function chaining event. As you can see, this is pretty much the same one that I've shown you earlier, so I'm not going to run it here. But instead, I'm going to show you fan out, fan in pattern. What it essentially is doing is here is my client function. It is starting my orchestrator called E2 backup site content, which is here. What essentially it is doing is it is going to my temp directory in my D drive, looping through all the files, creating an individual task, copy task for my each file that I have. And then it's waiting for all those copy operations, copy tasks to get over, and then it's returning back how many bytes were copied. And here are the two activities functions that I'm using. The first one is I'm getting the list of all the files, and then second, I'm copying them to the local emulators directory. Let me go you and show where here is my temp directory where I have these different copies, 19 files. If I go to storage account, local emulator, you will see I don't have a directory here right now for backup. So if I go back here in fan out, fan in, and if I run it, since it's an HTTP trigger function, I'll go ahead and copy the link and go here. Click on start. So as you can see, since it's a durable function, it has returned all those methods to me, the URIs to me. I'll go ahead and keep getting the status. I'll wait for it to complete. Let me see what's happening in my Azure Function Runtime. As you can see, it's executing all those in parallel, copying all the files. Let me see if it is completed or not. You can see my orchestrator has completed. Let me go back to my, as you can see in my Storage Explorer, it created a folder called backups. Let me open backups folder to see if it has copied all my files or not. And here's the temp directory, and here are all the 19 files. With that, let me quickly jump on to my last few slides on Azure Durable Functions. Entity functions, With that, you can read and write, update small pieces of state known as durable entities. It's all based on top of aggregator pattern. It comes with a special trigger type called the entity trigger. Unlike orchestrator functions, entity functions manages the state of an entity explicitly. Entity functions are only available in durable functions 2.0 and onwards. Here's an example. You have entity defined here called as my counter, and you are checking its value till the time it's less than 10. You are incrementing it by 1. Otherwise, you are exiting the function. And here are the implementation of the different here's the here is how your entity function is defined. You have the entity trigger binding defined here, and then you have the different functions that you want to execute on your entity. Let me quickly go back to my code and show you an entity function as well. We have last few minutes. I hope I am able to finish it off. Here is my client function, as you can see, which is triggering my counter orchestrator function. Within that, here is the entity that I'm creating. It's checking the entity ID value. If it is less than 10, it is incrementing it. Here are the 3 methods that it supports. We use context methods like set state and get state to store and get the state from the task hub for my entity. Let me quickly go ahead and run it and show you what it is doing. Oops, let me close all these. And my durable entity function is up and running. I'll go ahead and go back to Postman, and I'll go ahead and post it. As you can see, it is triggered. As you can see, my value is currently 1, and I'll run it. It will go ahead and increment it by 1. I'll run it again. This time you will see that the value is increased to 1. So I can keep running it, executing it every time, and it will keep store the state as well as get the state back at every execution. With that, let me wrap up my presentation quickly. Few things to notice: orchestrators can't do input output directly. Instead, they defer it to activities to do those IO operations. But in durable functions, starting with version 2.0, you can call HTTP APIs directly from orchestrators using the call HTTP async method. There you can implement singleton pattern using your orchestrators when you want to use orchestrations for background jobs where you need only one instance of the orchestrator at a time. You can check the status of orchestration. If it is completed, failed, or terminated, you can exit. Otherwise, you can keep it. Well,
Why
you
go?
can run. Yeah, I'm about to wrap it up in just 1 minute.
Yeah,
Please.
yeah, please.
Yeah.
Okay.
The eternal orchestrations are opposite to singletons, where you want to run the orchestrations never ending. You can use a method known as context.continue as continue as new to run your eternal orchestrations. And as you can see, the only difference between eternal orchestrations and normal ones is that you have a static instance ID that you pass to the start new async method. These are some limitations for orchestrate durable functions. They only can call deterministic APIs. If you don't know what deterministic API is, it is an API that always returns the same value given the same input, no matter when or how often it is called. For example, an API which returns current date or time is non-deterministic because it returns different values. So I'll be aware that you can only call deterministic APIs. Your code updates can break replay behavior for the unfinished executions of your orchestrations. And lastly, as I was saying earlier, it cannot do IO directly, but you can use HTTPs. Here are some of the resources that you can use for further reading. I'll share this slide if possible, and you can get all the links. I know we are out of time for Q&A, but you can reach out to me on this, any of the contact information. You can reach out to me on Twitter, LinkedIn, or send me an email, and I will be more than happy to answer. With that, that's pretty much I have for everyone today. I'll stop sharing my screen, and thank you once again for having me today.
Thank you very much, Vaibhav. So that was a wonderful presentations. So we look forward to our next interaction show. Thank you.
Thank you.
Hello, John.
Hello. Hi.
How are you?
I'm good. Thank you. We're not live yet. Or are we?
Yeah, I'm also fine, and thanks for joining with us, John.
Okay, right. Yeah.
So before we get into the sections, just let me take a few minutes to give up short introductions about you to our participants. So John has designed and implemented a computing system ranging from high-speed industrial controllers to distributed IT systems, focusing on security and high availability. And followed with that, he is a specialist in identify system for last 20 years, with a particular focus on federated identity to provide authentications and authorization solutions. Moreover, he has handled many UK projects and multinational that requires optimized IT systems. So once again, we welcome you, John, for joining with us. Also, we will be traveling with John for next 50 to 60 minutes by discussing on the topic of Azure AD, B2B versus multi-tenant apps. Notes from the field. So, John, the stage is yours. Please go on.
Thank you very much, and thank you for the introduction. So it's really great to be here talking at the Azure Community Conference. I am John Craddock, as you already know. I'm an identity security architect. I'm based in the UK, and up until a year ago, I would sort of travel the world doing consulting, and also I've spoken at very many major conferences, including sort of Microsoft Tech Eds and Ignites and IT forums. And that speaking and presenting is one of the things I really enjoy doing. I cut my teeth on building real-time controllers, and actually wrote real-time operating systems. I got involved in Microsoft in the sort of 90s, and somebody in Microsoft said, hey, have a look at this. And this was a very, very early precursor to on-premise Active Directory. I then went on to feed back to Microsoft at that stage, and we got a really good relationship. And one day I got a call from Microsoft UK, and I sort of immediately looked around the office thinking, oh gosh, what don't I have licensed? And they said, we hear you know something about Active Directory. And it was sort of like, yes. And they said, can you come and tell us about it? And that's when I really forged a very strong relationship with Microsoft. I'm now Microsoft MVP. I'm looking forward to going back around the world doing things, but I am sort of obviously a lot of it is now virtual. So let's get on. Let's have a look at the slides. And these slides are sort of my notes from the field when I had to discuss a project with a client. And, you know, should they be using Azure AD, B2B, or should they be using multi-tenant? So let's start off by actually looking at what their problem was. And their problem, or what they needed, was to solve a customer ask. They were a very specialist ISP, and very specialist because they were highly secure. They had a very select group of clients, and they had an application that those clients wanted to gain access to. And the way that they allowed their clients to gain access was basically through forms authentication. And to do that, of course, they needed to put the accounts into the accounts database for their Forms app, and that was all manually provisioned. And they were being pushed by their customers to actually come up with a way of actually doing this in a sort of more automated way. So they didn't want to do the manual provisioning. They also, the customer ask was, can we do SSO with our on-premise credentials? And that's where we got involved in looking at the project and talking to the various participants in the project. And it sort of broke down into a series of workshops, one which is sort of talking about federated authentication and what's available there, and then looking at maybe how we leverage the Azure AD and what that would do for us. and then federating with the app with the authn tenant. And when I say org-n, it could be org1 or org2 or org3. There were multiple organizations that were making this request. And then we looked and went through the multi-tenant versus Azure AD B2B. And then, of course, it was decision time. So I want to take you on this particular journey that I went through with the customer. So we started off with a workshop which was explaining what federation was. And if you look at federation, what we've got is we've got an application that a user needs access to. And what happens when you are federating that app and you're using a federation protocol, we hit the application realizes the user's not authenticated. If the user was authenticated, they would have a cookie to prove their authentication to the app. But at this stage, they don't have that cookie. So the claims aware app says, I can't authenticate you. You know, if it was an app that was doing forms auth, it would authenticate you against its own database. But here, the app has no way of authenticating you. So it sends you to a security token service that it trusts. So we're sort of through a redirect, we end up as security token service. And with a fairly complex string when we go up to that security token service, and it says, in basic terms, please authenticate the user to this application. And we identify the application uniquely. So we end up with the STS. The STS authenticates us in whatever way is necessary, and then builds a security token for that particular application. And the cookies that the security token service issues are cookies that prove the user's authentication to the security token service. So if they go back to the STS for another token, they don't have to go through the authentication process again. They can prove their authentication using those cookies. So now we've got a security token which proves the user's authentication to the application. So that's passed back to the application. The application will validate that token, and then it will return the page that it wants to return to us. And also it will set an authentication cookie that proves the user's authentication to the app. And the security token, if you think about it, is proof of authentication of the user to the application. And it may have additional data which will allow the application to authorize access. So we can have additional information in there, but its primary purpose is to prove the authentication of the user to the app. Now, I haven't talked about federation protocols at all here. And there's sort of a number of federation protocols that we could be using. WS Federation and SAML were fairly traditional protocols, and they use a SAML token format, which is in XML, and that can get fairly bulky in size. It beautifully describes all the attributes and claims and settings and things that are returned. However, it is potentially bulky. It's also potentially hard work to parse, hard work to create, hard work to validate. And so sort of the OpenID Connect and OAuth 2 protocols use a much lighter weight token, and it's a JSON web token. So it's a much simpler token format. So it's easier to work with. It's easier for the apps to work with. It's also smaller to transmit and manage. The JSON Web Token is mandated for OpenID Connect. It may be used for OAuth 2. It depends on the implementation. In Microsoft Azure, they use a JSON Web Token for the access token, which you get with the OAuth 2 side of the protocol. So the benefits of using OpenID Connect and OAuth 2 is its immense flexibility. So we might have a scenario where we have a user needing to authenticate to a website, and then the website needing to go to a backend API with permissions that have been granted by the user. So first off, if we're authenticating the user to the application, then the user will present an ID token, and that will have been gained through the OpenID Connect side of OpenID Connect and Auth2. Then the app, and this is app 1 in this particular scenario, will have an access token, which is proof that they've been authorized for access to app 2. And that access token will have had to been consented to, and normally it could be consented to by a user. So what the user does is it consents to app 1 having a certain type of access to app 2, and the user is considered to be the resource owner, owning certain resources on app 2. Well, really what it is the user has access to certain resources on app 2 and can delegate that access to app 1. So app 1 can gain access to app 2 in the security context of the user. So that's sort of OpenID Connect and OAuth2. So OpenID Connect is about ID tokens, OAuth2 is about access tokens. But then there are many different scenarios from the web API. So you might have a single page application, and the single page application is actually running inside the browser, and it's probably JavaScript. And that single page application needs to access an API. Well, that's a perfect candidate for using OAuth2. And so the SPA, or the single page app, would have an access token. And then we might have desktop and mobile native apps, and they may need access tokens. So we need to be able to give them access tokens as well. And then we could have a situation where actually we have a server inside our data center, and that server needs to gain access to an API using its own credentials. In OAuth2 speak, we refer to the app 1 in our picture at the top, and this server would be referred to as a client. And if we're using server to app 2, it would be using client credentials. So we'd be going as the identity of the server. Then the next scenario is we might have a device. It might be an IoT device, and you could think of it, as your Apple TV device or your Netflix device. And it will need an access token to gain access to the APIs where it can actually stream the videos from. So we need to handle that situation as well. And then we might have a situation where app 2, which is a web API, needs to call to another web API with the identity of the user. So the beauty of OpenID Connect and OAuth2 is there is support for many, many different application types and authentication and authorization scenarios or architectures. Now, one thing I'm always asked is, which protocol should we use? All right. And I simply answer it, whatever is needed to support the environment you're working in. If you are deploying SAML apps, all right, you will need to use SAML protocol. If you're deploying WS-Fed apps, you will need to use WS-Fed protocol. Now, if you're only just authenticating to the app, SAML WS Federation will probably work perfectly, and those protocols are going to be around for years, but there'll probably be no new innovation in them. What will happen is there will be security fixes where necessary. But if you're thinking about developing a new app and you're thinking about which protocol to use, you should seriously consider using OpenID Connect and OAuth2. So always go down that route and make sure, obviously, that it's correct for your application, but thinking new applications, OpenID Connect, OAuth2. So if you want to federate Auth for enterprise customers, what we could do is we could set it up so we build an application, and the application trusts a security token service. All right. So each org could have their own security token service. And so what we end up doing is letting the app trust each security token service individually. So the app itself when a user arrives at the application, we will have to do what's called home realm discovery and send the user off to get the token from the appropriate organizational's STS. Plus, the app itself will have to be configured written so that it can configure access and a federation with each of those STSs. So the application development becomes more complex to support that scenario. If we look at the flow, what we do is we hit the SaaS app, we go up to home realm discovery, and it says, you're from organization 1. Off you go to see organization 1. Or you might be from organization 2, in which case we'd send you to the organization 2 STS. We arrive at that STS, and what we're doing is, because of the trust relationship that's been set up, we're going to actually get the STS, after authenticating the user, to produce a security token. That security token will be sent back to the application as proof of authentication of the user, and we return the cookies. Now, if the user is on premises and already signed in, the authentication against the STS will probably be via Kerberos. So our on-prem users in Org1, Org2, etc., will have a single sign-on experience to the application. But we have to create an app, we have to create an app that actually supports multiple STSs. Plus, we will have the actual authentication protocol will be bound to those STSs. So if the STS supports SAML, that's what we'll have to use for the app. If the STS support WS Federation, that's what we have to use for the app. So we might be constrained as to how flexible we can make this. So an alternative approach is for our SaaS app to trust our own STS. So we create an STS, and then what we do is we actually, rather than the app trusting the org's STSs, our STS trusts the org's STSs. Now, the beauty of that is we can have a federated protocol between our security token service and Org1 security token service, which is maybe using SAML. We can have a federated relationship between our STS and Org2's STS using WS Federation. And then we could have, maybe also a federated relationship using OpenID Connect. That's a possibility as well. And it means that the application doesn't actually have to worry about the protocol for the federation part with the other organization. What we'll have is a relationship with our STS, and we would be able to use any protocol that we want. So the app doesn't have to think about, for Org1, I need a particular protocol. For Org2, I need another protocol. What the app thinks about is, what protocol do I want to use? And they configure that with their own STS. Let's look at that in action. So now what happens is we hit our SaaS app. And our SaaS app says, you're not authenticated. I'm going to shoot you off to your security token service. All right. That's the one you trust. That's where you're going to get your token from. And that security token service will now do the home realm discovery bit, the bit that was done previously by the application. And the home realm discovery will identify the users from a particular org and shoot the user off to that organization. Right now, what that organization is going to do is going to produce a token, having authenticated the user, obviously, produce a token that will prove the user's authentication, not to the SaaS app, but to the SaaS hosting security token service. So now we get this token passed back to the security token service in the SaaS hosting organization. That itself is then processed, and then it produces a token that is proof of authentication of the user to the SaaS app. And that's presented back, and we complete the cycle. So that's looking like quite a nice solution. So if we it's particularly a good solution when your SaaS offering consists of a suite of applications. So rather than each application having to set up a trust relationship with the organization, and it's not just us working with our application, the org is going to have to actually set up that relationship as well. Now, if we've got multiple applications, we don't want each org to have to set up for multiple applications. They can set up once with a trust relationship with our STS, and we're involved in actually setting up the trust between our applications and our own STS. So, it's a great solution for that. And of course, SSO will work as before if, because we're talking about SSO for org N users. So if an org N user is on their corporate network, they can authenticate seamlessly with their org N STS. So they won't be prompted for additional credentials. Now, if we're talking STSs, we could actually be talking about having to build quite a lot of infrastructure. So if you look at it from an ADFS infrastructure perspective, ADFS is quite a piece of work. Number one, we need to know how many servers we need to support our authentication. So we'll build out an ADFS farm. We'll have to choose a configuration database. We'll have to manage certificates. And, management of certificates invariably, unless you're really careful, quite often goes wrong. And then if we're going to expose this, if we've got a farm, we need a load balancer. And if we're going to expose it to the internet, we need a proxy farm. So we need an ADFS proxy, and that's called the web application proxy. And then we're going to need a load balancer for that. So in all, it's quite a lot of work. But if we've got a user on our corporate network, they can sign in with SSO using Kerberos credentials, because what they'll do is they'll go to the ADFS farm load balancer and they'll use Kerberos creds to actually gain access. So that actually works quite nicely, but it's a lot of work to put together a good solid ADFS farm. So our next thought was, what about leveraging Azure AD? How would that work? Well, if we look at Azure AD, we've got basically the infrastructure. We don't have to care about it. We don't need to know how many servers we need in an ADFS farm. It scales automatically. It's got scale. It's got cloud scalability. It's cloud authentication. And we're not thinking about infrastructure. What we're thinking about is managing our data. And primarily, it's going to be the user data, the application data when we register applications in there. And we might be looking at device data and all sorts of bits and pieces. But it's no infrastructure to worry about. So now, how do we manage it? Well, there are portals to manage it. There's Graph API that you can programmatically manage this as well. And then what you've got is PowerShell capability to manage it. And then, of course, you can take your users from on-prem and sync them up into the cloud itself. So, the infrastructure problems have absolutely disappeared in terms of managing that. So what does it do for our users as soon as we're in this space? Well, it opens up a whole new world for our users, and that's the world of SSO, single sign-on to pretty much anything you desire. Azure subscriptions, Microsoft 365, your own apps that your organization publishes, partner apps through B2B processes. And there's an application gallery which allows you to do integration with thousands of SaaS apps. So, now you've got your single point for SSO. It's your Azure AD. How do you get an Azure AD? Well, if you've got Microsoft 365, you already have one. All right. But you can create another one if you want, or you can go in, with no M365 subscription, go in and create your own Azure AD, and then you become a tenant in a multi-tenanted Azure AD space. So it's the Azure AD service. And the tenant is actually identified by a display name. Well, it's not really, the display name is shown. The identity comes from a tenant name, which is a unique name in the Azure AD space, and a GUID. The GUID and the tenant name can't be changed. The display name actually is really important because that's what users see, and it should really be representing your organization. So we've got our users suddenly up into the Azure AD tenant. But if you remember, what we were being asked for is our on-prem users, right, can actually authenticate, right, with SSO to the SaaS hosting application. So what do we need to do? We need to be able to authenticate to Azure AD with on-premise credentials. So how do we do that? Well, number one, we synchronize our users into Azure AD. So our on-prem users from our on-prem AD are now synchronized into Azure AD. And then there's a number of options for how they get authenticated. One, which is really the preferred way of doing it, is to use password hash synchronization. And if you're not using password hash synchronization, I would really look at it because it's actually quite a safe synchronization. It got a very bad name at the beginning because it was called password synchronization. And security officers said, no way are you syncing my passwords up into that Azure cloud thing. And reality is, it's always done a pretty safe way of doing it. What it does is it takes your on-prem password hash and then it pushes it through a iteration of SHA-256 or HMAC SHA-256, and it goes through that 1,000 times. So the hash that actually is put into Azure and stored very, very safely is actually very strong hash. And if it was stolen, it would be extremely difficult to use it for attacking your on-prem directory. And if it was stolen, well, that would be a real challenge because it's stored very securely in the Azure AD data centers. So if you log in with password hash synchronization, you are being validated against data stored in Azure AD. Another alternative is to use what's called pass-through authentication. Here you gather the username and password in a cloud dialog, and the username and password are passed down to an on-prem authn agent. And what that agent does is authenticates the user using the information that's passed down against on-prem AD. And that does an explicit logon against on-prem AD. The third alternative is to use federation with ADFS or a different STS. And that's a possibility. A lot of people are now moving away from that and moving to password hash synchronization. But it is a possibility. If someone said to you, that's our new design, that's the way we're going, I would really question it. If someone's looking at a new design for Azure AD, syncing your users up there and getting your hybrid user is an on-prem user and which is synchronized into Azure AD, I would seriously think password hash synchronization. But you can federate with an STS if you want to. How do we add SSO? Well, if you've got a federated solution such as ADFS or STS, then it will just use Kerberos. If a user's on the corporate network, they will just automatically SSO using Kerberos. You can authenticate against Azure AD using Kerberos, using the single sign-in option, which is an Azure AD Connect option. And it uses Kerberos if possible, but if not, it will fail back to PHS or PTA. So what you do is you choose PHS, which is password hash sync, or pass-through authentication, and then say, I would like to use single sign-on. If single sign-on works, because you're on the corporate network and your browsers are all configured correctly, then it will use Kerberos against Azure AD. If it doesn't work, it will fall back to either PHS or PTA, whichever you've got arranged. The other thing is to take your Windows 10 and actually do SSO via a primary refresh token, which you get once you've joined to Azure AD. And that gives you a really, really good single sign-on experience. Okay, so that's a sort of intro to Azure AD. So our next thing is looking at federating the app with the org-n tenant. So we're going to try and look at having all our organizations having an Azure AD. So if we look at this, we've got our orgs, our different orgs, and what they're going to do is they're going to have an Azure AD tenant, and they're going to synchronize their users up into that tenant. And now what we can do is we could, all right, we could do there were two scenarios for our federation. We could actually federate with our app directly with those tenants. Or what we could do is add another STS. If we were hosting multiple applications, then we would definitely want to host another STS. But it would be possible to do it this way. The problem is with this way, we're going to have to actually register the application in each of the Azure AD tenants. So there's a bit of work for each organization to do. But the benefit for this, for our organizations, there are no on-premise STSs. And the users could be automatically provisioned. And there's a industry standard, which is called SCIM, which is a system for cross-domain identity management. And we can provision and deprovision users automatically into the database. And then the other advantage of doing this is the org-n, the different orgs could actually invite external users into their Azure AD tenant. And those external users could potentially gain access to the application. So, that again has a lot of flexibility. So if we look at the pros and cons of federating with each org's tenant, so we look at the pros. Number one, there's no requirement for an org that deploys AD to have an on-premise STS infrastructure. So that could be good. Of course, they might already have one, but if they didn't, they could use it as Azure AD. Provisioning, WSGIM, all right, as I say, industry standard APIs for provisioning users, deprovisioning users. And it also would be possible to federate with an on-premise STS for orgs that don't want to use Azure AD. So that's a possibility. The cons, of course, is it requires the org to create an Azure AD tenant and deploy Azure AD Connect for synchronization. If they've got a Microsoft 365 subscription, they'll already be doing that. But if they haven't, that's a piece of work for each org. And then it also requires each org to deploy the application in their tenant. So they will need to do that. And the hosting company's app will need to manage multiple configuration protocols. So, there's a few drawbacks there. But if we look at multi-tenant apps, what do they bring to the game? So a multi-tenant app is an app that is created in one tenant and marked as a multi-tenant app. And if it's a multi-tenant app, it can receive tokens and codes issued by any tenant, right? So any tenant can actually authenticate to that app. If it was a single tenanted app, then only users from that tenant would be able to gain access. So, single tenant, the app will be registered in one tenant, and only users from that tenant will be able to gain access. But if it's marked as multi-tenant, any Azure tenant can actually produce a token which will prove the user's authentication to the app. So how does it work? Well, you hit the application, you get redirected Now, instead of being redirected to the tenant where that application is configured, what happens is you go to a common endpoint. And the common endpoint actually literally has the tenant ID replaced with the name common. And the common endpoint you can think of, if you like, as a multiplexer. So you arrive at the common logon endpoint and you enter your username. And Azure says, aha, you are from a particular tenant. And inside the cloud, it routes the user to get authenticated by that particular tenant. So from the username, it's identified which tenant the user's from. It doesn't redirect the user and say, you've got to go off to this tenant. What it does is it does it through an internal process. And I call this cloud magic. So you go through an internal process and we arrive at the tenant. And remember, as I said right at the beginning, when you actually go up and you redirect to an STS, the redirect string is actually saying, please authenticate the user to this application. So we arrive at that tenant. And when we arrive at that tenant, so we've arrived at tenant B, it says, please authenticate the user to this application. Well, tenant B can authenticate the user because the user is from tenant B. That's what the multiplexer has done. It's found the right tenant. And we've arrived there saying, please authenticate it to the app. And tenant B looks in its directory and says, that app doesn't exist. And it could give you back an error message. But before it does that, it checks. And this is, again, the tenant doesn't have to think about this. If you're configuring tenant B, you don't think about this. It's happening through cloud magic. So it's the Azure AD service that is doing this. What happens is it says, this particular app you want to authenticate has been defined in tenant A. So what happens is there's a template in tenant A from which a service principal can be created in B. And that service principal allows B to issue tokens for that particular application. And that just happens automatically. You have to consent. Consent will be required. You're going to consent to this happening. But once that's done, we've now got the ability for tenant B to issue tokens that are acceptable to the application and will prove a tenant B's users access or authentication to the application. So that is what multi-tenant is about. Now, if we think about this in a bit more depth, the multi-tenant app, you may decide you create a multi-tenant app and you want everyone who's got an Azure tenant to be able to use it. And Microsoft create lots of those, all right? A lot of their apps that you use on a regular basis. And you may, if you're doing dev, you may have used Graph Explorer. Graph Explorer is a multi-tenanted app. And if you look in your enterprise blade, you will see that service principal after you've used it for the first time. Microsoft wants everyone to use Graph Explorer, so there's no restrictions. But what if you were creating an app that you wanted only certain tenants to use because only certain tenants were licensed? Well, what you'd have to do is you would have to control the access at the application level. So the application will require to create a subscription list of tenants and users that they want to actually access the application. So, there's no control. Tenant A, which we've got in this scenario here, can't put any control on who can access the app. There will be any tenant can produce a token to prove a user's authentication to the app, and it's down to the app to control access. Let's have a look at this, and we're going to look at this as a demo. We've got multi-tenant apps in here, so let's kick off. And we're going to go to this application at the moment, and I'm going to sign in with hybrid flow. And don't worry about what the flows are, that's not particularly important. And I'm signing as one of my users from my tenant. And I signed in here. And what we can see is we've actually got in here we've got an audience. That's the identifier for the app. So it's A86. And the token has been issued by this tenant, which begins 280. That's the tenant identifier. There's an ARM parameter, says we've been authenticated with a password. And coming down here, we see our user. That's our user from our own tenant. But what if we bring in a user from a partner organization? So here, we're going to use a user from a partner organization, and we're going to use this character here, which is Tim at 5.partners. We're going to sign in with hybrid flow, and this is signing in to the tenant. And let's see what happens. So we come in here, next on there, and we enter the password, and let's see what happens here. We go to sign in, and you get this error message. And it's saying these error messages look horrendous, but actually, if you read them, user Tim at 5.partners XTS Hub from identity provider 3E2 does not exist in the tenant. All right. And that's quite correct. What's happened is we've hit the application, we've gone to the tenant to get authenticated, but we're a partner user. So what we need to do is actually get away from that. We need to go to the common endpoint. But first of all, let's just have a look in the Enterprise Blade. This is the partner organization that we've got here. So this is the partner organization's tenant, Enterprise Blade. There are no service principals showing. All right. So what we'll do now is we'll actually go and see what happens when we actually sign in to the common endpoint. So we're going to go back to the application, and we're going to sign in this time to the common endpoint. So it's a multi-tenant endpoint. And if you, we're going to select our user, but before we do, look up here, it's saying common. So rather than having a tenant ID in the address bar, it's going to common. And we're going to go as Tim. And now Tim is going to be authenticated by the partner directory. He'll have to consent, so he accepts the consent here. And then what happens is he's in, all right? And if we look at this particular token, the audience is exactly the same. It's exactly the same app, but the app is marked for multi-tenant. The issuer this time is 3E2, so a different issuer. And it's been issued by the partner tenant. That's who's issued the token. So if we move on from there, what we can do now is do a refresh in here, and what we'll see is if we just do just switch to user settings to do the refresh, we've got the token for OIDC Azure 2. So that service principal has been created, and it just all happened automatically. So that's what a multi-tenant application will do for you. So that was just a sort of quick demo of what a multi-tenant app looks like. And what we need is just the pros and cons. So the pros are supporting authentication users from any tenant. Organ does not need to do to configure the app in their Azure AD. So any Azure AD tenant user can use it with no configuration. The hosting company deploys the app in their tenant. And again, it doesn't need to think about setting up for multiple identity providers. So that's all good news. The cons are the application access has got to be controlled by the app. So the tenant that is doing the hosting can't do any control. And the hosting company's tenant cannot control access, cannot apply conditional access policies. And it also only supports users from other Azure AD tenants. So those are the cons to that. So if we go on and now look at Azure B2B, if we look at B2B, what we've got with B2B, we're going to invite a user into our tenant. And when we invite them in, they will become an external user, or if you like, a guest user in our tenant. And when that user goes to the application, they don't go to the common endpoint, they hit the app, they're redirected to tenant A. And what tenant A is detects the fact that they are an external user, and they'll figure out that the tenant B needs to authenticate them. All right, and again, that happens automatically. Now, the beauty of this is that our external user can be put into groups, assigned roles, assigned conditional access, control, and so on. So tenant A is in full control of how that user gets access to the application. So if tenant A wants that user to have MFA to get access to the user, they can impose it. So if we look at it, the B2B flow is we hit the app, we go with the sign-in redirect, takes us to tenant A, and what we then do the home realm discovery, and tenant by literally putting in our username, tenant A automatically through cloud magic, this is handled by Azure, says, that user's home directory is B. We'll get them authenticated by B. They're authenticated by B, and then what happens is we get a token back, and we present that token, and the user's authenticated. So the sign-in is via tenant B. The token issued is by tenant A. And that's the beauty of B2B. So there's no sort of multi-hop federation dance or anything like that. The next thing is, in terms of who can come into our tenant through B2B process, we basically invite users. They'll get an email saying they've been invited. We can have users from any Azure AD tenant. That's quite possible. We could have users from using a Microsoft account, so that's the Microsoft personal account, Outlook account, etc. There's actually implicit trust already built in. We can set up a trust from our tenant to Gmail. We can set up a trust from our tenant to Facebook. We can set up what's referred to as an indirect trust, referred to as a direct trust with other organizations' SDSs. And if a user doesn't meet any of those criteria, what we can do is use what's called one-time passcode. So if the user's not in an Azure AD, doesn't have an MSA, doesn't have a Gmail, which we've directly federated when we've directly federated with Gmail, and doesn't have Facebook when we've directly federated with Facebook, or doesn't have an org-n with direct federation set up, then OTP is used. Microsoft used to create, well, they still do for the moment, create what was called viral tenants, and B2B was slightly messy. Big cleanup. Viral tenants will stop being created starting November, probably mainly in January of next year, and you'll automatically switch to using OTP when we haven't got a different solution. I did a deep dive on Azure B2B. If you want to look at it, there's a reference there to my blog. Okay, a little demo on B2B. So let's look at that. And what we've got going on here is we're going to finish cleaning up on this. So we close off our window, and what we're going to do is we're going to shoot over. This time we're going to use our partner. Tom.5 is actually in the partner directory, and we're going to sign in directly to our tenant, right? So no common endpoint. We're coming in as the partner, sign in, and through Cloud Magic, he's going to be authenticated by the partner cloud. He's going to have to consent, so he's consented. And what we've got now is an access token, which actually shows that he is his audience. The audience is the app again. He's come from. It's been issued by our tenant. Why? Because he's a guest in our tenant, and we can see that he's Tom from the partner organization. Now, if you don't have someone in that tenant and you've got OTP enabled, what we can do is automatically revert to using one-time passcode. So I've got Peter. He's not actually in the partner tenant. He has a partner email address, but he's not in the tenant. OTP is enabled. So let's see what happens. So we're going to go off again, signing in directly to the tenant, and we're going to have to sign in this time as Peter. So in we go. And now we've got enter a code. And so Peter has been sent an email to get a one-time passcode, and he grabs his email. Once it's arrived, there it is. He opens up the email, grabs the passcode, and then what he'll do is he'll sign in with that passcode. So sign in there, and we can accept that. And now he's in. And if you have a look at this, you can see that, again, the token has been issued by the hosting. The hosting directory is the one that invites the users in. The hosting directory is the one hosting the app that they want to share. And you'll see that Peter's come in, and he is in the authentication method is OTP. So that's the authentication method for Peter. We'll do one other scenario. We're going to invite someone in. Well, they're already invited in, actually. And we're going to log in. Again, we're logging into our own tenant, the hosting party's tenant. And what we're going to do is allow a Gmail account. So we're going to host. So we put in our user, which is a user from Gmail. So xts.john@gmail.com. And next on there. And then it's taking us to our organizational sign-in page. And this is Gmail. And actually, we're already signed in, but we need to verify our creds with Gmail. So we just get a verification code. And once that's got, yep, okay, so we got the verification code. We'll pop that in, and next on there. And now we've come in with a Gmail account. Again, we have to accept the consent. And if we look down here, what we'll see, if we look at this token, what we've got is, again, the token has been issued by the hosting Azure AD tenant. But the user, there's no ARM parameter because we don't know how the user was signed in, but we do know the IDP was Google, and we have this rather strange, unique name, which is google.com hash, and then the Google identifier. So yeah, there you are, the ability to bring in people from a Google if you wanted it. Okay, so that's a sort of short demo of B2B. And the next thing is just to summarize that is the pros and the cons. All right, so our pros: complete management of the application via the hosting tenant's control. So if you want to do conditional access, do MFA, you can do it. If you want to assign additional roles and claims for that particular user, you can do it. Very simple and very easy to block access for that user. Okay, and control of who's allowed to invite an external user, we can do that, and we can control which domains an external user can be invited from. So doing the B2B, we've got a lot of control available to us. There's no requirement for Org-N to deploy the SaaS app. Okay, so the Org-N doesn't have to think about doing anything about the SaaS app. If you are not using, if Org-N doesn't have an Azure AD, we will need to configure a direct federation with them, assuming they've got an STS. So we'd have to directly federate with them. If they didn't have an STS, they could come in through using OTP. That would be possible. But the other thing is, we're assuming that an enterprise organization probably has an STS, probably has an Azure Active Directory. But if you've got a small shop, so a small shop might use Gmail. I know quite a lot of organizations that are small consulting organizations, and they're using Gmail accounts. Well, you can support that because you can federate your Azure AD with Gmail. And again, if you don't do that, they can come in using one-time passcode. What are the cons? The cons are the hosting company needs to manage the external users. So there'll be an external user invitation process. You will need to think about licensing for the external users as well. There's 2 licensing models that you can use. But the hosting company does not need to manage the external users' password and password resets and things like that. So that's all pushed off to the org-n, so the org-n management. So there's a lot of advantages from doing B2B. So having gone through all of this, gone through all the discussions with our particular client, it came to decision time. And decision time was where they decided how they were going to do it. And what they decided was to use Azure B2B using OpenID Connect and OAuth 2 for the application. The B2B invitation process that they had to go through, sending out invitations, was seen by them as a personal service to their enterprise orgs. So they could send out a very nice customized email. If you do it through if you invite someone in through the portal, there's an automatic email that goes out from Microsoft, but you can programmatically generate the invites. And then having done that, you can send out an email to the other organizations from your own alias. B2B was considered best for groups, roles, user assignment, and MFA and conditional access if they wanted to use that in the future. Then they thought, okay, is this going to be a showstopper for some of our orgs? And what they discovered is when they did a survey, 75% were already using Office 365 or M365 implementation, or they had an Azure AD in use. So that was a good number. The remaining orgs could be accommodated either by adopting Azure AD or direct federation. So a lot of the remaining orgs already had security token services that they could directly federate with. 2 small shops wanted to use Gmail, so that was accommodated as well. And dev time was considered to be a lot shorter because the app, the SaaS company, the hosting company was actually having to create and manage, only needed a single federation with their Azure AD. Rather than using a sort of multi-tenant app, they decided to federate directly with their Azure AD. Licensing, it's not huge, but the additional cost for licensing was not seen as an issue, as they decided to actually just add that as part of the SaaS app licensing. They were already licensing these people to use the SaaS app. And that was it. That was the end of the journey. Very happy customer. It was a really good consideration of the 2 aspects. If you're interested, I do everything I've just covered in a lot more detail, and in a sort of an identity masterclass, which I've been running online around the world. Full details at learn.xtsseminars.co.uk. But that brings me exactly to my end of my slot. I hope you found the session useful. It's great being here with the community, and thank you for joining the session. And thanks very much.
So, hi, John. Thank
Hi.
you very much for your wonderful presentations. And we had a great sparing your time, most valuable, which efforts took to get more knowledge from your end. So it's amazing session from your end, John. So thank you once again. We look forward to our next introduction show.
Yeah, well, thank you very much for inviting me, and maybe I'll see you another time, and maybe there'll be a live event one day, which will be fun, because I'd love to see you all and meet you.
Thank you,
Yeah,
John.
thanks a
Thank
lot.
you.
Thank you.
Okay, have a nice day. Bye-bye.
Bye. Bye-bye.